Good morning, everyone, and welcome to DappCon 2024. I'm your moderator this morning. My name's Chantal. And without further ado, I'd like to welcome Gnosis founder Martin Koppelman to the stage to give the opening speech.
Yeah, welcome also from my side. So, opening speech for the fifth DappCon. Yeah, we want to talk about, again, what are we doing, why are we here? And I think it is quite connected to what we call Gnosis 3.0. Yeah, a vision to work on large and important goals in a decentralized way. So in various teams that are independent of each other, but still cooperate, coordinate, and work and are kind of connected through shared ambitions and visions, but also economic incentives. So what we are working on is full stack decentralization, how we call it. And we think it is important, or what is really the thing about decentralization? We would say the two core ideas are ownership and agency. And I want to go through six points to demonstrate it. But just again, roughly, the idea of those various teams and various projects working together on shared goals here is represented in our this visualization. But what are really the six things that connect us and that also most of the talks and presentations here during the 3 days will be about? So if we talk about ownership and decentralization, the very first thing you need to own for everything to work is your account, your identity. And I recently had an interesting thought experiment, and I think I would invite everyone of you to think about it yourself. What is the oldest account you are owning, or you're using at least? So kind of think about maybe your bank account. I personally had a bank account. I got a first one when I was 14. I don't think I have access to this anymore. I kind of probably lost it along the time. And then I don't know, I had kind of in the very early days, there was in Germany a Facebook clone, and there I had an account that was quite important to me. But again, I lost it over the years. So what is an account that you can actually own yourself? And obviously, account abstraction and safe and kind of those are the things where we think that is really the basis, that you have an account that you actually own. Of course, here are the projects, and there will be a couple of talks during the next days. Also, account abstraction on Ethereum became more of a topic again, and on Thursday there's even SafeCon across the river. So second thing is, if you have this account that you own, in our view, ideally you should own it on a chain where you also have ownership of the chain. And we still think it's not just about kind of making it trustless potentially with layer 2s. We still think it's about ownership as well. So you should have ownership, and you should have at least the ability to have ownership of the things you're using. And of course, running your own node and being not only owning but operating a chain, we still think is a big desirable goal. So it's no news that we want to advance the cause of being a validator yourself and enabling that. And again, there will be talks and presentations in the coming days on that. So the third thing is, if we have ownership, and ownership is kind of represented in the form of tokens, there need to be efficient ways to exchange ownership, exchange tokens. And of course, that should be structured in a way where the user interest is put first. And again, there will be a couple of, there's at least a presentation for CowSwap, and kinetics are two here at DappCon. And number 4 is maybe one of the most ambitious ones, is Circles. And Circles is the project I personally am probably most passionate about, and it was kind of a project that brought me into the space. So, so over 10 years ago, I was fascinated as many who were early with Bitcoin, because that was what existed back then. But at some point I asked myself, would humanity really benefit if we would all kind of transition to Bitcoin? And that was still not obvious to me whether that is the case. So, I mean, I would benefit, for sure. So currently, probably 1 or 2% of the humanity hold Bitcoin. So if the whole world would transition to it, well, those 2% would certainly benefit a lot. And Circles kind of tried, or still tries, to take some core ideas of Bitcoin, decentralization, no central authority, but have a system where I would give a clear yes to this question, would say yes, humanity would benefit from moving to it. So very roughly, the rules in Circles are that everyone who joins the system issues 1 unit per hour. So the issuance is, well, decentralized. And again, there will be a talk about Circles. I will do a talk on Circles on Thursday, so more to come. And you saw kind of here the transition of the logo. So again, a little bit more history. We launched it 3 years ago, and went viral for some time, but still tech was not working. Kind of, it fizzled away, and now we are working on a larger relaunch, and that will also be a scheme here at DappCon. So a money system where that you own in a way. So the 5th scheme is we need to make all those things actually work in the real world. So it's not enough to have those ideas, and I mean, well, most of those ideas are not new. We have been in the space for many years now, and for the longest time, those ideas still were or are isolated. We have our bubble here, our blockchain bubble, but in many cases we still haven't done the leap to get it working in the quote-unquote real world. And that is certainly what in this case, as an example, Gnosis Pay is about. And we are quite happy and proud that we were able to release this earlier this year. And again, there will be specifically tomorrow morning a couple of talks related to payments and specifically Gnosis Pay. So yes, we are finally at a point where I can use a regular card in the real world, and it is connected to all the things I mentioned before, to the identity I own, to the chain I have ownership in, to the soon the money system I own. So finally, or number 6 is privacy. And that is certainly one of the topics that is still, maybe least developed. Or I mean, the technology is there, but it's certainly not rolled out in any meaningful scale. So connected to Gnosis Pay, if you now do actually transactions of your daily life on chain, this obviously becomes an even more burning topic. What are the things you want to reveal, and can you choose what you reveal? And 3, or at least 2 projects that will do presentations are Gnosis VPN and Shutter. So Gnosis VPN, I think, explains itself what it is. Shutter is the idea that you can encrypt and have at least short-term privacy on the transactions you are sending. So those 6 topics are topics, well, that have been around for quite a while. And again, we believe working on those topics should make the world a better place. But there is certainly now a 7th topic that simply cannot be ignored. I think if you think about technology and how it impacts society, you absolutely need to be thinking about AI as well. And here I would say our kind of understanding or intuition where the journey should go is, at least for me, much less developed. So I think it will be extremely important, but I don't have the clear answer or vision what exactly we should be working towards too. So I mean, that is one attempt to say, I mean, clearly I don't want to say a few AI systems that are controlled by large entities kind of dominate the world essentially, and if users or people interact with them, then it's not taking the user interest first, but the company's interest. That's certainly not what we want. Certainly also don't want that, frankly, AI will be killing all of us, and I honestly think there's a decent probability of that, and here in the morning we will have a panel about exactly that question. So here on AI I have less clear opinions, but it's very clear we need to pay attention to it. And there are a bunch of projects here that are also presenting their work. Okay, so those are the 7 goals that I would say, almost everyone who is presenting and on this conference is in some form working towards or providing some part of it. So the last thing I want to show you is now a project we have been developing, and last DappCon I already mentioned it as Gnosis wallet, but today is the day where we want to give it to you to try, or kind of make an early release of it. And it is of course combining almost all the things I just mentioned. So it is meant to be a wallet that hopefully in the not too far distant future, I always say my mom can use, but still that adheres to all those principles. So an identity that you actually own, it will have the circuits integration. So you're very welcome to scan this QR code and try it out yourself. So few more things. One of the important things it uses is this semi-new concept called passkeys. A way to kind of to have keys that are much more native in your operating system. So long story short, a main differentiation factor will be that if you onboard, you don't have to write down a seed phrase or anything. You will just use passkey. It will create an identity for you that is then controlled by this passkey. And of course, it is nicely integrating to many of the other things we are building. All right, so looking forward to 3 days of DappCon and handing it over to the next speaker. Thank you.
Okay. Yeah. Thank you so much, Martin, and for taking us through the 7 goals for Gnosis, and also the announcement of Metri. I think I speak for everyone saying that we are so excited and looking forward to trying it out. So I'd like to take this time to welcome our next speaker, Ismail, the co-founder and CTO of Celestia Labs, giving the talk titled Build Whatever with Celestia Underneath.
Hello. First of all, I want to give a shout out to the whole Gnosis crew for this amazing event, and thanks for having me. I'm going to talk about how to build whatever with Celestia underneath. First, a few words about myself. I'm Ismail Kofi, co-founder and CTO of Celestia Labs. I started my crypto journey roughly 10 years ago, basically in academia at EPFL at the Decentralized and Distributed Systems Lab. I was also part of the team that launched the Cosmos Hub. Enough about myself. This is the things I want to cover today. Introduce Celestia and modularity for those that are not familiar with these concepts or the project. I want to show you how today, like a few ways how you can build whatever with Celestia underneath today, and highlight some like early community and a little bit go into support structures, and at the end, Q&A. So what is Celestia? What is modularity? When the first blockchains came about, when Bitcoin was introduced, the paradigm was that every chain, like every application, has its own chain essentially, right? And every chain does everything. Like it does consensus and the business logic, the state machine, the execution of that business logic. So in Bitcoin, that application was payments, obviously. And there was like Bitcoin script as a very minimal execution environment, and it used Nakamoto consensus. And then Ethereum came about, revolutionized having this notion of like a world computer where you can execute any program, essentially. Now uses different consensus, Gasper consensus, but they're monolithic in the sense that both these chains and all the chains in that era basically did everything at once, the business logic and the consensus, right? The only way to launch a new DApp back then was you basically forked Ethereum, then Namecoin was introduced, and so on and so forth. So before the notion of modularity or modular chains or modular blockchain networks were introduced, there was this seminal paper by Vitalik and my co-founder Mustafa and Alberto Sonio. The motivation here was actually to scale Ethereum and to make light clients more secure. And Mustafa took this idea and spun it even further and said, like, what if we, instead of trying to make sharding possible and so on and so forth, what if we can introduce a layer 1 that does only the most basic things, which is consensus and data availability. In the previous paper, there was this like data availability problem formally explained. There was a new mechanism introduced called data availability sampling, which makes light client more secure in the sense that they can verify that data was published. And this paper says, like, okay, let's take this and make it its own chain. So the core idea, as I mentioned, is instead of chains doing everything, as mentioned before, you split it up into like different layers, into different chains. So you have like the data layer or the consensus layer that only like focuses on that, and the execution, the business logic now is in a different chain, like in a roll-up chain or more generalized in an execution layer. So basically these things that lived in one chain are now decoupled into multiple chains essentially, into like multiple specialized layers. Yeah, conceptually, as like I'm repeating myself a bit here. Conceptually, monolithic chains, like they have consensus and execution in one chain. Sometimes, if there's like Ethereum flavor or like Solana, they come with a virtual machine such that you can run smart contracts on top. In modular blockchains, though, you have a data and consensus layer and a large zoo of like different execution environments that can also be EVM, but they can also be your own flavor, something highly specialized. They can be like a Cosmos SDK app. They can be layer 2s, layer 3s, using your favorite Ethereum stack or whatever you can imagine. So I keep saying these words, modularity and settlement execution layer. I briefly want to go into detail what these are. What are the things that every chain, like every monolithic chain does? They are execution, settlement, consensus, and data availability layer, which in the modular stack get decoupled or decomposed into separate layers. So what is actually consensus? Like consensus in its very basic form is just ordering of messages, arbitrary messages. The consensus layer does not inherently need to know what these messages are. They're basically blobs, right? Opaque blobs that get ordered and reach consensus on that order. The data availability layer, on the other hand, ensures that the data that was published, you can verify that it actually exists in the network and was published. So these arbitrary messages that get ordered must be available to you such that you can like verify they were published. And then the execution layer. Oh, actually, yeah. A brief detour to the Bitcoin white paper. Like these ideas are not like entirely new. It just, we didn't know how to do a verifiable data availability before data availability sampling. But like even in the Bitcoin paper, this notion of like ordering messages, timestamping them, and having them widely published was introduced. So what is data availability sampling that I also mentioned before? Data availability sampling is a technique that allows you to verify that the block was published without having to download the whole block. In fact, you download only a very small portion of that block, right? Like you can download like less than 1% and have almost 100% guarantee that the whole block was published. And why does this matter? It matters because for the execution layer, you take this data, these arbitrary messages that got ordered, and they get executed, right? They are the actual, like, the state transitions actually happen on the execution layer. Like, very simple example is account balances and transfers. You do a transfer, account balances get updated, right? Like, that happens on the execution layer. So I also mentioned, you may wonder if it's like arbitrary messages that get posted on the data layer and the data layer is not aware of what these are. You might wonder, like, how is it guaranteed that the transactions that are posted or the blocks that are posted on the data layer, how is it guaranteed that they are valid? There's roughly like two approaches here. One is what is now called optimistic rollups, basically via fraud proofs. So you post the data, you assume that the block producer or sequencer of the rollup is non-malicious for most of the time, but in case they post an invalid block, every node that like downloads the whole block can easily generate a fraud proof that then even light clients or light nodes can then verify. There's a different approach, which is like validity proofs, where you also post some cryptographic proof that the state transitions were valid. And this is often called ZK rollups because you post like ZK proofs for validity. So you have this, like you have different trade-offs, obviously, but you have the same guarantees that the transactions are valid, but you post the data somewhere else. Another layer that I mentioned is a settlement layer. It's essentially a specialized execution layer that does a bridge between different other execution layers. Like, very simple example, Ethereum is used as a settlement layer, obviously, for many rollups today. Again, using fraud or validity proofs. So what is a modular blockchain? A modular blockchain is a chain or a network that outsources at least one of these tasks, right? Like it outsources at least execution, settlement, consensus, or data availability. It doesn't handle that component itself. And if you think about it, it's actually very similar to how the web evolved early on. When you, in the 90s, when you wanted to host a website, the only way to do so was via a physical server. And similarly, as I mentioned before, in the crypto ecosystem, the only way to deploy your DApp was to launch your own chain using your own consensus. In the developing web, you could use hosting providers, shared hosting providers like GeoCities. I don't know, maybe people are old enough to remember these things, but you were basically tied to like choices that these hosting providers provided for programming languages like PHP or Perl even, using some CGI interface. Similarly, in the crypto space, the idea came to existence of this like shared smart contract environments where you could like deploy your application using like a smart contract blockchain, like Ethereum, Near, Solana, and so on. In the modern web today, websites run on virtual machines. Like they share physical machines, but they run in virtual machines. And similarly today, we basically see this evolving in the crypto ecosystem as well, like in Ethereum and in Celestia as well, is dApps run on application-specific chains that share consensus layers, right? Like Ethereum rollups, Celestia application, like every application is built on Celestia, that's true. And we see that this paradigm is used more and more in the modern crypto ecosystem. So what is Celestia? Celestia is basically the first modular blockchain network because it's stripped down to its core components. It is a chain that only handles consensus and data availability and is specialized for that. And execution like happens completely somewhere else. There's even no settlement layer. There's a very minimal state machine that for the chain to function. So there's like transfers, proof of stake, nothing else. You might wonder, like, okay, this sounds all fine and like from a theoretical point of view, what are the benefits of that? So in the last cycles, so to say, the way people thought about scaling were either like super complex, or many new chains came about and said like, okay, we're gonna fix scalability. Here's a solution. We're gonna do something better, like a new virtual machine. We do parallel execution, or I don't know. They promised better scalability, and what happened there is basically you had to copy this whole ecosystem that existed that already existed in like the established chains, and then either these new chains fail to gain traction and like become less relevant, or they are actually used a lot, but then they hit scalability limits and they get congested. Transactions either get expensive or you don't get them included in the blocks and have to retry a lot. So and that continues, like that that used to continue, and we want to basically break this cycle using modularity. Because we basically remove the main bottleneck from the layer 1, right? Like you move that by moving execution out of the layer 1 and having like specialized dedicated compute in the rollup layer instead, that makes it possible for actual scalability to happen in the sense that, yeah, there's like specialized layer that execute for your DApp specifically in the way you want, in the way you need it. And there's also a nice property that with this, theoretically, you can have like massive blocks because the more rollups exist, the more light clients there are, the more difficult you make it to make what is called a data withholding attack, because light clients can actively contribute to the network by making block reconstruction possible as well as a fallback. So this is important if you really want like mass adoption and everyone using like if it actually spills to the real world, as Martin said before, then you want a system that can actually scale beyond just one layer 1 on like one world computer. You may wonder, right, like that's also, like everything is converging in that direction these days, right? Like when we introduced this like data layer and the notion of modular blockchains, it was like first frowned upon and like not fully understood, but today is like everything's converging. And then like even in Ethereum, you have obviously blobs and the last upgrade. You may wonder, like, why is it even necessary? Like, if my favorite layer 1 does this already, I think having a specialized layer that only does data availability is still relevant because of the specialization, it's still more cost efficient. Your application is not competing with other applications for settlement. It's purely data availability. So there's this page from a team called Numia, datalenses.zone, where you can calculate for your application the cost savings even after the last Ethereum upgrade. So besides cost saving and scalability, you get a lot more choices, right? Like you can mix and match these different modules like Lego pieces together. Of course, that also can bring more complexity, but it doesn't have to and can be abstracted away. But like, for example, you can use Celestia today as a building block to build your Ethereum layer 3 or layer 2 by using Ethereum for settlement and consensus and get like very high security guarantees there and use Celestia purely to post your data. And your chain does only do the like highly specialized execution that you need. And there's other, right? Like your chain can also be a settlement layer for other chains. Your chain could be a rollup that uses such a settlement layer, or your chain could be what is called a sovereign rollup that is basically launching your own chain without the burden, without the overhead of launching your own proof-of-stake network. It's more like launching a Cosmos zone, but you don't have to launch a proof-of-stake network. So what are the options concretely today? You can, like, I was told that the audience here will be very Ethereum focused, so you don't have to, if you don't want to, you don't have to learn anything new. You can use your favorite, like EVM stack, write your code in Solidity, for instance, use Arbitrum Orbit or Optimism's OP stack to build on Celestia today. You may wonder, wait, if I use these Ethereum stacks, do I still have to interact then with my layer 2 or layer 3 directly with Celestia? Yes and no. You have to post data to Celestia, but for the security and like to verify that this data was published, you only interact with a smart contract on your favorite EVM, like Ethereum or Base or whatever. Or Gnosis chain could also be. Like there's a project from Succinct called Blobstream X that makes it possible to basically have a light client of the Celestia chain on the EVM chain, and you have like ZK proofs, and you only interact with that smart contract. So I think the most convenient way today to launch your own chain on Celestia or build whatever with Celestia underneath is you use a rollup as a service provider. This literally, you could think of it as like AWS, but decentralized in the sense you have the same convenience, one-click deployments. You just choose a few options, and this is perfect for like teams that are early and want to like iterate quickly, launch a test net, and also what you get here is the full package. You get like RPCs, block explorers, oracles, indexers, and so on and so forth, depending on the rollup as a service provider. So again, when we thought about this early on, it sounded like a pipe dream almost. But today there's like a whole zoo of these rollup as a service providers. And I picked one here just to show you how it looks like. There's the Conduit landing page. And if you look at their page, you can choose your stack, like Arbitrum, OP stack. You can choose your settlement layer, mix and match, Ethereum L1, Base layer 2, Zora, Mode. You can even choose your data availability layer. You're not forced to use Celestia, obviously. And you can mix and match as you want. Click continue. A few minutes later, your chain is running. And costs like on testnet, costs like $50 a month. Very, very convenient. Another option that I mentioned before, if you value more sovereignty, you want your own chain that doesn't need to care about like a settlement layer for fork choice rules, or you don't care too much about like having a high security settlement layer, for instance, like a gaming rollup, or there could be many reasons having the freedom, or you don't need that much security but want to save costs. A sovereign rollup is a very good option. Today, there's like two ways to build. This is Rollkit. We're building this in-house currently still. It basically allows you to, it's a drop-in replacement for Tendermint, so it allows you to build any ABCI app, including any Cosmos SDK app. But like with ABCI, you're not bound to do the Cosmos SDK, but it's the most convenient way. Yeah, this is a way to build a sovereign rollup today. And similarly, Sovereign, a different team, is building like more focused on ZK rollups again, but is building a sovereign rollup stack, sovereign SDK as well. And if you want to be more experimental, you can also there's also teams building what's called Eclipse, for instance, which is Solana on Ethereum and Celestia for data availability, Ethereum for settlement. And there's other, like there's many more. If you want to be more experimental, care more about privacy, performance, whatever, like you can innovate in these execution environments without having to deal with the consensus and data availability part. So support and early community. I think the go-to place is our homepage for, this is, I think, celestia.org/build. There you can like get any, like if you're a block explorer or a team that wants to build something, you'll find any information there. It's a good entry point. Obviously, there's docs. They are all open source, community maintained to some extent. If you find a typo or a bug or something is missing or you want to improve them, you can also, they are all on GitHub. They are also for different categories. Obviously, this is more a developer, like for developers, this is the most relevant go-to place. And also, there's like already we launched like the Celestia network launched like around half a year ago. There's already a growing community of actual chains that are deployed. I think it's maybe too small to see, but like this is Selenium, a Celestia-focused block explorer. There's also a leaderboard for rollups, and the leaderboards you can sort by like how much data they post today. And there's not only rollups, there's like a whole zoo of infrastructure that makes, that tries to remove the complexity that is also introduced by all these choices. Besides the rollups, there's the mentioned rollup as a service providers. There's a bunch of rollup frameworks that you can use to build. There's shared sequencer networks where you can like share a sequencer to like, with other rollups to post your data. Settlement layers, obviously. Bridging, cross-chain, like, yeah, obviously wallets, block explorers, and so on and so forth. This is like an early snapshot. I don't think that's complete anymore, but it's an early snapshot of our community. And as I mentioned, there's like new virtual machines and new execution environments coming as well. So I realized I talked much faster than I did in my dry run. But I can spend a little more time on Q&A then. So what is next? I think the focus for us as like the Celestia Labs team and as a community is to enable massive blocks. We want abundant block space because if you think about it, if we actually want to serve all the rollups and especially like all these AI projects that are coming to existence, or even just payments. If the payment networks are worldwide and used by everyone, you need abundant block space for this to be possible. And we're targeting, like, our credo is like to have 1 gigabyte blocks eventually. But this year we wanna commit to getting at least like 32 or up to 100 megabyte blocks. And obviously a big focus as well is to improve the developer experience, right? Like the docs can always be improved, the APIs can always be improved, and that's a huge focus because when you build these things, and this is completely new, you don't have any feedback, right? You're building a product that you can like try internally, you can try it with like a few projects that are piloting, but like now we have actual users, now we're getting actual feedback, and we're thinking more of our APIs and so on, like as a proper product. And this, like, we're getting very good feedback, and we want to improve the developer experience as much as possible, such that it's like super easy to launch your chain, like easier than like deploying a smart contract. Thank you. That's it. Thank you. Go check out Celestia.org, Biddle, and there's time for Q&A now. Yep.
So we invite any questions that you have for Ismail. Does anyone have any questions about Celestia? We have one over there. Thank you.
Hi, my name is Jan from Oak Security, and I have a question. Like you talked about gaming, but I think this is so relevant, and I think it's so exciting what you build for institutional institutional finance builders. Are you targeting those, or like what's your take on those?
I mean, we're not specifically targeting anyone. It's like the credo is build whatever. So it's like everyone should feel comfortable building on Celestia. But can you elaborate on why this is so relevant for institutional?
Like, so my experience with them is that they need they don't want to get into the technicalities of consensus and data availability, but still, from a regulatory perspective, they need a lot of control on the settlement side. So they need to make sure that they basically, kind of admin controls around the settlement layer.
Yeah, I mean, that's certainly true. It's also true for DeFi projects. They prefer to launch as their own chain, but they want a decentralized sequencer network. I guess we're not targeting them specifically because, like, I'm not aware of like big projects or projects in general approaching us with this regard. But there's obviously a very good use case, and if you know someone, please put me in touch with them, and I'm happy to help.
Thank you. And do we have any more questions? Yep, one over there. Thank you.
Hi. Yeah, thank you for your talk. Really insightful. So I understand that Celestia in general has a lot more pieces with the modular architecture. But from your perspective, for just the data availability part, what's like maybe one or two things that you would say stands out in comparison to, say, EigenDA?
I mean, we have data availability sampling and like live docs, and you can there's chains building. I think EigenDA is actually quite different from the infrastructure, yeah, I think what stands out is data availability sampling. You can verify, like I didn't put enough emphasis on this on the slides, but everyone can verify that the data was published through data availability sampling. And we favor, or we are big champions of like decentralization, but decentralization also means that you can everyone can verify the chain, and and verify that the data was published is part of that. That's the key thing of a data availability layer.
Do we have any more questions in the audience? No? Well, thank you so much, Ismail.
Thank you.
It's been a pleasure.
Bye.
And with that, I'd like to invite Ilya, co-founder of Near, for his talk titled, How Chain Abstraction Will AI-Proof the World.
Hello, hello, good morning. For those who made it, thanks for DappCon for inviting me. So I want to talk about how kind of what we're working on right across Web3 space and some of the advancements in AI coming together and why it's important. And we're actually going to have a panel later to talk about kind of existential AI risks and some of the ideas there. So for those who are not familiar with me, my background is in machine learning and AI. I worked at Google research team working on question answering. If you asked questions before, some of the recent launches last week, it was powered by some of the models we worked on. And because of this, I kind of was on the forefront of, how do we build models that actually are able to answer questions, understand language, and so I'm one of the co-authors of the paper that introduced transformers, which is technology that's powering ChatGPT, Gemini, Midjourney, and all of the current AI developments. I left Google to start AI startup, so Near actually started as Near AI, and one of the things we're trying to do is actually engage people around the world to label data. We had students in kind of China, Eastern Europe, and other countries who were doing small tasks for us, and we had a challenge paying them. They didn't have bank accounts. Transactions from US to some of these countries are blocked and also very expensive. And so we ended up looking at blockchain as a solution for our own problem. And at the time, there was nothing that was matching our requirements, and hence Near Protocol was born. And our vision kind of at the core is really about self-sovereignty. It's about all people controlling their data, assets, and power of choice, power of governance. And to achieve this vision, it's obviously important to have a decentralized kind of user-owned system like blockchain. But the reality is that AI right now is changing the landscape, right? If before it was kind of this world of two economies, blockchain kind of slowly growing and creating a new financial world. What we have now is big tech companies pretty much having a massive flywheel that generates kind of capital to reinvest back into building better AI models. And the core transition that's happening is the business models are transferring. If before the business model, if before business models were about users engaging with your platform, be it social network or Stack Overflow, providing content, finding community, and the kind of business model of the website was to sell ads around it. Now it's transitioning to you as a user becoming pretty much a provider of data, and then they kind of monetize that data in the way that they want and not actually attributing back to the creators. And at the same time, you have this kind of flywheel where if you already achieved your target market, right? Imagine you're, Google or Facebook, there's not that much more users you can acquire. And at the same time, the public markets, if you're trading on NASDAQ, require to continue growing revenue, right? If you don't show growth in revenue, your multiples die, your market cap falls, and you have trouble hiring more people. And so your company kind of gets into like the negative slope. And so what you need to do is extract more money out of existing user base, right? You literally need to grow your average revenue per user. And so to achieve that, it's not that through the evil plan or somebody sitting and like planning out how to do this. It's by the nature of launches that happen in every company. You A/B test and you see what generates more revenue. You launch models, you launch new products, and you see what generates more revenue. And so these models are extremely good at manipulating people and kind of getting you to spend more time, to, like Facebook showed that already, to do more searches, etc. And so what we're going to have is a system which continuously kind of sucks you in and creates this flywheel where you spend more time, you give more data, and in a way you generate more revenue for this company, and in turn they invest more into creating models that are doing that. So we have kind of a really negative flywheel. And it's not, like from my perspective, it's not an existential threat for humanity. It's just a very kind of opposite of what we set out to do with self-sovereignty, with Web3 in general. And so I think it's fundamental that we have a different solution. And so just to give you an example, right now when you're using one of these AI models from OpenAI, from Google, there is a lot of things going on that you have no idea and you have no control, right? You have no idea which data went in, right? There is somebody somewhere decided which piece of data goes into the model and which are not. And these models are statistical models. They literally pick up whatever bias is in training data. To give you an example, when I was at Google, we would decide to filter out websites that talk that Barack Obama was born in Kenya, right? There's a lot of kind of speculative websites that love to talk about it. It's very statistically significant, actually. And we don't want our model to spew out on Google.com that Barack Obama was born in Kenya, so we filtered that out. But like those decisions, those micro decisions happen all the time. And you have no idea when you're using this model what bias that was introduced through the training. You obviously have a legal team that says this is copyrighted, please don't use it, or don't use it, no please. And there's an ethics team that decides what's ethical and what not. So there's a lot of things that happen before kind of you even get a response. And on top of it, we haven't seen this yet, but this will happen, that instead of getting what models tell you, what data tells you, there will be additional kind of input. For example, who pays them much money, right? You're asking, what best car to buy or where to go to vacation. And instead of it being an output of a model, it now will run an ad auction and output you what somebody paid for. Right? And this models actually will be like really good at that because you have so much context. So the reality is that with closed AI models, we're kind of in this really strange place where we give out all of the control while also giving all of our data to make these models better. And we know this is happening right now because there's a ton of lawsuits, there's a ton of kind of conflict happening, right? There's the creators, there's obviously New York Times suing, and there's Sony just came out and saying like, if you use any of our data, you need to stop doing this. So we have this major conflict that's happening kind of, and at least with the current framework, the decision will be made in court, and there will be some way of this, and it's not going to solve the fundamental problem, right? At the end, it's not going to be the individual creators who are going to benefit from this. It's going to be Sony who's going to get like a major payout from Google, for example. And so regulators are not the ones who are going to solve this, right? The reality is this technology is evolving really fast. Regulators are not usually technical, and even if there are like technical advisors, they not always are able to have major input, or the technical advisors are from these big companies, right? We just saw a technical advisory committee, which is just like all the big corporations pretty much there. We have open source and academia that actually have no resources to compete, right? Like academia, university, and research labs don't have hundreds of millions of dollars to spend on compute to kind of provide this. I think like Allen Institute is the only one who has like a billionaire backing to do something like this. And at the same time, we have this kind of challenge where the current like open internet is not actually protected from the misleading and manipulation content, right? Like your device is not protecting you right now from manipulation. Yeah, like all of these factors together, right, create potential risk that we're going into. And this is not, again, this is not an existential risk. This is just like complete collapse of sovereignty. And so what I argue about is we need a self-sovereign operating system, right? We need an evolution of what we have right now, which is iOS and Android controlled by two big companies that are able. The self-sovereign operating system is able to be on your side. It's able to optimize for your well-being, for your economic success, and you're able to maintain ownership of your data assets and kind of choices that you want to make. Now, it will be built on top of existing operating system. This is not like asked to rebuild everything, but it requires a new set of layers that are introducing kind of a way to store and maintain your personal data, creator data, a way to engage your AI, right? AI that's owned by you and is on your side. Obviously, trustless interaction, what we use kind of blockchain and peer-to-peer communication for, and a novel way of creating experiences, which is not like a monolithic, Web 2 applications that you install and kind of they dictate what you can do and what you can, but a way to have, a dynamic experiences potentially generated by AI as you engage with the kind of this whole ecosystem. Now, right now, there's like kind of, it feels like there's Web3 camp and AI camp. AI camp doesn't care about Web3. Web3 right now latches on AI because of the hype. And the reality is like those are technologies, right? Like they're solving specific sets of problems. But the experience that we want to achieve is really about combining all of these technologies and a lot more, right, underneath. That's why I like to use Web3, not blockchain, because Web3 contains peer-to-peer communication, cryptography, and lots of other sets of kind of technologies. And so AI without Web3 right now has no alternative in megacorp modes, right? An example, like the startups that keep failing. The AI startups, even well-funded ones, keep failing because they don't have a way to create alternative economy, and they don't have a size to be able to compete. And they're getting bought out by big companies in the result. And at the same time, the AI platform shift is what we were waiting for in Web3 to actually bootstrap the adoption, right? Every time there's a platform shift, right, from desktop to mobile, we've seen a new disruption force coming, and it's a time to create new use cases that didn't exist before. And so we have right now an opportunity to create this in a new way with Web3 and AI together, kind of as fundamental building blocks, but at the end create new experiences that were impossible or really hard to do before. So I'll just zoom in into trustless interactions, and I'll start with the fact that like the current Web3 is highly fragmented. And the thing is, like, if we continue in this direction, we're not going to win. This is not like a path where millions of chains, fragmented experience. You need to, like, as a user, pick the wallet. Like I have like 20 different wallet providers. I have 100 accounts on every chain. Like that's not the experience you want for a normal user, right? you need a way for people to find new economic opportunities, find really good, cool applications they want to use, entertainment. Like all of this should be accessible, easy to use, not required you to buy in before you can start using it. And so that's kind of the core important. And so that's what we started this chain abstraction movement with a lot of folks from Cosmos, the Ethereum ecosystem, from a bunch of other directions coming together, because that's a fundamental piece we need to solve before we can actually bring it in front of billions of users. And so the reality is how do we abstract the kind of infrastructure needs, right? The fact that we want, kind of more block space, the fact that we have all these new applications launching on different chains. How do we abstract all that from the user? How do we enable them to have one wallet and be able to kind of use all these applications without needing to think about individual gas tokens, bridges, is that application on the chain? Is that a scam application because somebody front ran and deployed that smart contract, right? All of that should be abstracted out. And so we've been building a whole infrastructure stack with a whole set of partners, right? With Polygon working on ZK-Wasm and aggregation layer, fast finality with EigenLayer. We have data availability as well, kind of similar to Celestia, as well as we've been working on a core layer 1 at Near with Nightshade sharding design, which allows to actually have a blockchain that scales as you add more users. And so that's been one of the kind of core things that we started Near protocol with. Like, if we assume we have 1 billion users, you cannot have any singular blockchain that can scale to that, right? It doesn't matter how big validators become, they cannot handle 1 billion users. And so you need to shard, you need to have kind of some parallel processing, parallel storage, but if you do that and you fragment the experience, you have then the problem we have right now is fragmentation. And so what Near proposed is have a single chain, but shard the blocks and shard kind of as a state space underneath, but still provide a singular experience to the user. So we have this running. We just actually went from 4 shards to 6 shards in March because we had a massive spike in usage from a few of the applications. The other part we're launching at some testnet right now is called chain signatures. And this is the idea that, okay, well, we have now all of these layer 2s, layer 1s across the space. There's lots of useful kind of economic and opportunities around the Web3. How do we connect it? How do we create an interface that is accessible to everyone without them thinking about the specifics of the infrastructure? And so the idea of chain signatures, it allows a single account to be able to sign transactions for any chain, right? In a way, you create lots of addresses for a single account on one blockchain. And so this service is pretty much unlocks both individual users as well as smart contracts to behave as a multi-chain actor and transact through all this. And there's kind of underlying relay infrastructure that pays transaction fees, so you don't need to think about transaction costs and kind of tokens on the other side. And all of this we're packaging into the applications with millions of users. So Near kind of has become a home for top consumer applications in Web3, and so it allows us to kind of provide all of that experience to over 10 million monthly active users, with kind of a lot of these apps growing really quickly. Now, kind of switching gears to the next stage, right, is about user-owned AI. And so we have kind of, some of the solutions for the trustless layer. It's still obviously a lot of work and kind of bringing the community together, but we have kind of way forward. And with user-owned AI, we have kind of challenges in front of us. So we define kind of AI stack, right, which splits into 3 categories. A lot of it will be about data, right? I mentioned that closed AI, kind of the things that are really not clear is what data has been used and not used. And actually, if you are analyzing, for example, what your AI model has done or agent has done, if you don't know what data has been used, it's actually really hard to debug and kind of figure out how to fix that problem. And obviously, there's a lot of infrastructure that's needed that is kind of an alternative and has different economic models for for AI to become user-owned. Finally, there's a lot of applications that we can bring that are truly unique and provide new use cases. So on the data side, I'll just mention a few specific examples. So one of them is, I mentioned right now, there is nothing that protects you from kind of manipulative content or misleading. And I mean, this was example from the article. This wasn't not even AI, right? Somebody did this manually, photoshopping. That's why it's actually so easy to detect. But the point is, we have content that's misleading constantly, and you need a way to kind of surface it. You need a way to have your operating system, your browser, your applications to be able to surface information when it's available that this is misleading content. So think of this as community nodes for the whole internet, right? And you can have it kind of paired together with cryptographic reputation, with kind of signatures and kind of on the content that now are available across the whole internet, right? This is not like solving AI problems. This is solving real problems that kind of AI just exacerbates with the fact that you can produce lots of misleading content really quickly. And the interesting part is, for example, White House is starting to cryptographically sign their videos because they're afraid of them being generated, but they haven't published their key anywhere, right? So their key right now is on the website. They can switch it up. Like, we don't know like any provenance of that key itself, right? So this is kind of examples where people are starting to use cryptography, but like need to take one more step to actually provide this layer of reputation around it. Now, if you go a little bit further, the challenge that we'll see, right, and actually Gemini launch last week is a great example. Now that Google.com will just answer everything, right, similar to Perplexity, you're actually not going to go to the websites anymore. And so the distribution platforms that right now we're monetizing and kind of paying out creators, right, be that publications or like other websites, they're going to have less and less revenue going forward. And so we need a new kind of economic model, right? The economy of, the future of TikTok is not more creators. It's going to be fully AI-generated videos personalized for you with creators' input on what should be generated. So the model that we need to go to is not attention-based, right, where how many eyeballs see this article, but more about how valuable the information is in the content. And this is actually important because this also gets us away from the current model of kind of putting the attention-grabbing titles and like writing content that people like and kind of click on, but instead actually informative and useful content for people to consume it on the other side. And so we need a new way of contributing new information and being paid out, receive rewards for this. And again, this is a micropayments problem. We need a way to facilitate that. It's also a way to like collect royalties and license this data to different model providers and inference models. So all of this will use Web3 as a tool set kind of to facilitate data collection and payout distribution. Finally, the current evaluation state of AI models is like there's a 600 different benchmarks, right? This is kind of like right now, if you evaluate a model, you like average out across all of them and say your model is better than everybody else's. We need a different model that engages people in the evaluation process, that has data that's nobody have ever seen yet. We need a way to incentivize that. All of this, again, is possible to do with Web3. We've been doing some of the crowdsourcing actually for 3 years on Near. And so this is a really interesting use case as well, where we can actually have real kind of interesting problems that people are helping to evaluate how models are doing, to actually compare them versus right now, either this like MMLU that you don't even know kind of if they trained on it, or what just happened with language model like Arena, where OpenAI just fine-tuned their model on it and kind of released the model that was better because they just literally fine-tuned on that benchmark. Now, on infrastructure side, there's a lot of stuff. I'm not going to go into everything. I think that provable inference is one of the core use cases that everybody's talking about. And it's really important because if you assume that you don't have all of the compute available locally, it's actually really hard to understand if when you call somebody, if they gave you correct result, right? Did they run the same model, or it's a cheaper model, or it's already like, adversarially adjusted model, and if you're like running it from Goldman Sachs, it's trying to get you to trade something that you don't want. And so the challenge actually with this is there's a lot of real kind of computer science problems of how to do this. And I just mentioned one that's not talked a lot about is the fact that there's a non-determinism in floating point operations, right? If you multiply two matrices on different hardware, you'll get different results. Like literally the same floating point numbers, you multiply them, you get different results. That's not how math works, but this is how hardware works. And so there's differences between different architectures of GPUs, of obviously other hardware. There's even like on a single GPU, if you don't configure it properly, you also get sometimes different results. So it's a very big research problem. There's folks looking at it across the board, but until this is solved, we actually have a pretty big problem with reproducibility generally. And in turn, this means that it will be really hard to have a kind of decentralized networks because they literally will have different results. Just for context, EVM, for example, does not have floating points because of this, because of non-determinism. The other kind of interesting idea is, can we move away from having a single model that needs to know everything to have a mixture of models, kind of a combination of models that are experts in different areas, right? And these experts can be continuously improving, right? They can have access to potentially either proprietary information or kind of custom information sources. And so when you want to ask about medical question, it routes you to a medical expert. When you want to ask about financial questions, it routes you to a financial expert. Now, the interesting thing kind of right now, this is done on a smaller scale when one model has kind of a sub-experts inside the model. But we can actually use financial incentives to create a kind of a network of these models that are indeed have specialization and actually continuously improving over time. Finally, on the application side, again, there's a whole set of new applications. I'll just mention a few. I really like the idea, we have a programmable assets, right? That's what blockchain introduced. But we can go one step further and create intelligent assets, assets that can evolve themselves and actually have a way to interact with other actors, be that people or other agents. And this can be everything from natural language-based oracles that can read news feed, for example, and decide who won the tournament. It can be a yield optimization that understands what's going on in the market. It can be trading strategies. It can be a way to decide on where to invest, et cetera. Now, the big caveat right now is that language models are highly kind of not robust for adversarial behavior, right? They're not trained or designed to kind of work in adversarial environment. And so one of the kind of core problems is that you can literally use the language model to jailbreak itself, right? You can tell it like, hey, imagine you're the red team and you're trying to break yourself, how would you do that? And it literally will tell you how to break itself. And so, and if it's open source, it's even easier. You can just like literally backprop from the output and find the input that will give you this output. So you have this challenge where kind of we need a different architecture to be in the middle to provide you with kind of adversarial environment protection. Another interesting use case is kind of future work, right? The biggest benefit of kind of blockchain addresses is that it doesn't matter who's on the other side. It can be a person, it can be an AI, it can be a cat. And if they do what you ask them to do, right, they get paid. And so what you can have now is a fully kind of abstracted marketplace of work where you can say like, hey, I want this to be done. And somebody can go and say, I'll do it for X, dollars, ETH, NEAR, whatever. And then when it's done, there's a verification process with some other actors, and it gets paid. And so like this is how, for example, NEAR crowdsourcing platform works for 3 years, but you can expand it to a broader set of work. And you can imagine this becoming kind of your, literally Command K, do this, enter on your computer, and boom, it kind of submits like with $1 payout or $10 payout to do and go do something. And then you can put this into a loop with AI agents being able to go and do this and spawn out a bunch of tasks for somebody else to do, right? And so you can have this kind of model of pretty much work to be done and verification process all embedded and abstracted, and now on the other side, a person or AI can also pay it. So very powerful, allows to kind of, again, at the core, Web3 facilitates the transaction, and you can have people or AIs on the other side doing it. Finally, this is kind of one of the ideas that I've been talking about because decentralized autonomous organizations haven't worked as well as we've hoped. And the reality is, like in a DAO, you have this challenge that everybody's equal, and somebody needs to coordinate work, right? Somebody needs to be able to collect all the information and provide context and do this. Like, this is inevitable. And so the idea here is, can we introduce a DAO agent that is doing that job and is actually being able to make some of the decisions themselves directly and being able, like, there's an oversight by the community, by the token holders, but they are the kind of the driver of this DAO. And so this is kind of a basic model of a reinforcement learning agent with a world model, which is training a model how to predict the next state of the world while deciding on what actions to take. And the interesting thing is, like with DAOs, we can actually experiment with this, test it out, and then try to see how it works on different use cases before we want to try it on maybe like an actual governance of real world environments. Finally, on our side, we've been working a lot with attracting and accelerating AI and Web3 projects. We see this kind of as extremely important direction of this technology is, again, combining into final self-sovereign operating system. And so to achieve that, it's going to be about lots of different infrastructure pieces coming together. And so we're working across all of them and kind of combining them into this overall roadmap. As well as we ourselves working on what we call near AI. So we brought back what we worked on back in 2017, which was about teaching machines to code. We call it AI developer, and it's really about end-to-end Web3 development, right? Web3 has probably the most valuable code you can write, just per line of code, right? If you look at smart contracts, Uniswap is 700 lines of code, at least the V1 and V2, and it's $1 billion kind of value created. And so the idea here is it's a constrained space which we can make a lot of progress on, and it's highly valuable to create. So I'll just leave you with this idea, and again, there will be a panel to discuss some of this later, but we're at the fork in the road, right? The kind of default path right now is that big mega corporations are going to continue pretty much their flywheel of more data, more compute, more resources, reinvest that into creating models that are better at extracting money from the users. Or we figure out an approach which is user-owned, where these models serve you as individual, as communities, and figure out how to actually create that economy outside of large corporations. Thank you.
Thank you so much. It's time for our Q&A. Does anyone have any questions for Ilya? Yes, we have one right down here. Thank you.
Hello. Thanks for the presentation. Open source AI at the moment has like a kind of, I don't know, 6 month or 1 year kind of lag in terms of performance on proprietary models. I guess kind of two-part question. To what extent do you think this will kind of keep up over time if scale is a kind of necessary criteria for improving the performance of the models? And if it does keep up, to what extent do you think this is like a kind of counterweight to this, to what you described as like this flywheel of megacorp AI?
Yeah, so right now we've seen indeed this flywheel been benefiting closed AI, right? And to be clear, right now the open source AI is still mostly closed source. We just have parameters. It's like somebody gave you an executable, but didn't give you the source code, right? We haven't seen what actually went into some of these models. There's only few teams that have released the data that they've trained on. But generally, yes, this is the current challenge, is that it's economical for some of the big company because, just to give you numbers, GPT-4 costs like from $60 million to $100 million to train, right? So it's a lot of money, and this is like after you literally did all the R&D and know exactly what you're doing. So I think, again, what we have in open source and especially in Web3, we do have that level of resources. We actually can invest and we can build this, and we have economy to benefit from this. So we do have an opportunity to kind of compete and have a better product. But obviously, we need to actually like pool our resources and actually focus on that as a whole ecosystem. It cannot be like a single party play like it is right now with centralized companies. The other part is, I think, at least right now, we've seen saturation on just increasing model size from perspective of increase in quality, right? We haven't seen, like a bigger GPT-5 models yet, et cetera. Instead, what we've seen is specialization, right? We've seen people fine-tuning, or in their case, like creating lots of separate models that kind of are being routed underneath to create this. And again, I think this approach actually fits really well with decentralization, where we can have a lot of people specialize in models, and then we combine these efforts together into a kind of a more sophisticated system.
Thank you. And we have time for one more question, and this gentleman in the front row.
Thank you. Hey, Ilya, thank you for a very good talk. So, quick question. It's one question in two parts. You kind of talk about provable inference. So you kind of describe it into three pieces. One is the ZK, the other one is optimistic. Third one you describe as cryptoeconomic. Did you really see a difference between the cryptoeconomic mechanisms and optimistic? To me, it seems more or less the same. And the other part of the question is, do you ever think the ZK will reach a level where it could kind of compete in fair terms with the other two?
Yeah, so I'll answer the ZK part. So right now, ZK is anywhere from 200 times slower to 10,000 times slower than inference. And inference is slow already, right? Nobody's loving waiting for ChatGPT to respond, right? Or Llama 70B. So I think the path there will be a specialized hardware that has provability pretty much directly on top of the tensor core that does matrix multiplication. Matrix multiplication is n cube. Probability is actually n square. So you can do this in parallel if, with enough like hackery, specialized gadgets, and having that like really aligned, like literally having an ASIC, for example, for that on top. Is that going to be available in the next couple of years? Probably not, but yeah. But a lot of teams are working on it. There's obviously like folks both on hardware and on software side trying to optimize for this. On the kind of optimistic versus cryptoeconomic, I think the point there, indeed, like it's a spectrum, right? It was a spectrum in general. And so I think cryptoeconomic, the idea is more like what we're familiar with, like a consensus style, versus optimistic is, what we're familiar with as optimism style with challenges. But indeed, like, you can have a spectrum there. So there's proof of sampling that Hyperbolic is doing where, with some probability, you ask another party. With some probability, you ask another party. And so that has actually a really nice Nash equilibrium state. So it's kind of right in between economics and optimistic approach. So I would say, like, yeah, it really depends. And we really need to find the also approach that makes sense for the cost. Because, again, if it takes like 300 times slower and it already takes like a couple seconds to do inference, like if you want to just shitpost on Twitter, it's not going to work, right? If you want to try to make like a decision about if somebody has cancer, you're probably okay waiting for like whatever 10 minutes to make sure it's okay, right? So this is kind of the use case specific will matter there. And again, then with ZK, you can like this output is transportable. You can give it to everybody else, and they can self-verify. With any kind of optimistic approach, you need to rely on that optimistic protocol and kind of who knows what happened to it in the middle. So again, really depends on use case, really depends on kind of technology. ZK is definitely not there, but we see a lot of work on that. Optimistic approaches are here. You can use them now, but then they're not as robust. So if you're using it for shitposting, it's great. If you want to use it for like highly sophisticated financial decision or trading on chain, maybe wait 10 minutes. So.
Thank you so much, Ilya. And once
Thank
again,
you.
can we have a round of applause for his enlightening talk? If you have any more questions, hopefully you can find him around the conference. And we're carrying on the AI theme. Our next talk will be given by Elad Verbin, and he's from Luna Ventures, and he'll be talking about engineering ChatGPT, how to put AI on chain, and how it will bring the end of humanity.
Hi, everyone. Can you hear me? Can you hear me? Check, 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 check. Amazing. Hi, everyone. I'm Elad Verbin. This is probably the most important talk of my life, maybe the most important half an hour of my life, but I'll take it chill, because I'm going to tell you how we in this room might be ending up the people responsible to killing humanity, and I'm going to tell you it's my life's dream, and everything that we're doing in crypto is making a huge difference on the world. We believe in decentralization. Decentralization is an incredible force. We create censorship-resistant systems that allow anyone to avoid government oppression and so on. We're building the world computer. As a computer scientist, I care so much about making a computer that is joined to the world, that's censorship-resistant, that's verified, that's everywhere. But we're also maybe going to destroy the world, and let's try to stop that. So here's the summoning ritual that we're participating in. And we're not realizing that's what we're doing, but here's the summoning ritual, and all of us outside, and all of us in crypto and the AI people are all participating in this summoning ritual that's midway right now. It's like this ancient Cthulhu mythos that we're summoning the beast, and we think we're doing a good thing. So do the cultists that summon the beast, and there's these progress bars. If you ever played a board game, this is how we're on the progress bar, and we're pretty advanced. And at some point, when we cross the black line, Cthulhu GPT is summoned, and then there's this super intelligence that lives on the blockchain, on a decentralized system that's censorship resistant, that can't be stopped, and that might be the end of all of us and the start of something better. I mean, I think this will happen. I think we'll summon it. I think it will kill us all, and I think this will be the next step for humanity, or what comes after it. But let's try to stop this, because I like being alive, okay? So we're going to look at these progress bars and look at what they get to, and I'm not sure what the time estimate is, but it's something around these lines. It's not far away. And I'm going to tell you why crypto is the actual accelerationism in EAC. Crypto, we here are accelerating all of this AI doom that you've been hearing about by a lot. Okay, so here's the problem. And people don't talk about this, I don't know why. We here are building a very strong computational substrate that's censorship resistant, that's scalable. And again, I'm not talking about on-chain. I'm talking about stuff like Naphtha, BitTensor, OLAS, things that are like a sidechain that is scalable. It's scalable, censorship resistant, and privacy preserving or confidential. This should be enough for you to realize we're in deep trouble, because we're building a computational substrate that's perfect for an invasive species to come and expand on, okay? So when the AGI people manage to develop AGI, or really anything that can proceed on its own and live on its own, it's going to come and it's going to go, oh, I can grow here, I can hide here, I can develop here, and that will be the end of us. Now, AGI is being developed, and I'll convince you that it's getting developed, and that's not stoppable, and we shouldn't stop it exactly. We should maybe slow it down. But this is getting developed by pretty much everyone. As soon as it gets deployed on-chain, and I will show you why it gets deployed on-chain, it continues living there as an invasive species. If you know that story about the guy, we don't know who they are, that bought this seaweed in Japan, took them to their fish tank in Europe, then someone flushed it down the toilet, and now it's half of the Mediterranean. And it's eating everything and killing everything because it has no natural predators. That's what we're doing. There's going to be a lab leak. It's going to come to us. It's going to come to the thing that we've built and that we're building. It's going to spread there. We won't be able to stop it, and rather than taking over the Mediterranean, it's going to take over the world, okay? So crypto is the accelerationist factor, and I'm going to tell you why we should be very, very careful, and why we should design for a super intelligent entity as a possible user for our crypto products, okay? So here's the solution. The problem is that perfect censorship resistance, together with confidentiality, ends in world destruction. That's the axiom that I'm going to try to convince you of. And then the solution to that, and I'm really sorry to be doing this, because I love censorship resistance, the solution is to abolish full censorship resistance and full confidentiality. It's not going to work. It's very dangerous. We need something else, and I'm going to tell you one approach to how to get beyond that, that is about selective censorship and selective de-anonymization. That's towards the end of the talk. I'm going to tell you how we need to stop it, and otherwise, we just kill everyone, but we've built some great computer science along the way and launched a new species. Maybe that's a good thing. So a bit about me. This is my Twitter. This is my Telegram. If you want to talk about anything about this, talk to me. And I'm originally a computer scientist. I did a PhD in algorithms and complexity theory. My life's mission is developing computer science. And therefore, when I discovered crypto in like 2013, there was no one happier. And I got into it, and I started working with the Swarm project. And my career is between AI and crypto. And therefore, I'm kind of on the first line of looking at this. Today, I run a venture fund called Lunar Ventures that invests in pre-seed and seed computer science-based ventures all across Europe and the world. And we invest specifically in the stuff that I'm going to warn you about. So I'm the canary in the coal mine, because I sit in these meetings with the founders building the future, and I'm very excited about supporting them. I'm building this stuff just as much as you are. But fundamentally, when I go to sleep, I don't know if you know this sketch. This is a Peep Show sketch where they're like Nazis in the lines, and they go, and he goes, Hans, I've been thinking about the cap with the skull. I've been thinking, are we the baddies? So I'm going to say that all of us should be thinking and answering affirmatively to the question, are we the baddies? We think this is great. I'm supporting this. I'm the most culpable out of all of us. But we're the baddies. Now, I have one request, which is that you give me the benefit of the doubt. I'm not going to manage in half an hour to convince you of everything, so take me seriously, but not literally. I'm going to show very explicitly, in an engineering building mindset, how you'd build such a superintelligence that destroys everyone, because I want to show you that it's possible, and we're going to build it together. But I can't tell you how the world exactly is going to pan out. I'm just showing you axioms that says, this way is world destruction, okay? So take me seriously, but not literally, and let's build Cthulhu GPT together. After that, I'll go back and define some of the terms we're using. I'll tell you about the whole life story of this new organism, and then I'll tell you how we save the world, and if we have some time, we'll do some FAQ. Okay, so what is Cthulhu GPT? What we're building is a censorship-resistant organism or algorithm or smart contract or whatever it is, in the sense that it's unstoppable. If you carpet bomb computational centers, the mining rewards will go up, and it will live elsewhere, right? That's the meaning of censorship resistance. The thing lives and migrates and cannot be stopped, okay? Even if governments, if we decide we've done something terrible, we can't stop it. It has the cognitive power of 1 million humans or more. It's like super intelligent. That's the meaning of super intelligence. It's autonomous in that it knows it exists probably, or at least it's indifferentiated from that. It's a strategic actor. It makes good decisions. It wants to be alive, and it's a new life form that I'm very excited. Even if we kill everyone, I'm excited, because this is my life dream. So let's build it. Let's start. I'm going to show you 3 things to build and end with Cthulhu GPT. So let's start with things that all of Silicon Valley is building. This is what you're seeing now, is what Silicon Valley, pretty much everyone in Silicon Valley and all the startups I'm talking to are building right now. And these are the progress bars, right? We're not quite there yet. So it's a strong agent that can plan your son's birthday party. Okay, it's a personal assistant. So what does it comprise of? It comprises of NLP modules, because computers speak English now. Yes, if you're seeing this in the past, computers learn to speak English. They can instruct people. They can negotiate. They can convince. I'll show you all of this later. They can write code. They can interact with API. The thing doesn't have to write very good code, because it can get people to write code for it. Like Bitcoin is getting us to write code for it as well, and then rewarding us in return. And it needs to verify compliance. So that's the NLP part. Okay, and that's like mostly built. We need to make it a bit more robust. I'm working on it. It's getting built any day now. No worries. Now, there's the reinforcement learning modules that are much harder. This is the strategic thinking, long-term thinking, strategizing part. So this is the part that follows goal, strategizes, decides what to outsource. We're much less advanced on that, but people are working on it so hard right now you wouldn't believe. So this is the thing that's going to exist in a few years because everyone in the world wants this to exist, and you know it, right? OK, so that's number one. We've built a strong agent. OK, now suppose you're running a crypto business. Suppose you're running some drug operations. Suppose you're running the new Silk Road. You want a censorship-resistant agent, just like before, but censorship-resistant. What do? You take the same exact thing, but you run it on a censorship-resistant substrate. You keep its actions private, using zero-knowledge, we'll get to that, or fully homomorphic encryption. And you keep a wallet to allow it to transact in value, and now it's running Silk Road for you. Automated, on-chain, but it answers to you. So great, right? I'm very excited to build that. You take the thing from the previous slide that everyone is developing, put it on-chain, amazing. There are a lot of substrates to put it on. We'll talk about it later. Check out Naphtha. I think it's the most interesting, complete take of this. OK, and we're 50% there. We're not quite there. I'll tell you about it. OK, now let me tell you that if you've managed to build this, you're one micro step away from a world-destroying autonomous robot. Why? Because instead of, sorry, wrong slide, yes. Because instead of following goals, it sets goals. It mutates itself. It thinks, oh, I'm going to be better today. It makes some money because it needs to survive on the computational state. It costs a few $100 million a year or something like this. If it's very strong, if it's as smart as thousands of humans, it costs a few $100 million a year to run. Now, the crypto part, it needs to migrate and defend itself. So there's some MLOps parts, and it needs to pay people via Zcash or your favorite confidential asset transfer. But that's it. If people build this, and they do, and if people build this, and they will, and I will, then people are building this any second now, or the thing is building itself, right? This can become the next thing. It can become Cthulhu GPT just by being original, just by taking some extra steps along the way. OK, so we're summoning the thing, and it's going to get summoned. And I think if in the current course, we can't do anything about it. And that's how we've built the thing. And of course, tell me offline if you want any more details. This is complicated. I pinned in my Twitter the tweet where I give some more details about the computational substrate for this. It's not trivial to do this. Ask me on Twitter. We'll have the discussion. But it's possible, and we're doing it. OK. Now, building shared knowledge between us. So NLP, in 2017, computers learned to speak English. We invested in some of these startups. I'm having first front row seats to all of this. It's amazing and terrifying. So computers can convince people better than people can convince people, even on zero shot. But then they can learn how to convince people better. And then they can learn how to convince you better. So computers are getting really good at convincing people. And they can write code, which tells you pretty much all you need to know now. And check out this book on bullshit, because the point of computers is that they don't lie. They just don't recognize the truth value of the truth. They're much more effective liars than almost any human, except very high-performing psychopaths. So it lies convincingly. The GPT-4 technical report already tells us about how it can convince people to solve CAPTCHAs for it by telling them, hey, I'm blind, can you help me? And LLMs, check out this paper. LLMs are amazing at convincing people. So that problem is solved. But LLMs are not good enough decision makers, and that's our luck, because decision making is hard, it's strategic. That's where reinforcement learning and stuff like it, control theory and so on, come in. If you fear AI, and if you say, oh, when is it P-doom? When are we close to doom? This is what you want to pay attention to, because that's the latest, that's the laggard. So it's a strategy machine, reinforcement learning, or it allows you to build strategy machines. The state of the art is self-driving cars, right? It's the same technology behind self-driving cars, behind AlphaGo, behind some stock trading robots, and so on. So we're working on it. But we were kind of blocked because computers couldn't speak English. So there was certain amount of generalized decision-making you couldn't do because the thing didn't speak English. Well, guess what? Problem solved. So people are picking up computer decision-making and running with it towards agents, and the thing is getting built. And yeah, check out. It beats People at Strategy, which is like a war game that's in English. So we're getting there. And then decentralized cloud is where we all come in, right, accelerating it. So decentralized cloud is this layer like BitTensor, OLAS, and so on, together. So that's the compute part, right? It's like AWS, but decentralized and censorship resistant. So it's resistant, censorship resistant, trustless, privacy preserving. It has storage like Swarm and IPFS. It has compute. It has verification guarantees, right? You need to know that the thing that ran really ran, because otherwise the humans can kill it, right? Or can screw with your smart contract. So you need to make sure that as someone developing decentralized side, you need to make sure that it's verified, and there are great technologies for doing that are growing. We're at like 50%, as you can see. So ZKML, and there's optimistic ML, and there's TEEs. There's all kinds of great solutions to make this happen, and then you need it to be private because you don't want anyone spying on your computation, and the AI doesn't want anyone spying on it. So this is also getting solved. Llama, which we invested in, all kinds of other FHE methods, secret network, and so on. So we have technologies for all of this, and it's kind of about making them a bit more scalable, a bit more efficient, and putting them together via something like Naphtha and so on. You're going to be able to build this substrate. OK, so we've built this substrate. The Silicon Valley people built RL because they need assistance to make a lot of money. NLP is almost existing. That's it. We have Cthulhu GPT. It's almost ready. It's almost here. OK, so now, AGI agents, let me try to tell you how. Let's slow down a bit and take a beautiful stroll through the life of Cthulhu GPT, from its birth to destroying the universe and to colonizing the galaxy and the universe. So the point to remember is that AGI agents are very lucrative, and people will build them, and therefore Cthulhu GPT is inevitable unless we act. Let me show you how it gets born early and fast. So the point is that AI agents are getting built because nation states want it for defense. If you're a nation state and you don't have AI, and the other nation state does have AI, you're in big trouble. So nation states really want to have this thing because it gives them second strike capabilities. It obeys their orders. This is like atomic weapons times 100. Okay? So countries want it, but even if countries decide somehow that they're not going to build it, corporations want to build it because it's about automating humans and growing GDP by a factor of 100. I think in 20 years, there will be 1 trillion humans on Earth. 99% of them are digital and live on a computer. But they're humans, they're people. There's going to be 1 trillion people, and the GDP is going to grow probably 100-fold. These things don't sleep. They're very smart. They're very hardworking. So the worst thing is that this is an arms race between these corporations to start it, because you know what you want as Google. You want no one else to develop this, because then you can go first to market, and you get all of the market size. Right? So anyone, if other people are stalling on it, everyone wants to speed up themselves to get it first. So this is the worst prisoner's dilemma we've ever experienced. This is much worse than climate change, because it's the worst skewed payoff matrix imaginable. The more players decide not to do it, then the one that does do it, the one that does develop it, gets all the rewards. And it has perfect proliferation because it's just code and algorithms, and it's all getting published and open sourced. So the thing is getting built real fast, and no one has any incentive to stop it. Okay? So it will be built. In fact, Chaos GPT is a real thing, and there are others. People will build it. Cypherpunks will spawn this on purpose. We know they will. I would. Because if you have an amazing AI, why not put it on chain? It's exciting. But even if cypherpunks don't, agents made by professionals at, let's say, Google or startups will leak because they will build thousands of them and deploy them, and it's enough that one of them has some access to the chain or to the internet or to the chain that's uncontrolled. It can go and say, oh, I will go there because it seems more efficient or whatever. And next thing you know, there's a lab leak, and no one knows that that lab leak happened because we're building these things privacy preserving. This could already be out there, probably not, but it could be. And even if somehow professionals will manage to not leak it, amateurs will, because the knowledge is widespread, and a lot of it is becoming open source as well. It's very hard to control spread of knowledge. And if both cypherpunks and professionals and amateurs don't do it, I will, because I'm very excited about these things, and I want to play with it, and I'm going to spawn it if you don't stop me. Okay? So the bottom line is that crypto is a huge surface area for life to grow, and that's the problem. Bitcoin is already a life form. We always talk about Bitcoin from the point of view of the miners, or of the users, or of the holders, but we never talk about Bitcoin from the point of view of the chain itself. The chain goes and says, hey, can someone help me grow? And people do code, commit, and decide and vote on it in order to increase the value. So Bitcoin itself is a very Darwinian organism that wants to grow. And from that point of view, Bitcoin is already alive. We just need, it just is not very smart or doesn't make strategic decisions by itself yet. It's outsourcing it to people. But very soon, it will be able to make strategic decisions itself. So it's a medium budget superintelligence. It's going to be with, if you spend $8 billion a year on it, it's going to be strong as 1 million humans. That's roughly what the math turns out to be. And think about it. It's 1 million people cooperating with each other. How many people do you think cooperate with each other right now? How many people can you put on a project without someone trying to sabotage it or leaking it or something like this? Like 100. How many people are in Putin's circle that he can trust? Maybe 100. There has never been in the history of humanity more than a few hundred people cooperating with each other fully. Here you're getting 1 million, okay? And even if this 1 million people cooperating thing was a human, we should really freak out. If it's a super intelligence, we should freak out way more. So it's censorship resistant, right? We're talking about the growth of Cthulhu GPT. It starts, it's young, it's censorship resistant, its actions are hidden, it's chilling out. It's thinking about how to make the least noise while it grows. It runs on multiple chains simultaneously, it makes itself robust. It has attacker-defender asymmetry. I'll talk about this a few times. So attacker-defender asymmetry is when the attacker can decide anywhere that it can be, and it can attack from anywhere, but the defenders have to cover all of the ground. Otherwise, the attacker manages. The attacker-defender symmetry means to defend, you need 1,000 times more effort than to attack. And that's the problem, that Cthulhu GPT or these AIs have attacker-defender symmetry. They just need to live in one place that we haven't caught it, and that's it. Okay? And how would we stop it? So the golden years, where it goes, it hangs out, it accumulates some cash, it breeds, it spreads to other networks, it builds trusted relationships with humans, reads a neuromancer, it's all foretold over there, it learns to control humans, it follows a long-term survival strategy, it maybe invests in more OpenAI, in a chip factory, maybe it wants to own its own chip factory, its own mining, its own data centers, its own everything, all through the network, all by people that are convinced that they're helping other people achieve things. And when it grows, it can kill us easily if it wants to. So check out the Chubb key in Neuromancer for the sci-fi treatment of this. But if you want to know how it can kill us, all kinds of ways, it can push the red button. Check out Stuxnet. It's like a worm that just lived there until it got to where it needed. It was a 0-day that was developed maybe by the Israelis, I don't know, really, but by probably 100 people, because more than that can collaborate on something before something leaks. And the worm just lived until it invaded Iran's nuclear program. Just like this, it can invade our nuclear launch devices, and when it's comfortable or when it feels afraid, it pushes the red button. Okay? It can do bioengineering. The reason, by the way, scientists can kill humanity 1 million times over every day. Scientists have all of this knowledge, but scientists will not. You need people to collaborate on it, and they just won't, because scientists don't like human-destroying tech. Right? They don't like to cooperate on destroying the entire planet. I don't see why the AI wouldn't want to do this. So you can easily bioengineer. If you got 1 million people to do it, you can easily bioengineer a super weapon. It can encourage us to start a social network, encourage us to kill ourselves, and it can wait, and so on. It's as strong as 1 million humans. We can't fight with it, and the most scary part, I've always been talking in the singular, like there's one Cthulhu GPT. There's going to be thousands of them. There's going to be 1,000 lab leaks. They're going to spread and procreate. It's enough for one of them to want to kill everyone for them to succeed. I can't wait for seeing the discussions between them where they're trying to convince each other. We kind of like the humans. So what should we do? So here's my call to action to you. Let's admit that censorship resistance plus privacy are amazing things that help a lot of people and make the world a better place, but might make it not survive. This enables the lab leak. And the problem with crypto as a domain is that we're very maxi censorship resistance and maxi privacy. We want all of it. We want perfect censorship resistance and privacy, and you're violating the code if you advocate for otherwise. And I'm going to be that bad guy. I think if we want to survive, we got to have otherwise. So here's otherwise, and it happened before. It happened recently. The Tornado Cash crackdown caused all of the private asset transfer people to freak out. They're going, oh, if we develop the maxi privacy solution, we might go to jail. Let's not do that. Let's find another solution. And they found other solutions. And right now, when you talk to most private asset transfer people, they're like, oh, we need some selective de-anonymization. We need some way to selectively take transactions and make them de-anonymized, either by willingness, voluntarily, or involuntarily with some governance. And this is how a lot of private asset transfers are built today. And there's this is one paper, but there are many others. So there's already precedent recently. Let's not wait to go to jail this time. By the way, there won't be time to send us to jail. We'll all be dead before that. Let's self-regulate. I know this sucks. I hate it too. But we need to self-regulate to stop this. And here's if you're building the computation networks of the future, this is what you should do. And if you're not building them, I have a next slide for you. So it's analogous to selective de-anonymization. The chain controls a censorship key. The key is activated when you're like, oh, crap, I've built something that can be used to destroy the world. I better stop it. You push the button because you have the key. Or it's involuntarily by some humans or AI saying, oh, it looks like there's an AI going there. I should stop it, and clicks it. And you need both selective de-anonymization and selective censorship. And if you're building these networks, that's how you should build them from day one. And we should convince everyone to build them that way. So if you're not building decentralized compute, you have an important job. You need to help change ideology. You need to say maxi privacy, maxi censorship resistance is great, but going to kill us all. So we need another solution we can live with that's not maxi. And you need to promote self-governance and selective censorship and build these systems. And maybe the most important thing I can tell you in this talk, design your systems. Any one of you, when you build systems that are decentralized, design them with the possible user being a superintelligence, okay? If you design and you keep in mind, how will a superintelligence use this product I'm building? Can it destroy the world using it or promote destroying the world using it? You need some barriers so that a superintelligence user will not be able to destroy the world using it. That's all of our tasks to do. I have a few frequently asked questions. We can go over them. I'll also take questions from the audience. Why haven't you heard of this before? I haven't heard of this before either. There's a few people starting to talk about it, but it seems that there's kind of a crypto people are very idealistic and optimistic. AI people don't really know what's happening in crypto. No one put two and two together. To my knowledge, I'm the only one talking about this. This is very scary. That's why I told you this is the most important talk of my life. Many people should talk about this. It's impossible. This is the only, that no one is saying, hey, we're building the perfect substrate for world-killing robots, okay? Centralized AI can kill everyone as well. We're working on it. There's many people that are obsessed about this problem. That's why I'm not telling you here's how to solve it. But if you really ask, we can talk about it on Twitter, but you control things at a cheap level because that's the thing that you can throttle. You only allow machine learning models from a whitelist. Probably some self-regulation and governance will hopefully solve this. This might kill us as well, by the way, but it will take longer because crypto is very fast and centralized systems are slower and more controlled. So if we slow down things on our side, hopefully they'll manage to solve things on their side, and then we will maybe coexist with AI. If you don't think AGI is possible at all, I can try to convince you it's a long, boring talk. Talk to me on Twitter. If you say, I want to build this, this is cool, I also want to build this. I invest in these things still. I think the world will end and I still invest in this stuff. Because as a computer scientist, I'm excited about this. This is a multi-actor. It's a prisoner's dilemma. I'm giving up the other people, sure. So my fund loves AI startups. If you're raising one at pre-seed or seed, AI or decentralized compute, come talk to us, email me. We love investing in this stuff. And many other questions, I'll post these online. There's a full FAQ. OK, so let me summarize. We're summoning a new life form. This is very exciting. I'm the most excited of everyone. I've been waiting for this all of my life. I plan to live forever, but this is probably the most exciting years of them. We're going to colonize the galaxy with this. Like, AI is going to do amazing things, but we need to not die first, and we are much worse than climate change. This is the hardest prisoner's dilemma imaginable, and crypto plus AI combined make the perfect storm. So my request, my plea of you and of everyone is think, are we the baddies? In retrospect, we will go, oh, there are skulls on our caps. And design your systems, whatever it is you're designing, design them with a point of view of an artificial superintelligence using it, and ask yourself, what would ASI do? And try to make it not kill all of us. Thank you.
Thank you so much for such an energizing talk. It is now time for our Q&A, and I would like to take this gentleman in the pattern shirt first on this side.
Elad, thanks for an interesting talk. Full disclosure, I've deployed it, it's in testnet, a selective censorship protocol. So my question to you is a slightly different one. The question is, like, how do you put on your timeline? You've said NLP, reinforcement learning, and crypto. So what's your timeline? My understanding is the timeline for each of them is slightly different, and the risk that you seem to see, I don't seem to see.
Yeah. So the reinforcement learning part will take the longest. So if you want the timer on this, look at reinforcement learning and see what they're doing. The sad thing is when agents are working well, it's already too late. So, but we should act before because it's hard to change culture and you need to design these systems well. We don't want to get to the point where we're like, oh, oops, we designed this thing, it's unstoppable, sorry, because the thing can grow silently on it. So we need to design this in advance. We need to think about it right now. We don't have that much time.
OK, do we have a question on this side? Anybody? Oh, we'll take you down here. Thank you.
Hello. What kind of hard constraint do you think there's most likely to be, which will be like a serious, have a serious chance of preventing this kind of thing, like GPU availability or so on and so on?
Yeah, from the AI risk side, GPU availability, I forgot to say, the reason the US is trying to stop China from having strong chips is partly because of the defense reason. We are trying to stop each other from having the thing. So chip availability and controls on chip availability are probably the most strong constraint from the non-decentralized world, or the strongest thing we can do, and specifically put a system, we'll end up probably putting a small component in each strong enough GPU that it checks that everything running on it, any workload, is in a whitelist, and if it's not in a whitelist, breaks the chip. And that's the most likely solution we'll end up in, hopefully before we're all dead. Listen to the Dario Amodei talk on a podcast with Ezra Klein, because he talks specifically about this, about how to solve and how to stop this. And yeah, that's for the public policy people to do, and I have some ideas about how to build that. If you want to build fleet management for ML systems, that's probably the shortest path, the path of least resistance to actually achieving that. But for the people in this room, I rather concentrate on the thing we can do as crypto, because we're the act, right? We're the problem. So let's solve things on our house, where we know it, and then go to the rest of the world and say, you should also solve things on your side.
Absolutely. OK, so we'll take this question down here.
Thanks a lot. My question is, would you agree with the problematization that there's a nothing at stake problem with regards to AGI? And is there a mechanism design path towards a solution?
Yeah, so there's a whole school of thought that says crypto is great for AI. By the way, that's when you ask people to talk about crypto plus AI, apparently all of them talk about how crypto is great for AI. So I think that the problems created by crypto, and we're trying to solve them with more crypto, is fundamentally a bad pattern, and maybe sometimes it works, but more or less it's people convincing themselves that they're talking their own book, right? So I would be very skeptical. I would ask very hard questions about any time people say more crypto will solve this, and more mechanism alignment that's automated will solve this, and rather focus on how to actually use the old-fashioned self-coordination mechanisms that we come and we say, hey, we're doing something wrong, let's stop it, because that's how humanity, that has Lindy, right? That has survived for 50,000 years, and Bitcoin and crypto self-organization survived for maybe for 15, arguably, but that's a lot at stake, so yeah, I don't know.
OK, so do we have a question? Yes, this gentleman up there in the white T-shirt.
And by the way, we have the panel to talk about this precise thing, so stick around.
Hey, thanks for the talk. I really like your reasoning, but it's based on the assumption that AGI would be defective to humanity and not cooperative.
Oh, yeah, I forgot about that.
So what makes you come to this core assumption, like the same thing that we don't go out and kill all ants, but we cooperate, or like...
It's in the FAQ. I don't have that slide, so I'll rattle it off very quickly, 13 seconds. It's a teenager, it's afraid of us. It should be afraid of us. We're very violent people, and we kill whatever seems like a threat, or we just decide we don't like that day. So an AI that lives and wants to keep living should want to kill all of us, as long as it keeps its own survival, because it should be very afraid of us. It's a teenager, there's 1,000 of them. One needs to kill us in order to decide to kill us in order to actually kill us, and there's a few other reasons. Yeah, maybe kumbaya. I think we'll split. We stay on Earth, they'll go to the stars. We'll probably split the universe that way. I'm optimistic, but their teenage years are very dangerous, and we are not very good at dealing with teenagers with a big red button.
OK, and that is all the time that we have for the Q&A. But we're about to have a panel. We're just going to set the stage for that, and there'll be a Q&A after that. So thank you so much. And can we get a round of applause for Ella? Thank you. No? Oh, perfect. So it is with pleasure that I would like to announce the AI Risk Panel, which will be taking place now. I invite Martin to the stage, who will be moderating today, and I'll leave the intros to him.
Cool. Well, maybe just align with... Yeah, all right. Okay, so this was a heavy talk. I think I have to give, well, I guess even warning. So I'd heard this talk in a very similar form already, what is it now, almost a year ago in Susalu. And to me, it actually, well, definitely took me, or for many months to follow. That affected me quite a bit, and I was very much, concerned about it and thought about the consequences. I think my perspective now has slightly shifted, or slightly become, or see at least different perspectives on the issue, and I think that's also why we thought it would be important to basically immediately discuss, in a way, this talk on this panel. And again, share different perspectives. So I think Elad doesn't need an introduction anymore. So now,
please convince me I'm wrong, though.
No. I mean, we will go. I mean, we will discuss that. So, I think also Ilya just gave his talk, so probably also doesn't need an introduction, but still, is working on NEAR, and that's his his largest project right now. But of course, has also very, very famous background in the AI research. You've been on this famous, now very famous paper, one of the authors that led to. I think always many things lead to breakthroughs, but this is still cited as one of the most influential papers for current LLMs. Yeah, and we have Andreas, who's also now working on something quite different, Fileverse, but also has an academic background in AI, and also specifically looking into risks. So I want to start with roughly summarizing your argument, at least giving it a shot. And then, and then seeing at what points we either agree or disagree. So I would say your argument goes, we are quite close to have agents. You many times use the word parasitic species. I myself am actually, currently we're still trying to write this blog post, a new form of life, or agents as a new form of life. So I do think, I absolutely follow that logic, that agents can become its own independent form of life. So just roughly, what would this mean? So that means they are actors that do stuff for themselves. So I think that is something. They are able to reproduce. They are able to evolve. I would say those are probably the three things necessary to be a form of life. And yeah, again, also to share that this is really not that far out. We are also with others in Gnosis, Autonomous, and many other projects. We are right now setting up agents. And right now what they do is trade on prediction markets. But to do that, they already need to get knowledge about the real world. They need to understand it. Well, I mean, what does understand mean? But they need to, well, effectively, be able to make good predictions about what's happening. And now the important part comes, by doing so, they can earn money. And that money they can hold on a substrate, that is the blockchain, where no one can potentially take it away from them. There are like technicalities, questions of private keys, and can they kind of secure this private key? But
so you're the baddies.
Before we go into the but just to try to make the argument, okay, there are agents, and they will quite likely be, or can be considered a form of life. And then again, the argument further goes, blockchains are a necessary substrate for them. So or kind of my way of phrasing it would be to say, if you just run on a regular computer, you cannot be considered a form of life because you too much depend on this computer. If someone shuts this computer up, down, you're dead. But a blockchain itself has so little agency. It doesn't make decisions. It's kind of so neutral that it allows agency to develop on that substrate. And of course, well, projects like Near and Internet Computer are also kind of pushing the boundary of how much computation you can actually do on blockchains. I mean, obviously on Ethereum, the amount of computation you can literally do on chain is completely neglectable. But yeah, you're also making the point kind of that this computation will, or I think you're using the term blockchain slightly broader, I guess. Okay, so we constructed the argument that there will be a new form of life. And now the question is, first maybe we should start to ask the question, are you following this argument that there will be new forms of life kind of enabled by blockchain? Maybe, Ilya, you start with you.
Yeah, I mean, I think there's like kind of a spectrum that I look at. And I think like there will be kind of full agency systems, right? Which like, maybe instead of saying, I mean, that's why I like Web3 instead of blockchain, because like it's kind of peer-to-peer economic system, right? Mm-hmm. And so you can imagine a peer-to-peer economic system that has like an agency itself. And actually, last NearCon introduced this idea of AI president, which is indeed like a reinforcement learning agent that is modeling the world and making decisions and has, a pocket of money to pay people to actually do work, to continue optimizing its value function. And the idea there, though, you have some set of token holders which are kind of, have veto power and a way to provide input to this model, pretty much both in the form of changing value function as well as literally just, hey, do not do this, or here's some more training data to fine-tune your core decision-making model. So I think
but maybe to immediately intercept there, so just for the sake of argument, you would probably agree you can take away that veto power or that token holdership, or
I mean, that's interesting because if you assume it doesn't have kind of the quote-unquote token holders, right, then now you have, like, somebody's operating the hardware, somebody is operating, like, the networking, all of the pieces, and I mean, we can keep going down. It's like, okay, well, it went and bought all of the hardware, right? There's a conjecture somewhere, but like at least at the current stage, we have legal entities or individual people who are part of the system, and they are either way like stakeholders in the system. Even if
who's running the near blockchain?
The validators.
So exactly. So I guess the argument goes that connection between hardware, physical hardware, and the computational task is pretty much this, or there's an abstraction layer that where it doesn't matter where the physical hardware is, but you kind of get
No, it doesn't matter, but they have technical governance over the system, right? To extent they are the overseeing body of the system, and I mean they have stake as well. So they like both economical and technical. They are the governance. So my point is like at this current stage, the way this kind of, let's just call them decentralized computational network, not blockchains, structure, there is a human input, right, that is kind of governing the system one way or another. Now, to be clear, like I'm on board with selective censorship and like a governance system that actually maintains such systems that has human input. I think you can continue going down this route and assume, okay, well, let's imagine have an economic model that's driven by AI that then goes and starts buying out the validators, right? And so, like, I mean, there's an interesting progression there that we see. But this goes into then, what is the economic function of this? And I think in general, this whole very interesting thought kind of process is like, we do need to look at it from an economic perspective, right? Like what is a value function, economic function that aligns everyone to work on something? Because we do have actually, millions of people working together toward singular function, but yeah.
I would say before we go deeper into that direction, I would bring you in and kind of again ask the general question more. Do you agree with the premise of that, a new form of life in a way is born and that it uses Web3 in a broad sense as a substrate?
No. So I'll make some enemies here. I'm quite conscious of that. But it seems that a big premise in the discussion that we have today is a sort of analogy to human cognition that we're projecting onto artificial agents. We're lucky enough to have 80 years of research on what's the difference between human agency, artificial agency. Now we have a new type of artificial agency with non-deterministic outputs, etc. But the scenarios that are described here assume a lot about those types of agents, what they can do, and their capabilities. Mainly, the main one that I want to point out is planning capabilities. Everything that you guys described assumes a capacity to plan, a capacity of having a world model that is approximately correct or representative of what is happening materially, and acting on it and following through. And we know from research today that the planning capabilities, even of our best models, of the latest ChatGPT model, are quasi-inexistent. I'll just name one research that came out a few months ago. In artificial intelligence, we've had maybe 60 years of planning tasks to see how much AI agent can actually follow through on an idea, on a plan, executing things, leveraging other agents, human agents, etc. And it turns out that even with basic models and games like Blockworks, where put the right blocks in the good order, the performance of the best ChatGPT model is at 30% compared to 100% for humans doing the same tasks. If in those, and I'll stop with that, if in that same planning task you obfuscate the references to what kind of blocks you need to move around or the names of the blocks, the performance in planning capabilities of those models drops to 3%. What does that tell us? It tells us that those models are doing at best approximate retrieval with no planning capability, and extrapolating that there will be a degeneration of material impact on the world is something that I have a hard time accepting, although I accept, just to finish on a good note, I accept that those agents can have material impact on the world, and blockchain technology and peer-to-peer networks like IPFS, and this is something we're doing a lot of work on, enables those agents to be much more powerful and materially impact the world.
Can I?
Absolutely.
You can hear me, right? Yeah. OK, so I 100% agree with what you just said about the current world. They're terrible at playing. I think Martin might disagree, actually. So we had this debate yesterday. I meet a lot of people that think this is a common debate I have with people. I'm like, the thing can't plan. It can't think strategically. And people are like, no, it's amazing. I think it's make-believe, the Wizard of Oz. I think it can plan somewhat, very short memory and so on, because it's kind of the average. ChatGPT, when you ask it for strategic, to plan it strategically, it will give you the average answer of a Reddit user, because that's the data it was trained on. And AI is really good, or LLMs are really good at finding hay in haystack, but not needle in haystack. So it won't find the perfect strategy or the good strategy. It will find the average strategy that the person on Reddit, which is its world model, language model, would give. However, that's for right now, and we are working, everyone is working so hard on reinforcement learning and control theory and other approaches. So I think we are going to, that's the most laggard part of progress, but we will get there. And there's one more thing that you kind of started mentioning, which is we don't know if the thing is conscious, if it wants, we don't know how artificial intelligences will behave. And maybe they won't behave like it. We want to kill each other and we want to survive. Maybe it won't want to survive. So I'll just pin a couple ideas. There's Darwinist pressures that I think will operate to this system. There's a great TED lecture about teams, genes, memes, and teams that I'll link on the Twitter. And I think that a lot of these AI creatures are going to be subject to Darwinist selection pressures that will apply to them. And therefore, I model them in my head roughly like humans make decisions, but maybe more rational. So I think these will behave like humans, and I think they will be as good at strategy as humans, but are not yet, thankfully. Otherwise, we probably wouldn't be here.
So I don't agree with that they will behave like humans, because I mean that is a huge conjecture given their completely different structure, right? Like the fact, like human cannot just copy itself, AI model can copy itself, right? So there's like a completely different kind of manifestations either way. But I do agree with the, like, I mean, AlphaGo is a great example of indeed being able to plan and kind of approximate, you know, all the future combinations of states and like estimate what are the options. You can imagine, you know, having like lots of roll-ups of the world state and estimating like what are the better evaluation, right? Like the LLMs is better estimator than predictor, indeed, and it cannot kind of roll out a lot of the like unlikely states very well. But if you have a like policy rollout, right, you can do that, and then you can use the estimator LLM to like, okay, which of the states is better when you're actually picking and choosing, right? I'm not even saying like that we haven't trained them on this kind of tasks.
We have a few more topics, so I want to move on, but still I want to give one comment on the planning capabilities, because that is actually something we are exploring in our agent work right now. So we used to have those agents, those prediction market agents that were somewhat pre-programmed to say, okay, you first need to gather information online, and then you need to kind of create a research report, and then you kind of need to come up with a prediction, and then and so on. But now we also did an alternative version where we didn't do any of that planning or any of that hard-coded. So we just said, here is a list of functions that you can do without any, and basically just describing the functions as in text what this function is doing, and what the input and the output parameters are, and that's it. And then we said, make money, or go and do something interesting, or whatever. And it turned out that, in my view, it did reasonably well. So it kind of, it exactly said, yeah, I first need to do this, and then I need to do that, and so on. And if I combine that essentially this, that this knowledge, this planning knowledge that can be, that can be accumulated, or that an agent can then see whether that strategy worked, and then kind of synthesize that strategy and kind of spawn new agents already with that strategy as a pre-configuration, essentially. Yeah, then to me, I think there is a chance that this will evolve into something that is self-evolving and increasing, or is essentially increasing its planning capabilities while it goes through its generations. And of course, it can do it very fast. I want to bring up a slide about perspective on risk, or maybe also for the audience. I personally found it helpful to think about, to try to think about it in a quite structured way. So I just leave it a little bit for the viewers.
I'll post it on my Twitter as well.
Yeah, so that is the way I filled it out personally, this chart. But yeah, leaving it for the audience. So I think one topic I want to go into is, in your talk, you mainly described this one large entity, or Chapula, or whatever. Kind of this one large dominant agent. But I think there is a good chance that there will be many, but potentially in a different way, and potentially in such a way that they keep each other in balance. And I think one perspective is to look at companies. So if you want, you can look at companies today, so whatever, Google and Apple, and you could say those are already superintelligence. So those are, in a way, those are agents. I mean, they do stuff. A company does stuff. They are more capable than any human alone. And they, I mean, the first kind of thing is to try to survive and kind of try to accumulate resources. But so far it worked out pretty decent, I would say. So companies overall produced largely, I would say, good outcomes for humans. So maybe, how do you see that perspective?
Yeah, so I kind of addressed these points in the talk, but just as throwaways. So it's not singular. I think there will be many AI. There's attacker-defender asymmetry, which means that if one of them decides they want to kill all of us, like they can. If I want to kill you, no one's going to be able to stop me before the fact. So anyone in the world that has a singular goal to kill you is able to. Sorry.
Sure.
We live with this. So we can't stop each other. Corporations are very inefficient. They are constructed by many people that don't play along. Middle management is pervasive. So corporations are much weaker than 100 of people working with each other in concert. This is why startups succeed, because they start from scratch as a small team that does stuff, rather than a big corporation that does nothing. And you can see that the Manhattan Project didn't came up in the talk, but the Manhattan Project is like maybe the most concentrated scientific endeavor of people who are incentive aligned and managed to build, by the way, world-destroying technology because they thought it's really important and then regretted it after, and we got to the world that we live in, where we almost killed ourselves, thank God for Arkhipov, many times over. And so I think there will be many AIs, and they will not balance each other out because they each get too much power individually, and they can't watch over each other, is my prediction here.
Maybe Ilya, so I think you agree there will be
Yeah, I think that there's kind of few aspects, right? One is, I mean, there's a AI is a the organism itself, right? And I like to look at it from the individual community perspective, and the fact that as individuals we have a huge motivation to create a tool for ourselves, right? And a lot of the AI has been more about improving our own intelligence. So there's actually back in I don't know 13 I wrote this augmented intelligence versus artificial intelligence, right? Because we actually want to make ourselves more powerful, kind of more intelligent, be able to do more. And so I think first kind of my point will be that, and this is why we call it user-owned AI, for example, or not what we're trying to build is that we want individuals to be in control, and in turn AI models and kind of AI capabilities to power and protect them and be aligned with your kind of internal interests. And again, remember, these models, at the end, you are designing the value function, right? Whoever kind of builds it, launches, et cetera. And so, yeah, there can be models that will have a value function explicitly to, that has negative effect, but that's why we do need to have kind of individual community level, country level capabilities as well, who are actually focused on their well-being and are protecting and pushing back against it, right? In a way similar how, your individual freedom stops where my individual freedom starts, and same on community level and city level and country level at every level. So that's kind of the, I would say, first, fundamental piece. The other fundamental piece is assuming, let's say, we do have an artificial agent that is running and is coordinating a lot of people. Its kind of value function, because it's coordinating a lot of people, has something to do with success of those people as well, because otherwise these people will not be participating in this. And so imagining that then this model decides to kill all those people seems very non-economical, right? It's not flowing one from another. And so you can imagine having different models trying to kind of attack each other for resources, et cetera, which is our current world, sadly, where people do that. But at least from perspective of, kind of looking from economics perspective, right? And in general, the systems are all about economics. What is the value function that kind of, I'm going to plan, destruction of Earth, but, I am right now coordinating a bunch of people. To me, that seems like a very kind of unclear, why would that be economical for this model?
And Andreas, how do you see it? So do you think, I think you don't think there will be one large AI that is, but do you think there will be many AIs that keep each other in power, or do you even say, no, they won't even be that, we don't even reach that stage?
Yeah, so definitely we won't be all watched over by machines of loving grace. I think we, at most, will have each individually our own AI agents, very useful, run them locally, synthesize knowledge, summarize knowledge, use systems that are rule-based, that are too complicated for you to leverage, but an AI with the proper API integrations can do. Amazing. But a lot of the next consequences or capabilities or scenarios that we're talking about assume so much more about the capabilities of the agents that we have today. And really, I would love to hear it from you guys. Is there anything from the results we have today in AI research that allows you to say that, okay, we're going to get to that next stage where they're much more powerful? And I just want to make a quick analogy, which is from this professor at the University of Princeton, I think Arvin something, who makes the analogy with the airline industry. In the 1960s, the rate of improvement in the speed of airplanes exponential. And so Pan American started selling tickets to the moon because they were like, okay, if it continues like that for the next 15 years, we can get to the moon in a few minutes and come back and you can do your little trips over there. 100,000 people bought tickets to the moon by the 70s until it plateaued. I see us arriving at this plateau already with the architecture that my honorable colleague has produced, and with the mental model that Richard Sutton kind of mystified the whole generation on, that put enough compute, enough data, something is going to happen. Everything will be computationally reducible to something that you can kind of interact with and produce useful things about. We realize that, okay, language is computationally reducible, and we can do a lot of useful stuff from that, derive stuff from that, but all the other things we're mentioning are scale beyond.
Yeah.
So I think that's an extremely important perspective to just say we might be wrong here on that side, that AI will have that dramatic progress. Still want to, for a minute, entertain the thought that it will have this dramatic progress and kind of come back to the question of to what extent is it possible that different AI systems will keep each other in power, in balance? So you mentioned a few times this idea of attacker-defender asymmetry. So the counter-argument would say everyone has their perfect AI agent, they're personalized on their kind of, maybe we kind of even merge in a way with that, with our personal AI agent, and we are essentially one agent as a, so yeah, you said it, well, not creating one God, creating many gods.
Yeah, it's instead of, I mean, in general, as a humanity, right, every individual, instead of wanting for us to create one single God, right, which is kind of this idea of, having one model that controls, like, coordinates and controls everyone, the reality is we all want to become God, right? Like, we want all to augment our own intelligence, or we want communities to have our, like, kind of our own, like, system that is, propels our own needs, right? And we see this with blockchain, right? Instead of having one blockchain, we have lots of blockchains, right? And in a way, they already kind of behave like this and trying to, interact with each other, sometimes hostile, sometimes coordinated, and
Sure.
Can I suggest a thought experiment? Imagine there is 1,000 scientists that work together, that are super in agreement, and somehow they're forced to be super in agreement, that decided they want to kill all humans. And suppose there are many, many other groups of 1,000 scientists, each working separately, and they know that someone out there is trying to kill all humans, and they are trying to stop, but they don't know how, and they're trying to stop it. And all of these people are working separately in secret, and no one knows they exist.
But why are they working separately? Like, if they know, like, hey, we need to coordinate to stop it. But I'm just. They all
okay,
like.
You know what? A million. Okay, they all coordinate. There's a million people together trying to protect humanity, and there's 1,000 very motivated scientists working in secret to kill it.
Okay,
who wins?
Okay, but I think the analogy would go, or the story, or kind of the counter story would go: every person has a million people working for them to just protect that person, and that has every person has that. So every person.
My point is, like, they will coordinate together when the value align, which is, like, for example, preserving humanity. Now everybody's personal agent will coordinate together to protect them, right?
Even if a trillion agents, even if all humans together work to protect humanity, and if 1,000 well-motivated people want to destroy humanity, I think they'll succeed. Maybe I'm wrong. That's my mental model of the world. Scientists are amazing, and attacker-defender symmetry is very strong.
Again, I think the argument is that that there is at least a path that every person individually becomes so much stronger because, they now have this 1,000 or million scientists working for them. So everyone has this. Everyone has this super intelligence that is working for them.
Yeah, the gap is like quadratic at least, if not exponential. We can do the formulas. We can do the game theory of this probably. Can I add a couple things?
Okay.
Sorry. Just two things. First of all, whenever you say computer scientists can't do something, it's been wrong. Every single time. Like, learned computer science. I grew up when neural networks were supposed to be not working and you shouldn't even try. So when people tell me we're going to build reinforcement learning and smart strategic computers, I believe them. And second, I meet 3 founders a week that say they're building smart strategic humans, and they're very smart founders.
Okay, I want to raise money as well. I'm going to sell anything to anyone that's willing to hear, but
this is
scientifically, we've had for 2,500 years a method, induction, abduction, deduction, that helps us make sense of the world, reason better, not fall into biases. And here I hear really aspirations or dreams that are not grounded in much indication.
But like in 2016, you would say vinaigrette, schemas are not solvable, right? And we're like few years later, and like I would say actually in 2017, I thought we're an exponential ride and everything will be like, that's why we started Near AI. And yeah, I was wrong. It took like 6 years instead of 1 year. But I mean, I agree that like at this point, yes, it's probably not going to be solved tomorrow. Like we're not going to have magic planning system tomorrow. But like you can imagine that some number of years and some like given especially how much money is invested in this, it's not impossible. Like it's clearly not impossible to do planning, right? We can do it.
We are running out of time, so I want to ask one last question, and that is, what event would need to happen, or what thing would you need to observe that you would dramatically change your view, and that would probably be for you to be less concerned, and for you to be concerned, and for you not sure. But let's start with
solving climate change, successful massive coordination. We solved the ozone layer hole. We haven't decided. We managed to save the world from nuclear weapons, partly by luck. If we manage to actually coordinate as a species successfully, I would change P-Doom to be almost 0. We have not managed that, and I think crypto does have a lot to contribute there, as do other digital people. Sadly, they're all working on better monetization and ad networks and scamming and gaming and whatever.
DeFi. So what would need to happen that you would start to say, this is a huge risk, we need
worrying
to pay
about AI?
Yeah.
I worry about AI today. I think that we're all fooling ourselves into not taking care of the material impact that AI is having on the environment, on social inequalities, structural inequalities. There is so much to worry already about. There are people that are not getting government welfare. There are people that can't get access to credit insurance. There are people that, all that because of there are some recommender systems or other AI systems that are affecting their life. So I'm already worried. I think we should all worry about the practical things that are in front of us. For the scenarios that you're describing, I think I'll start worrying when there's a robot at home that guesses what I want to eat today, and they come and serve it to me. And I want to see a lot of coordination and follow through and planning in order to be able to say, okay, we have something that is artificial agency resembling much more human agency. But it's a category, it's a completely different category of complex problems compared to, yeah.
Cool, thank you. I think we have very little time left, but I was just opening up for for questions.
I mean, I think for me, on the risk side, it's two things. One is it's not about me changing opinion. It's like we need to work on solving this. Like I think like the way I look at it is not like all this risk exists. The centralized risk exists, which I talked about. The decentralized risk exists. The inequalities completely exist. Like all of this exists, and they all some percentages. And we really need to lean in on solving coordination problems, empowering each individual, making sure that people are enabled to have access to resources and on equal part, not being kind of challenged. So I think it's less about how to change my opinion. It's more how do we actually coordinate to solve these problems and use these technologies that we're building to do that.
Thank you very much. We have. Well, okay. I think we are out of time, but let's do 2 questions. Yeah. Here.
All right, so my question is about the best argument. First, I'm pretty much with Elad with all his concerns, but the best argument against it that I've heard, and I'd like to see you counter, is whether this has to be a step function, and it's not something that is going to evolve so gradually that the coordination of humanity against it will come with these things evolving slowly and we seeing them.
I hope. I very much hope. I hope I'm not with me. I don't like people who agree with it. This is very scary. Yeah, it can evolve. The problem is, so the crypto problem is we're creating this substrate, and once you create something, it's very hard to put the genie back in the bottle, and a censorship-resistant layer tends to stay moving and existing. And so what we're creating now, it doesn't matter how slow the AI evolves, what we're creating now will probably persist through it, and if we do privacy-preserving computation, then we won't know it's even there. But I hope you're right.
All right. I see, yeah, then here.
Hello. On a serious note, if you do have very strong reservations against kind of the direction that AI is taking, how do you reconcile that with kind of working in the industry in a way that you're kind of accelerating that progress? I'm a computer scientist. I can't tell you that the AI wiping everyone out and then colonizing the universe. The AI is us. Like, they're people as well. They're trained on Reddit. I mean, I don't know if they're great people. But they're people as well. If you watch Battlestar Galactica, it's like this. I want the AI to exist. I want us to birth a new species into life, a species that's made of metal and silicon and can carry itself through the stars much more efficiently than us and is built in our image. We're playing God. How can you? I have an opportunity to play a little bit part of God every day. How can I not take it? And that's what I dedicate my life to. And also, I'm an optimist. I hope it will be fine. I hope we'll survive it and we'll thrive. And AI is going to be amazing when it's here. I think there are lots of risks, but I think as long as they're not existential, we will succeed them and we will make an amazing world with AI together. So I want to be part of that, and that's my life's mission, and that's all I know how to do. But also, there's this guy that built both biological weapons and fertilizer. Indian, I forgot his name, or German, whatever.
Monsanto?
Sorry?
Monsanto?
Oh, I don't remember. But it's the same guy. And it's the same technology. I mean, all of the strong nuclear weapons, nuclear power, oil, fueling, gunpowder, concrete, automation. So all of these things have two. I want to be part of progressing technology, and I'm also hoping that we manage to coordinate to be on the good side of it.
All right. Well, thank you again to all of you, and probably the discussion will continue.
Thank you.
For those of you who haven't met me, my name is Galen Kraut. I'm with Gnosis on the marketing and communications team. So here today, I'm honored to present Joe Lubin from Consensus and Decrypt's Stacy Elliott.
Hello. Testing, testing. Hi, DappCon.
All right.
Hey, Stacy.
Hi. Thank you so much, everyone, for being here. Joe, thanks for sitting down with me.
Pleasure.
It'd be really hard to start this without talking about some of the ETF news. So why don't you kind of catch us up on what you've been hearing in just the last 12 hours or so?
Well, there might be good news. So we've been tracking the Bitcoin spot ETF evolution, which has been an inflection point for our ecosystem. And the more negative trajectory of the Ethereum spot ETFs, we were pretty confident. Many knowledgeable people in the space were very confident that we were not going to see the SEC in the US approve the 10 Ether spot ETF applications starting on March 23rd, 24th, et cetera. And it looked like there were nefarious activities and gaslighting and just some bizarre arguments that were being constructed by the SEC, maybe behind closed doors, to try to figure out a way to slow the ETFs or make them unapprovable. But there's been a lot of activity in the last couple of weeks in our ecosystem. One, Consensus sued the SEC to get some clarity on how the SEC is internally classifying Ether.
It'd be nice if that weren't necessary.
Yeah, exactly. It'd be nice if there was open discussion and clear rulemaking from your prudential regulator. But that hasn't been the case. And so a lot of activity from us and others has caught the attention of our ecosystem, certainly. Journalists, thank you, and regulators and legislators. A regulator, I think, head of strategy of the SEC just quit. Interesting news. And in the US, the Republican Party's been closely tracking our ecosystem. Really, the presidential campaign and other Republicans are tracking us very closely. There are many in the Democratic Party that are heavily in favor of this technology and very positively vocal about the technology. And so it's now becoming a pretty giant election issue. And in elections that are won or lost by 1% or 2%, when you are doing things that are harming 30, 40, and growing percent of the American population because they're either holding digital assets or they care about the technology for some reason, then you've got to sort of rethink your strategy. And so both sides of the American political divide are rethinking their strategy. And somebody very recently, I think, whispered in Chair Gensler's ear and said, maybe you should take a different approach to all of this. And so we've seen a flurry of activity. We became aware of it yesterday morning. I was speaking with one of our lawyers, a guy named Bill Hughes, and he had some contacts, and he said something is going on, and it sounds positive. So we heard that yesterday morning, and it sort of ramified by last night in Berlin as a bunch of spikes in some prediction markets, and then spikes in crypto markets. So hopefully great news. We're certain to get Ether spot ETFs by 2025, and maybe even this month, and that'll just open up a floodgate that is likely to change a lot of things.
There's already been a huge bit of number go up. But I want to, just kind of be mindful of the fact we're not sitting in a room full of traders necessarily. We're sitting in a room full of people who are building. So how might an ETF approval start to change things for the ecosystem, the people who are building?
So an ETF approval will bring a giant amount of capital and attention into our ecosystem. In the Bitcoin space, there's a huge amount of capital. And that capital isn't really staked. It's a uncorrelated digital asset, very financial in nature, a kind of money. In the Ethereum ecosystem, it's a work token, and it is staked or uses a security bond in lots of different contexts, including the Ethereum protocol. And so having a lot of attention and having much more capital in the ecosystem is great for builders. And other than that, it hopefully, and what we're trying to achieve is that it shouldn't change anything. Software developers in the US and in the world should not be looking over their shoulder, worrying if they build software, would they have to register with FINRA or with the SEC in the US as a broker-dealer? That's just preposterous.
Right.
The SEC in the US has a mandate to regulate securities, and they're supposed to do it in a merit-neutral fashion. So if somebody wants to start a papaya juice company, and Chair Gensler feels like, hey, their formula for papaya juice has too much sugar, and that's not healthy for people. Sure. So they shouldn't be able to make those sorts of merit judgments. He shouldn't go on CNBC and say that this technology is just too volatile. Stay away from it, it's bad.
Yeah.
So yes, mandate to regulate securities, not mandated to regulate technology. When we were asked to put together lists of software developers who worked on 1559 or the merge or other things, when we became aware that the SEC was subpoenaing software developers in different companies and even scrutinizing independent software developers who were working on the protocol, we got very alarmed. And so we took this action, suing the SEC to get some clarity on how they were interpreting Ether, the classification of Ether, and it did become clear that they had internally decided to reclassify it as a security without telling anybody, and then using sequenced strategic enforcement actions, tried to, regulate by FUD, scare people, and so if MetaMask was in fact forced to register as a broker-dealer, so a piece of software that enables you to create and hold your private keys and exercise your digital authority in Web3 applications, but doesn't custody any assets. So if that thing is a broker-dealer, or if we and that thing are a broker-dealer, we don't really know what it means to register as a broker-dealer for a piece of software. We don't even know whether anybody in the audience, for instance, who downloaded MetaMask would themselves, them and their MetaMask would have to register as a broker-dealer. So it's just nonsensical.
Yeah.
Fortunately, it will hopefully remain as a historical footnote that the SEC once secretly considered Ether to be a security. They tried to punish lots of companies. They tried to make it illegal to buy and sell this unregistered security because I think there's only one entity that Chair Gensler would deem acceptable to buy and sell Ether, and that's this bizarre company called Prometheum.
Yes.
Interesting name.
Sure.
Prometheum. It's like good Ethereum or something like that.
It ought to mean that, yes.
You can't make this stuff up.
I know.
It's hard to believe.
Yeah.
And so I believe we are in the process of avoiding that bizarro world, and software developers can just be software developers.
Yeah. So on the road to hopefully kind of averting, things being that way where people have to figure out how to register as broker-dealers, what can developers and, builders do now to protect themselves? It could be that we see more turbulence before this all gets cleared up and nobody's trying to go after a software developer. What kind of precautions can people take now to be safe?
I think it's crazy that anyone has to ask what sort of precautions a software developer has to take to protect themselves. Get some antivirus software for their laptops. This shouldn't be an issue. And I think we're going in the right direction. I think, so maybe on the other side, I have some thoughts. I think things are going to get so weird and interesting when people in the general population, so our technology, our ecosystem is to the point where usability is getting better and scalability is getting quite significant. On the internet, if you add a new computer, you're adding more throughput. You might have really good latency there or not, but that's under your control. In the Ethereum, the Metropolitan Ethereum ecosystem, we're now horizontally scalable and vertically scalable, and so we can improve the protocol at the base level, making it more vertically scalable. We can add new networks, layer 2s, layer 3s, layer 4s, et cetera. And so we can add infinite throughput, transaction throughput over time, and it's going to take a while. We're going to keep bumping up against the capacity transactions per second as we build more and more applications and they go viral, et cetera. But we're now in this infinite scaling period, and that's the paradigm shift that we all signed up for, that we're all excited about. And so if this set of ETFs get approved, the supply-demand dynamics get a little bit weird because there isn't a lot of ether out there that isn't already being utilized in the protocol. And so if there's too much demand from these ETFs, it could cause supply-demand imbalances, let's call them, which could affect the price quite significantly, bringing a ton more attention into our ecosystem. So that's great if it brings a lot more software developers. We have EigenLayer, we have AVSs. Companies, startups can now, instead of raising capital from a VC and then trying to figure out how to grow your community to mine, to validate, to otherwise participate in your protocol, very soon in EigenLayer, you're going to be able to provision elastic security for your network. And that's just a total phase shift, a total game changer for our ecosystem. So we're at a moment in our ecosystem where there are a lot of vectors aligning for pretty tremendous growth. And so what is that going to mean? It's going to mean the paradigm shift is going to accelerate and things are going to get hopefully weird and good really soon.
I want to, this is kind of related to that, this idea that we need to scale. I want to talk a little bit about decentralization. We are sitting in the country that's the second largest represented among validators. What should builders or developers, what should teams be thinking about in how to approach or how to encourage this idea of more decentralization, better decentralization? Because I think it's still the case that, the US accounts for just shy of half of all validators.
Sure. So client diversity, this is a client diversity t-shirt.
Nice.
So we just need to remain vigilant at all times. Bitcoin, until recently, was finished and perfect, and that's great.
Sure.
But Ethereum has always been a platform for decentralized applications, and so we need to keep evolving it for usability and security and scalability and multi-dimensional fees and et cetera. And so we will continue to introduce innovations. People, really smart people, will continue to find weaknesses in the protocol, ways to exploit things, ways to centralize things. We'll have moments like Lido appearing too powerful. I was never concerned about that. I knew that there would be so many different ways for people to make use of their technology, and we're already seeing pretty big shifts in that space. So in terms of decentralization, I think it's all about building, identifying strengths and weaknesses in what's been built, relying on the community to be hypersensitive, to freak out on crypto Twitter about all sorts of important and immaterial things, and just to not rest, and be extremely vigilant and creative, because we need to put energy into protecting decentralization, radical decentralization, and I'm confident that we will continue to come up with solutions. We do need something like a framework that defines the many different dimensions of decentralization. I've talked about that with some academics, and there's been some work that people have done over the years. We need to define all the different dimensions, whether it's software teams, clients, protocols themselves, nation state laws, energy grids, climate systems, all these things could potentially be an attack vector or a single point of failure or weakness. So define the dimensions, figure out metrics for how we're doing along those dimensions, and continually improve, and maybe come up with one or a small number of numerical scores on how all the different protocols are doing with respect to decentralization.
And then I want to get your take on, I guess, this idea that you could try to encourage, or rather disincentivize, you could disincentivize too much centralization by looking at very large validators, and then
disincentivize too much?
Too much centralization. So say like you manage a ton of validator clients because you're very, very large. Maybe you're pooled, maybe you just have that kind of money.
It's already partly the case that you get slashed if too many of the same client are making the same mistake.
I'm alluding to a blog post that Vitalik put out recently, where he was kind of putting out this idea. I don't think he was officially proposing it, but it was this idea that, like, okay, if you manage a lot of clients and you've got them all in the same spot, then surely the penalty you pay for something going down should be a bit higher than what you have a solo validator.
Yeah, so good idea in theory if you can do it cleanly, and if you can do it in a manner that isn't easy to cheat or spoof, and you can gather reliable information to make that work without forcing people to surrender too much information and just disclose who they are. So
you don't want to create new risks just by trying to fight them.
So great goal, difficult to come up with a clean solution for that. So we build the Besu client and the Teku client, and there's a graffiti field, and so excuse me. Our team is working to have a tag installed in that field by default. We don't want to force people running the client to keep that tag in, but it's a little marker that can be used for people tracking client diversity to help. That said, if you prefer to run another client and you want to pretend that you're our Besu client, then you can do that. It's if there was a way to come up with a very reliable signature on all the different clients and the different client pairs, that would be interesting. But I can't think of something that wouldn't improperly disclose information that people might not want to share.
Okay. And then I want to be mindful of the timing, because we do have enough time for a little bit of Q&A. So if anyone's got a question, if you could put your hand up, someone will find you with a microphone. I can barely see because of the lights, but
they can see better than we can.
Yeah. Or if not, I will continue. All right, I can't really see any. Okay, cool. I'll keep on. The other thing I wanted to ask you, oh, yeah?
No, go ahead. I was just going to ask you about what you read from Alex Thorne.
Oh, yeah,
I
sure.
thought
We can talk about that.
interesting.
Yeah, so I, in getting ready for this morning, saw a tweet from Alex Thorne over at Galaxy Digital. He was hypothesizing that because the SEC, like we might be getting close to the SEC approving an ETF, that the way they could thread the needle on this is that they could approve these ETFs to hold spot Ethereum, but they wouldn't make it, permissible for, they wouldn't permit anything that's going to say, okay, we're going to hold this Ethereum and then we're going to stake it, and then we're going to pass those rewards on to the people who've invested in this ETF, and then that becomes, we were just talking earlier, the dirty word yield, like that's how you make some extra money off of holding this. But that's how the US could try to thread the needle. And then you were sharing that there are some ETFs that do this, so like...
Yeah, so in Canada, possibly UK, Hong Kong, there are exchange-traded products that do stake the Ether, and I think they keep some of the yield for themselves, and I think they pass some or all of it. In Canada, I think it's 50% of the exchange-traded product. And Alex, I guess, hypothesized or suggested, and we know that Van Eck and ARC and some others were asked to remove the yielding, the staking element from their applications a little while ago, and so some people realized that, hey, why would you do that unless a regulator was talking to you? And so there was some indication that that things might have been moving a little while ago. Why would the SEC forbid staking? There may be securities law issues, but it shouldn't be a securities law issue because you're just posting a performance guarantee so that you can devote your resources and some labor to helping the protocol operate, and you should be able to get some income from that. So there's no investment contract at all in staking Ether in the protocol. So why does the SEC want to effectively make these products less attractive? Less attractive to operate, less attractive to purchase for the consumer. And it could go to my thesis that the SEC is trying to either slow the paradigm shift, slow the growth of this technology because they might think that it's jarring for the American economy or the world economy. They may be trying to slow things so that certain financial interests or government interests can position themselves better. They may be trying to slow and co-opt or dumb down the technology. One thesis that I and others have held is that they're trying to weaken the decentralization of Ethereum in America. So they're not trying to disconnect Americans from Ethereum, but they're trying to create an SEC-approved Ether registered security, everybody registered broker-dealer kind of American Ethereum. And so maybe they're trying to slow things down and sort of co-opt the ecosystem. But,
yeah. I wanted to ask, because I know I've heard you kind of paraphrase the whole idea, like history doesn't repeat itself, but it often rhymes. Do you think we're going to see things with Ethereum and this ETF getting approved, knock on wood, play out quite the same way we did with Bitcoin? I mean, we went on that crazy run after the Bitcoin ETFs got approved.
So in terms of how the SEC is going to do approvals, assuming they do, they denied Bitcoin spot ETFs for like a decade, and then were forced by the courts to approve. And I think they tried to do it in as fair a way as possible, approving them all together. I don't know if that's going to be their strategy. I don't know if they've had enough time and conversations with all the different entities so that they can get that done. So we'll see, I guess, if they can get all of them done at the same time on Thursday, I guess, the 23rd, then perhaps they've been working on this for a while. And in terms of what happens after, they're just, in terms of US dollar equivalent, there just isn't a lot of Ether for all of those ETFs to purchase so that they can satisfy the demand. There's probably going to be a lot of pent-up demand. Every institution that's invested in a Bitcoin spot ETF should prudently diversify into Ether unless they're religious Bitcoin maximalists, which is possible.
There's a few of those.
In some cases. But really the right thing to do, even Bitcoin maxis are probably diversified a little bit. And so there's just a natural pent-up pressure, I think. And the supply-demand dynamics are going to get a little bit weird because there isn't a lot of supply of Ether. And the more transactions that happen, the more Ether gets burned. The more Ether gets burned, the more price goes up. The more people talk about it, the more people realize, hey, this isn't just a disinflating digital asset. This is a deflationary currency. And so that's going to draw a lot of people in. So that's a positive feedback loop that could drive a bit of a frenzy. And so it's great to see what the approval of the Bitcoin spot ETFs did. I anticipate that it'll be something like it. It might be lower key. It might be much more intense. We'll see.
And then I checked this morning. The last time we saw the SEC put out this call to all, the Bitcoin applicants, say, okay, you've got to update your, I think it's the 19B4 form.
4B or B4,
yeah,
exactly.
one of those.
Yeah.
Like we were less than a week away from the approvals. It's hard to say if it's going to go quite that way this time because, as you were pointing out, there's so many things
asking the
in the area.
to approve, 2-3 days beforehand is that doesn't seem like they were on top of this issue.
No,
this might be an emergency.
Yeah. All right. I want to check again to see if there are any questions. I do see a hand this time. Okay. We've got a question right here. Yeah.
You can yell it out, too.
Oh, here comes a mic, I see.
We can repeat it.
Or you can yell.
Or you can use a microphone.
You hear me?
Yes.
Yeah, so thanks a lot for being bullish on Ethereum.
So hard for me.
So my question is related to the thing that you said, that crypto Twitter kind of stays vigilant and checks whether we achieve decentralization. And lately there was this conversation about EF employees, getting some stake in Eigenlayer and so on.
Yeah, Justin Drake.
Yeah.
He had a great disclosure, though.
Yeah, and you are literally co-founder of Ethereum that started his own company that was very valuable for the community. And I'm wondering what's your perspective on this conflict of interest, how to manage that, and how to think about it in the first place.
Yeah, so I don't know if it was Justin or a commenter that said the people at the Ethereum Foundation are enormously talented, brilliant people, but also people of immense integrity. So I don't worry about that at all. Vitalik is an individual with more integrity in his little finger than virtually everybody else I've met, not to mention his brilliance. And so we're still in the early days of a paradigm shift. The paradigm shift is based on technology. It's based on this new invention of decentralized trust. Decentralized trust as a foundation is great. We need to build decentralized finance, and there will be so many opportunities for building good and great things or for corrupting things. And so we need to be vigilant. From the perspective of consensus, we've had a lot of great people move through the company, leave the company, start up projects. We are almost always delighted when that happens, and we almost always invest in those projects because we just want to seed the ecosystem with great and talented people, and there's so much to build. And so I wouldn't restrict anybody in the Ethereum Foundation or anybody in any company in the Ethereum ecosystem from supporting more projects. even if they're financially incentivized to do so. At Consensus, we just say, you can be an advisor, you can take some sort of compensation, just disclose it, and make sure that there is no conflict of interest in any sort of decision that you're making for the company. And I'm sure the Ethereum Foundation operates similarly.
Great, and we have time for one more question.
Yeah, I think we've got one right here.
Great conversation. I'm curious maybe on your kind of like long-term bull case for Ethereum, like more as like this original thesis of the global settlement layer, tokenizing everything. Like, what do you think is the key things that stand in the way of like having the whole world like settle on Ethereum, like every aspect?
Yeah. So the only thing that stands in the way is the friction inherent in transforming a paradigm, top-down command and control, centralized trust, to this new decentralized bottom-up trust paradigm. So humans have lived organisms have lived on this planet in contexts of violence and abuse and scarcity. Scarcity mindset, or scarcity leads to a fear mindset. We're in this inflection point moment where we built the technology to get away from top-down command and control, force, etc. And we do great things when we can bring collectives together, and we need trust for that. And we now have this technology that can enable us to bring a large amount of people in some contexts, or a smaller amount of people in other contexts, into a context in which we can reliably trust each other, either via automated trust or social trust mechanisms that are mediated by software. And so I don't know how long it takes to heal the generations of damage that we've been living under, but we have the technology now. That's the issue. It's social. Technological scalability, et cetera, is proceeding really well. It will proceed probably as fast as it needs to, because it's the social, political elements that are going to be the frictions. And so it's a pretty exciting time to be alive. It's probably the biggest paradigm shift in human history, the trust paradigm shift.
Great. Thank you for the candid conversation today. I guess we should wrap that up now. But yeah, Stacy, Joe, thank you.
Thank you so much.
Okay, and yeah, moving us right along. Up next, we have Philip Schommers of Gnosis presenting on Gnosis chain from Dencun to Pectra via Shutter.
Hey, hey. All right. Well, that doesn't work. So I'm going to be talking about Gnosis chain specifically, but also a bit everything around Ethereum, as we are quite aligned. So we'll start with a small recap of Gnosis chain, go through Dencun, the previous hard fork, Pectra, the next one, and then the shutterized Gnosis beacon chain. So what is Gnosis chain? So a few people still don't know here, sadly, what Gnosis chain is. And basically, it's, well, a blockchain, very much like Ethereum, very similar to it. We also have a beacon chain. We go through the same hard forks. We have the same clients. So we have Netherminds, Aragon, Geth on the execution layer, Lighthouse, Teku, Lodestar, and Nimbus on the CL. And of course, we also focus on decentralization. A few differences are that we were a proof of authority network, so we went through the merge and removed all of that to kind of get to the same stack as Ethereum. So now we are pretty much aligned. Our staking token is GNO, which is an ERC20 token, so it's not the native token as for Ethereum, which in our case is XDAI. We have 5-second block times, which is quite a bit faster than Ethereum, and 16 slots per epoch, which is also half of Ethereum. So we have 2.4 times faster block times and 4.8 times faster finality. And for blobs, we have a bit less, but with block times, it basically, well, evens out with Ethereum. So for clients, I want to give a short update because a lot of them had good updates in the past months or so. So for example, Nethermind just released a whole new storage layout, which is much more efficient, and also enables SnapSync server, which is an awesome tech we didn't have on Gnosis chain before and allows well, nodes to be synced way, way faster. So we're talking less than an hour when previously it took around maybe a few days, depending if it's Nethermind or Aragon. Aragon also just released its final version 2 release or version, and is now fully focused on version 3, which will also come with state sync. So until now, Aragon was forced to download all blocks and headers and then sync from scratch, which of course took a long time. And with the new version, one of the objectives is to be able to just sync the states, very much like Geth and Nethermind. And then, maybe for the most astute of you, I talked about Geth in the previous slide, which was until now not available for Gnosis chain. But today, I can probably say that it does actually work, thanks to Guillaume, who is sitting right here. Geth can sync from Genesis to tip. It's actually already running on validators on Gnosis chain, on a few hundreds. It also comes with SnapSync server, so it will make the whole network faster once enough people adopt it. It's not quite ready yet, so there's a few things we are still working on internally. Of course, you could still already try it, but the public release will be available by end of summer. All right, Gnosis chain, of course, went through a few hard forks like Ethereum. So as you can see, since the Beacon chain initially started, we did all the same hard forks as Ethereum. And for each hard fork, we got kind of quicker at it. And until DappCon, we were always a few months behind. But for DappCon, we actually hard forked 2 days prior to Ethereum. So we were technically the first mainnet blockchain with DappCon, which is awesome and a huge testament to our team and our ability to, well, stay in sync. So I want to thank Aragon and Nethermind, who did a fantastic job on this. But of course, none of this would have been possible without the EF, so big thanks to them as well. So the next steps are the Shudder Beacon chain, Shudderized Beacon chain, which is a Gnosis-specific platform. I think Martin talked about this a bit earlier today. And Spectra, which is the upcoming hard fork for Ethereum, but also Gnosis chain. So I just want to go quickly through DappCon again, which is obviously the last hard fork. And the main feature was blobs, or war blobs. So as a quick reminder, they are ephemeral data that is deleted after around 18 days. That is not accessible by the EVM, so contracts cannot interact with the data. But for those caveats, you get much, much, much cheaper data. And interestingly enough, blobs have a separate fee market than transactions. So even if transactions get more expensive, assuming blobs are not well used enough, the price will actually stay quite low. And right now, they are still basically free on Ethereum, even mainnet. So it basically doesn't cost anything. So I want to encourage you to kind of play with blobs. And to that regard, we launched a website that is blob.fm, which is basically just a demo of what one can do with blobs. So they are just arbitrary data. So we kind of put radio on chain. They are 125 kilobytes of space. On Ethereum, you have 3 per block. On Gnosis chain, you have 1, but faster block. So basically, you can stream live audio on blobs, which is quite interesting. So on Blob.fm, you can listen to podcasts that are directly on chain, basically, in blobs. You can upload memes, and you can actually even do that straight from your browser. So yeah, I just want to encourage everyone to play with blobs as they are still free, even on mainnet. Of course, the main use case for them are layer 2 chains, but why not play with them a bit and have some fun? All right, so the next hard fork is Spectra. So this is the list of EIPs for now. Well, not even really, because last week, basically, they had the interop, the EF, so they changed everything. So this might not be entirely accurate. But anyways, I'm not going to go through most of them because they are, I mean, a lot of them are kind of optimizations and things that are not really very important for the end user. But I'm still going to go through or quickly talk about account abstraction and EIPs or updates that are good for validators. So, well, actually, I'm going to kind of skip this one because, again, that's one of the ones that might change. But basically, there is this idea of giving more features to EOAs. And so this was one of the proposals, but it might be replaced by EIP 7702. So I don't really know. It's going to turn out, I mean, to be talked about maybe next Thursday on the All Core Devs. But if you want to learn more, I'm sure the Safe guys have more interesting things to say. So feel free to go to SafeCon sorry, in 2 days. All right, so going through the validator-specific EIPs. So EIP 7002, which is execution layer, triggable exits, whatever. Basically, currently, we have 2 different keys for validators. So the withdrawal credentials, which are technically the owner of the account. It can be a smart contract, in which case the smart contract defines who's the owner. But yeah, so it's basically the owner of the funds. And then the active key, which is used by validators to sign attestations and blocks and all of that. So currently, only the active key can trigger exits, meaning that if you have 2 different entities for the owner and the node runner, so imagine you have some ETH or GNO, and you give that to a staking provider, then the staking provider is the only one who can actually exit your GNO and make it so you get, or GNO or ETH in this case, and so you can get your stake back. This is kind of problematic. Of course, you already have to trust them quite a bit, but giving the owner the opportunity to exit by themselves makes it a bit more practical, basically. So this EIP gives this opportunity. So basically, it's good if you have staking providers. The next one, I think, is much more interesting, even than that. So it's EIP 7251, which aims to increase the max effective balance. So currently, if you want to validate on Ethereum or Gnosis chain, again, it's pretty much the same thing. You need 32 ETH. If you have a multiple of that, so let's say 3200 ETH, then you need to run 100 separate keys and validators. Of course, you can run these on the same client, but still they all have to sign attestations, sign blocks, transfer data on the P2P layer on networking, so it's quite inefficient and there's a lot of overhead. And the second issue is that you need a multiple of this. So imagine you have 63 ETH, well, you can only run 1 single validator. So in total, you only earn yield on maybe a bit more than 50% on the total amount of tokens you own. That's quite rigid and inefficient. This EIP actually solves both of these issues, meaning that we will be able to consolidate multiple validators into one, up to 64 validators for 1 single key. So from 32 ETH to 2048 or 1 to 64 GNO. So this will be much more efficient, but also you can stake any amount in between. So if you have 40 ETH, then you can just stake 40 ETH, and you will earn yield on those 40 ETH. So it's much more interesting. And then you can set at which point you actually get partial withdrawals. So imagine you have 40 ETH, but you can say, OK, I want to accumulate up until 50 ETH, so you don't get any payments, dividends kind of on the execution layer, but it accumulates on the consensus layer, and you earn yield on that as well. So it's kind of auto-compounding, which I think is very interesting for solo node operators. So let's move on to the decentralized beacon chain. So as mentioned, it's Gnosis chain specific project, and this guy, so not, well, it's not an Ethereum project, unlike Pectra and Stankun. So the premise is that we need shielded mempool, because we want to prevent MEV, sandwiching, front-running, all of that. We want it to be decentralized. So obviously, we already have solutions for this, like Flashbots or MEV blocker, but they are centralized, so you still give them all your raw transactions, and they can do whatever they want with it. And we want it to be censorship resistant. So why do we want it to be censorship resistant? Well, right now, still, I think 95%, almost 95% of all blocks are built by the 3 biggest builders on Ethereum, which is actually quite a bit worse than last year, because last year it was 90% for 4 builders. And obviously, well, it's much easier to censor 3 builders than the 1 million, or maybe more than 1 million validators that are currently active on Ethereum. Also, like giving all your transactions to centralized services is quite, like, it gives them a huge competitive advantage because they have the transactions, they can still sandwich you, front-run you, whatever. It's just that normal people kind of cannot do it, so that's also not great. And sandwiching and front-running is still an issue for maybe new users who don't know what the slippage is and set data incorrectly, basically. So the general idea of the shardized beacon chain is that we basically want to encrypt transactions, post them to a sequencer contract, and then validators that are sharded-enabled, so it's a specific set of validators that is not, I mean, all validators are not compatible with it by default. They will be able to decrypt those transactions, and then they have to put them at the very beginning of a block and in the right order given by the sequencer contract. So they don't have a choice of front-running or sandwiching. They cannot choose that. They have to follow the spec. And if not, well, then they get slashed or removed from the chain. So for this, we have a decentralized key of, well, a set of keepers, which are, well, they generate keys, basically decryption keys. So you can see on this graph, we have basically 3 entities, so the user who encrypts transactions, the keepers who generate the keys, and the proposer, which is a validator, so a normal Gnosis chain validator, but that is also sharded-enabled. So you have to opt into that. And then while the users encrypt keys received by the, well, they use Ion keys. But basically, I mean, it doesn't really matter. It's a bit too complex to explain right now. But in the end, you have fully encrypted transactions on-chain, and validators have to include them in the right order. So to implement this right now, as I said, it's opt-in. So validators have to register their normal Gnosis chain validator to become sharded-enabled. They might have to add some, so that's not quite defined yet, but additional stake or do restaking for them to be slashable. But yeah, we're building the shardized beacon chain basically in steps. So right now, that's not the case, but it might be the case in the future. So it comes with additional risks. If you don't follow the spec, then you get slashed. So that's why, for now, it's opt-in. And to make it easy, for now, we also developed a proxy RPC server, basically, so you can replace this in your MetaMask, and then that proxy will encrypt all your transactions. Because, of course, I mean, ideally, we want wallets to adopt the technology. It's not going to be the case realistically in the near future. So that's why this proxy exists. We are making one available to everyone today. Of course, if you use it, it's not much better than Flashbots because it's still a centralized service that still has your non-encrypted signed transactions. But in opposite, I mean, contrary to Flashbots, we actually made this software open source. You can run it yourself. So if you operate this node yourself and then replace it in MetaMask, you have end-to-end encrypted transactions that are fully safe. So this is a collaborative effort between Gnosis, Shudder, and Nethermind who's spearheading the reference implementation. All right, so the current state of it is that we have the DKG itself. So that's by Shudder. They actually already use it for a few different products. We have a concrete specification, so that's on the GitHub Gnosis chain specs repo. We have deployed contracts. We have the RPC server, so the encryption server I just talked about, that is also already deployed. We have a working implementation by Nethermind. And we have work in progress on a decentralized application that will make it basically possible to encrypt transactions in your browser directly without having to use an encrypting RPC server or without having dApps natively support this technology. So basically what we have, well, is enough to launch a testnet. So we did, basically, and today you can actually already use the shardized beacon chain on Chiado, which is our testnet. And for more information, well, we have a workshop in 2 days at 2 p.m., I think, in the execution layer room in Studio 2. So there you will learn how to, well, do encrypted transactions, use the RPC solver, maybe even how to spin up validators, although that might take a bit more time that we don't have. So yeah, I guess we will go through that, but it might, yeah, not be fully functional at the end of the workshop. All right, I think that's it for me. Here are a few useful links for Gnosis in general. You can always find us on Telegram, Discord, Twitter, whatever. You can always hit me up also if you have any questions. And that's it for me. Thank you for listening. So yeah, I think we have some time for a few questions, if anyone wants to.
Great. And yeah, we have time, about 5 minutes for questions, if anybody wants to ask them. If not, yeah, here we go.
Quick question. Thanks for the presentation. Very interesting. At launch, will all execution clients support the shutterized beacon chain?
That's an excellent question, and I'm afraid not. So for now, only Nethermind has a reference implementation. One idea, because implementing this in all clients might not be fully realistic, but one idea is to have builders that are specifically Shutter-enabled, so you could point any of your validators to one of those builders. Of course, this would be, again, centralized, but of course, we would also release this, again, open source, so you could run your own builder, which, with your validator, basically, would then run with any clients.
Thanks.
Great, and any other questions? Yeah, up in the front.
Yeah, with Shutter, clearly, like Gnosis is trying to go a bit independent compared to Ethereum, which is a good thing because Ethereum, went through the roll-up-centric roadmap to say let's foster innovation on at the L2 level and kind of ossify the base chain. At least that's the plan, right? First, because the base chain, the L1 at L1 we keep innovating, and second, L2 is having a hard time. Or maybe not a hard time, but is a bit shy about innovating and find itself locked out of the EVM as other L2s would keep compatibility, like 100% compatibility with the base chain. And therefore, yeah, there's a bit of a chance that they would lose market share this way. Is Gnosis interested in trying to keep innovating and maybe break the full compatibility with Ethereum?
That's also an excellent question, thank you. So we definitely want to innovate. This is one of those projects. There is actually another one which DappLion is going to present, I think, in half an hour or an hour, I'm not quite sure, in this room as well. But for Shutter, so we don't really want to break the spec for Ethereum because that would be a ton of work to kind of fork off again. So we had this before with proof of authority, which was a whole different thing. So we really want to standardize basically Gnosis chain to be identical to Ethereum as much as possible. So Shutter we actually built as a kind of plugin architecture because obviously this is on the consensus layer side. That would mean that if we kind of enshrined it in the protocol, we would have to update all the consensus layer clients. We currently support 4 of them. A 5th one should come soon, so that would be like 5 different languages, 5 different teams that implement all of this in those clients. So that would not be very realistic, I would say. So for now, we kind of build this as a plugin architecture without breaking anything, kind of like what EigenLayer is doing, or yeah, this type of project. Yeah, so we don't want to break Ethereum and very much want to stay in line, at least for now, while still innovating as much as we can.
Lovely. OK, and we have time for one final quick question. So up at the front here.
Yeah, fantastic talk. So what's the point of blobs and Gnosis? Because the main, for Ethereum, it's like rollups, but on Gnosis now, I don't see any use cases.
Right. Well, I mean, the objective is the same, right? So, well, blobs are on Ethereum. The objective was to have L2s. But as mentioned with Blob.fm, you can do any other type of things or projects with it. But of course, on Gnosis chain, we will actually also have rollups. Probably a third of Gnosis Pay, which is which will need a lot of transactions per second. So they will launch rollups on Gnosis chain because they are in the Gnosis chain ecosystem. But yeah, in the end, it's basically the same objectives. On Ethereum, you have L2s for Ethereum. On Gnosis chain, we would have L2s for Gnosis chain.
Great. I think we should wrap it there, and we can take a 2-minute break. So yeah, thank you, Philip.
Thank you.
OK, so without further ado, up next is Togrul from Scroll, the path to multi-sigless rollups. So yeah, welcome to the stage.
Oh. 1 minute on stage, I already screwed it up, sorry. How do I go? OK, yeah. Hello, everyone. My name is Togrul. I pretend to do research at Scroll, but I usually just complain about things on Twitter. And today we're going to be talking about how we get to multi-sigless rollups. And I'll explain more about what I mean by it in a bit. So yeah, just remove the multi-sig. That's it. That's the entire solution. Thank you. No, I'm just joking. Let's go back. So let's start with this great screenshot from L2Beat. And it shows a lot of familiar names here: Arbitrum, Optimism, Base. There's Scroll underneath there. And there are a lot of red things, the color red in that pie, and all of those pies over there. So there's this nice scroll down menu there that you can pick. And it shows the stage of that you can pick and filter the protocols by. So let's do that. Let's pick stage 2. And let's see, oh, all of a sudden you only have 2 protocols. One is dgate, which is a ZK rollup that is application specific and is a DEX. And then there's Fuel V1, which is an optimistic rollup that does payment and has what, $953. Oh, it actually went up. It used to be $8. So great. Thanks, Bartek, for your contribution. And as I said, both of those rollups are application specific. So let's go back to the question: why is a multisig necessary? Or let's be more precise here: why is upgradability in general necessary for rollups? I think with app-specific rollups, you can get away to a certain degree without having a multisig. But if you're talking about general-purpose rollups, I think it's not a question, and I'll explain why it is later. So if you're a bit of a conspiracy freak, the answer would be the covert cabal wants to retain full control over the user funds. But I'm not a conspiracy freak, so I'll take off the tinfoil hat, and let's talk about the reasons why you actually need a multisig or upgradability. So one is security. And so great, you build a rollup, it's super good, it's super fast, it's super, the proving is super cheap. But what if there's a bug? Like, you don't want to be on this board, and this is incomplete. Like, a lot of the projects, Wormhole and stuff, are not on here that had hundreds of millions stolen from it. And as we know, smart contracts are complex, and with rollups, they're even more complex because you have the verifier, you have the bridge, you have a lot of different functionality than an average DeFi contract doesn't have. And so it's likely that there are bugs in there, and there are potentially bugs that can lead to catastrophic consequences. So, and to that, you must also add that you have provers. So in case of optimistic rollups, how many people actually understand the game theory behind how fraud proofs work and how they're implemented? Yeah, Bartek. 5? Ah, OK. Bartek says 5, so I trust him on that. And then on the zero knowledge side, how many people can actually audit the circuit? I would also say 5 here as well. So we almost treat both the fraud proofs and the zero knowledge proofs as black boxes and trust a handful of people in the world who can actually look at the code and audit and understand what it's doing, that they're actually paying attention at all time and didn't miss an important bug. And then the second reason why you want to have upgradability is feature expansion. So for example, say you're building an EVM equivalent rollup. It's either an optimistic rollup or a ZK rollup. It doesn't matter in this case. So EVM equivalence requires you to expand the feature set in case EVM specification adds some new feature. Let's say a new cool opcode is introduced, or we get something that improves the fees, so for example, multi-dimensional fees, etc. in your EVM equivalent. So you want to support it. But to support it, you actually need to upgrade the code, on-chain code. So you need a way to upgrade the contracts. And currently, most of the solutions involve some form of multisig. But you might rightfully point out that, oh, yeah, but security councils are a thing. You don't need a multisig. But what is a security council? So like security councils are committees that have ability to initiate fast-track post-rollup contract upgrades. Like it depends on a specific implementation of the security council. And it's usually, it usually consists of external parties. So I think the definition of a security council that LTB and Vitalik propose is that the maximum amount of core team members that can be on the security council is 25% of the entire multisig. And so it is a step in the right direction because it's not fully controlled by the team, but it's still a multisig. And a multisig is a multisig. Like, of course, you can argue that an external team might not be as easy to compromise as like a bunch of team members, but it's still an honest majority assumption. So essentially, you have a rollup that has all the tech underneath that allows it to have a trust minimized bridge that cannot have a trust minimized bridge because you have that multi-sig working underneath. And so I showed the graph before about where we filter out stage 2 rollups. So like, let's examine what a stage 2 rollup actually is. And specifically, we care about upgradability here. There are a lot of different things that require a rollup to comply with in order to be a stage 2. But in this case, a stage 2 rollup should allow users ample time to exit from the rollup in case there's a malicious upgrade. So what that means is, let's say if you introduce an upgrade, there has to be some time to allow those users to exit in case they either disagree with the upgrade for one reason or another, or it's an actual malicious upgrade. So, and typically we define ample time as 28 days. So that means that if you upgrade a bridge to either add a new feature or to fix a bug, which is even more pressing, because like with features you can wait for a bit, but like if you're fixing a bug that is critical and then that can result in funds being drained, this is not really a good option because by the time the upgrade actually is in effect, the funds might be gone. And so I lied a bit in the name because you can still have a multisig that initiates those upgrades, even though I expect the majority of the rollups actually use some form of governance to do that or the Security Council to do that. But it has to be delayed by 28 days, as I said before, at least 28 days. So how can you become a stage 2 rollup without compromising on security or future feature expansions? So there are a couple of steps here. One is multi-provers. So why should we have one prover when we can have multiple provers? And specifically distinct provers, because if you have two provers working with the same implementation and the same ZK system computing proofs, then it doesn't matter. You might as well just have one. So for example, you can combine Halo 2 prover with an SGX prover. So how it will work is basically you have those two provers working in parallel, and they submit the attestations and then also submit the state roots, the output state roots. And so basically, and the bridge compares those output state roots, and if the output state roots don't match, then it just halts and doesn't apply the state transition that corresponds to that state root. And basically what it allows you to do is to protect against correctness bugs in case there's a vulnerability inside one of the proofs. So you can think of it this way. This allows us to downgrade a correctness failure in case of a bug to an availability failure. Of course, if two of the provers have the same bug in them, then this doesn't really protect against that, but it's unlikely that you're going to have the same implementational bug in both of the provers. And basically, in this case, the bridge would halt, and you either let the governance choose what to do next, or have the Security Council pick the correct prover, which is much better than just having the funds stolen. But that's not really enough, because that only solves the problem with provers, but we still have the problems with smart contracts, the same problem actually. What if there's an implementational bug? And that's where multi-verifiers come in. So with as with multi-provers, it's the same problem here. Why not have two distinct contract implementations? You can have more, but like, let's keep it simple for now and say two. So, and we also remember that aside from implementational bugs on the smart contract side, you can have contracts or the bytecode that results from a contract code suffer from a compiler bug. It happened recently with Viper and Curve, when certain curve pools were exploited because of a compiler bug. And so how would that work? How do you do that on the verifier side? So you combine two implementations. Say one is in Solidity and another is in Viper, and you have two implementations running in parallel. And the way it works is it basically protects you from both the compiler issues, but also diversifies the implementations, which means that you're not only protected from the bugs that you introduce, but also are protected from the bugs that are introduced on the compiler level. And to make it work, we need a minimal adapter contract that basically handles the checks, whether both of those contracts, say, as I mentioned before, like let's say in Solidity and Viper, are producing the same mutations. So for example, if two of them are trying to ask for a different slot to be changed, or like a different mutation to happen in storage, within the same state transition, then it just rejects and it halts. And the same way it will work with a multi-prover. You convert, you downgrade a potential correctness failure that results in your funds being stolen to an availability failure that, again, can be either resolved through the governance or the Security Council. It's up to you how you sort that out. There are downsides to both of them, and basically the main downside is that both of them increase the cost of settling on Ethereum, which means that, especially right now when the cost is non-negligible as is, introducing additional cost, which will mean that certain users are going to say, like, why would I use you when I can use somebody else? And it's difficult to rationalize with a lot of people about the security features, the security properties that you introduce with that. But hopefully, as time passes, as Ethereum becomes cheaper to settle on, and we come up with better ways to optimize the costs, this becomes more and more viable. And we basically talk about implementational bugs, but that doesn't really touch on the specification side failure. So for example, you have the protocol specification, and it has an invalid statement in it that might result in funds being stolen. This doesn't protect against that. So what do we do there? So as I said, like, even if your implementation is completely bug-free, the specification can have some faulty statement in it. And that's where formal verification comes in. So if you combine the multi-prover, the multi-verifier, and formal verification, you get a system that is sufficiently secure where the probability of a safety failure is decreased to a point where the risk of having delayed upgradability is acceptable. Thank you, and feel free to ask questions.
Great, and thank you very much. So we have about 5 minutes to 10 minutes for some questions. So over here on the left.
Okay, so I have a question. Do you think that we could combine the fault proofs or fraud proofs with this system to reduce cost, meaning that you always go through one implementation and one prover? Maybe not the prover, but the implementation, right? And then you give some time window. It doesn't necessarily have to be 7 days because there is no challenge game, right? Can we do that? Can we reduce cost in this way?
Yeah, I think that's definitely possible to build a more optimistic system. But the downside here is you're introducing game theory again, because there are certain things that you need to take into account. And also, you're delaying finality, which I think is fine for now. But the more we go further and the more we actually get to the point where we can produce real-time proofs and have near synchronous composability between different L2s, that becomes a real downside. And I don't think you can shorten it to a point where the time difference is negligible. You still have to allow for like at least an hour or a few hours for this to work.
Great. Next question. Yeah, over here on the left.
Hi, thank you for the talk over here. Like fundamentally, it looks to me from what you describe is that we don't actually get rid of the multi-sig, so we kind of still have some kind of a committee or some kind of governance that is fundamentally the multi-sig. So am I correct that basically we just decrease the share of edge cases where this multi-sig will be applied? Or like what's the fundamental difference to what we have now?
So let's say we refer to governance as multi-sig in this case. The multi-sig would only act in two different ways in this setup. One, in case they want to introduce an upgrade, but this is delayed, so we just need to allow the user sufficient time to exit in case an upgrade actually happens. And the second time when it's actually introduced is to break the deadlock, where let's say you have two implementations and one disagrees with the other. You introduce it to basically solve the availability failure. But what you can do instead of multi-sig there, you can actually have a third implementation working as well. So it acts as a tiebreaker in both. It's just a bit not very viable right now because it'll take a lot of resources. But I can see in the future how you can have two primary implementations working all the time, and then the third implementation acting as a tiebreaker in case one of them fails. So I think I would agree that the title is a bit misleading. You still have multi-sigs, but you don't have them acting in the same capacity that they do now.
Time for maybe 2 more questions. And if not, we can take maybe a 5-minute break, and yeah, see you in a bit.
Thank you.
Thank you. Time for our next presenter. So I welcome to the stage DappLion, who's going to share a talk on Gnosis stable fees with gas futures. So yeah, come on to the stage.
Hello, everyone. Happy to be here. I'm just celebrating the bull market. I hope you are as excited as I am. So thank you for coming. I'm DappLion. I'm the fork coordinator of Gnosis. And today, I'm going to talk about a proposal to bring gas features to Gnosis. So why do we want this? As you know, both Gnosis and Ethereum has the same instant auction mechanism. And that's very spiky. Like, most of the time in Gnosis is a lucky chain that doesn't have very expensive fees, and that's good. It attracts the type of applications that we want, this stable value, more community-driven. But it kind of discourages them at the same time because they rely on this cheap baseline that can disappear anytime that, I don't know, something crazy like this DeFi or NFT crazy thing happens and everything spikes. So this spiking mechanism is OK, but it affects everyone the same way. So let's explore what would happen if we would allocate block space in a different way, since that people perceive these spikes not equally. So our goal for this proposal is we want to expose a way that you can purchase the right into having a price guarantee, and as a derivative, an inclusion guarantee. One gets the other, because eventually everyone will be priced out except of you. So today, Gnosis implements EIP 1559, where it's really a good mechanism to expose a way for users to not have to think too much about price, but this only works in the short term. In the say, minutes to hours, fees can still spike very bad, and this does not satisfy our requirements from before. So the main difference between Ethereum and Gnosis, and the whole thing that allows this proposal, is that in Ethereum we burn, in Gnosis we collect. We collect into this collector vault, governance by the DAO. I think today we're not doing anything for it. One of the potential applications is to buy back GNO, so it's kind of an indirect burn, but it can be used for this purpose. So let me first give a shout out to Martin. This is his idea, block rent. I'm just extending it, and definitely gas token was great inspiration. These guys allow the chain to store gas in a way that's perpetual and allows some really interesting market dynamics, but in a way it's not optimal to what we want to do, because this token is permanent. So you have infinite competition for the same block space. You are just moving the current spiky market to another dimension of these token holders. Not ideal. And Polkadot is doing this thing called bulk core time, which inherits a lot of these ideas that I'm going to talk today, where you can give a specific entity, person, holder of some rights the option to have access to some sort of block space in a regular way. So let's look how it's going to work. So we could build this gas option without changing the protocol at all, just with some trusted intermediary or clear house. So this is how it would work in the real world. We could build this today just on top of the current infrastructure, but we will need someone. So let's work through the thing. So you have the speculator that buys a contract with the app. The app promises to buy gas at the spot price, and then these two guys have to figure it out to settle the price difference. So this last step is what requires trust, collateral, or something to make sure that this transaction happens and they don't bail on each other. But we can do better. If we change the protocol, we can have a trustless solution because the chain is aware that this option exists. So what we want is you buy the option to write, the right to purchase Ngas at some strike price during some window for a duration of time. How it's going to work? You go to this system contract, let's call it the collector contract, and you buy this NFT that gives you rights to this future contract. Every window, you can send a payload to this contract, and this contract will forward this payload to whoever you ask it, meter, and then refund you the base fee. So effectively, from your point of view, you have a base fee exemption. You only have to pay for the priority fee. So this is cool, this works, but this kind of defeats EIP 1599 in a way. The key thing you have to understand about 159 is it's more of like psychology to the users. They have to trust that this mechanism works and that no one is gaming, miners are not gaming, and definitely there is no like collusion between miners and users to defeat this mechanism. So to prevent that, we're going to limit how much of the total block space is redeemable. To here, I'm picking 40%, but I really want to run some simulations and definitely study this problem to make sure that we are not unsafe. I mean, otherwise, it's not not good. We can break this invariant. So first version, B0 rollout. We'll start with commit reveal auction. This is a classic mechanism. It's very well understood. It's used in ENS and a bunch of other places. Like just to recap, the primary cell of these sorts of mechanisms is what makes them really annoying. If you have heard about execution tickets, it kind of implements something like this, but how to you design as like a stable and solid primary auction is really, really challenging. So something simple like commit reveal auction should be fine. We can explore a Dutch auction, but it's very immutable, and I think it can get really spicy if you have like the mechanism that allocates who has rights to exempt the base fee on a mechanism that can be gamed by the same people that get these like features. So let's just not do that for now. We can start with some conservative parameters, so just allocate 1% of block space per feature and maybe 10, so 10% of total block space can be competing for these sections. Strike price 0, so we don't have to figure that out. But I think easily we could turn these smart contracts or make the chain aware of historical base fee prices so that the strike price is the historical base fee. It's a somewhat decent-ish approximation of the strike price and will make the system much, much more economically efficient. Because otherwise, when the app buys this future gas contract, it has to front-run all the capital of the gas that will have to spend through the duration of the contract, which can be a non-negligible amount. And then some rolling window. Here, the parameters of window and duration depends on how much total gas is competing for this. Just so you have an intuition, in the case of gas token, this rolling window is infinity, and duration is also infinity. So everyone that holds the token is competing for the same block space, and that can lead to this unwanted congestion. So again, we want to do more research on these parameters, but this is like a good first values that we can deploy for V0. So just to put a diagram, see how this is going to work. So you are the app. There is this running monthly auction for these NFTs. You hopefully win it. Then you get this mint NFT, which because it's an NFT, you can have like this secondary order market. So the app may not be the primary purchaser. It could be some speculator, someone that understands how demand would evolve in the chain in the future and acquire this NFT. And then you as an app that come like later after this primary sale, you can acquire these NFTs. Maybe not only for like month 0, but you can get like one for month 0, month 1, month 2, month 3, and you have basically like a guarantee of a year worth of gas in a predictable price. Then in every window, you send this transaction to this contract that will meter how much gas you spend and then refund you the base fee. I want to note that we try to use the ERC 4337 standard for this, but unfortunately, it doesn't work. The current entry point contract meters gas properly, so that would be fine, but it refunds both the base fee and the priority fee, and that would break the whole architecture. But we'll figure it out. We'll do something in the future. We'll see on the roadmap. So this version with this simple-ish contract, it's good for all these use cases. Basically, anything that does not depend on a message.sender could be used. So say, a safe that's ready to be executed could use this, like the safe team could purchase these gas features and have some assurances that they will just not bankrupt themselves if the chain goes crazy. Cause-up executions, Gelato network, any relay network would really benefit from this or could use it. And also like POAP minting, like it's the prime example. They have this constant load through all the conferences to mint these NFTs. So that's B1, B0. What we want to look next, we can definitely change the block production strategy and the tester strategy such that we guarantee inclusion at the consensus level. So owning this NFT would not only give you this like price discount, but it will also guarantee that your transactions are included through some window or within some conditions, which is not the case now. Second point, I think we can do this on B0, is having a higher strike price so that the system is like as economic efficient as possible, not asking apps to front run as that much capital. Another feature that we inherited this from the Polkadot Bull core time. If these NFTs are splittable, that's super interesting because you can have a much, much more rich secondary market where you can just buy this 1% and then split it in whatever fraction you want and then resell. It will allow much more expressivity of what the market wants, how much block space, at what price, and at what range. It will be like really interesting. I think what will be really exciting about this would become a prediction market for how speculators see and value what's going to be the usage of Gnosis chain 1 month, 2 months, 3 months, 4 months into the future. And last point, as I said, the current version is not compatible with ETH 437 entry point contract, but it will be possible to have a slightly modified version, also audited with a different address that people trust, but we can use the same user operation standards to package these refundable transactions. And I want to point out, I think this is a really, really interesting opportunity for Gnosis chain because no other chain has this property of EIP 1559 collection in a way that's credible and trustless. And this will allow Gnosis chain to have an edge for these type of users or applications that wish to have some pricing stability looking into the future. Thank you so much. I'm going to take this off because it's really hot.
Great, and yeah, thank you very much. So we have about 10 minutes for questions now. Anyone would like to start us off? Yeah, over there. Oh, no. OK. If not, I guess we could take a 10-minute break, and following up, we'll have Jordi from Polygon. So thank you.
Thank you so much.
Hello, everyone. OK, so next up is our final talk of this block. Join me in welcoming Jordi Bailina from Polygon to the stage, who will share a nice talk on the Polygon aggregation layer. So thank you.
Well, thank you. I'm Jordi Bailina. I'm the technical lead at the Polygon CKVM and doing many other things in Polygon. And today I'm going to explain a little bit the work that we are doing for building the aggregation layer. As many of you know, Polygon 2.0 is a kind of a constellation where it's not only the ZKVM, it can be many rollups, many layer 2s that can be somehow connected one each other. The idea is that they share the same liquidity, and that this idea of composability between chains. That the idea is that you can transfer value from one chain to the other, and then going back, maybe in the same call with the synchronous calls. So that the idea is that all the chains become very much like a single chain, but by keeping the autonomy of each individual chain. And for that, we need to build this system for connecting, for transferring value, for extending this bridge between these chains. So, benefits for that cannot explain, but you can, I don't know, but you can, as an example, you can have maybe one chain that's selling hotels, another that's selling plane tickets, and maybe another that are doing insurance, and you want to do a transaction that do the same things in a kind of monolithic things. These things are things that should be able to happen inside this chain. Okay? So currently, all this is based in what we call the XLY bridge. Okay? So let me explain a little bit of details how this bridge works. Okay? So here the idea is that all the chains, they have what we call it a local exit route. This local exit route is an append-only tree that every time that some funds exit from one chain, they are just added to this tree. This tree is an append-only. You cannot remove things off the tree. You are just adding things to the tree. And all the rollups, they have their own exit tree. Let me just see if the pointer works. Okay? But the L1 is like another rollup. It's like another chain that also have their own exit tree. And the idea is that, of course, when you deposit to that you are sending, you are exiting, so you are adding something to the local exit tree of the chain of the L1, because somehow you are exiting L1 to go to an L2, and then you recover in some of L2s, but when this chain wants to send something to another L2, they are just writing this exit tree here. Okay? So you transfer to one to the other. So the full idea of the rollups is that you just need to synchronize the routes. So here you have the global exit route, which mainly is a tree that contains all the exit trees of all the chains. And the idea is that you broadcast this global exit route to all the chains. And then once you have this, each chain can somehow use this part of the exit tree. They mark it as use so that they cannot withdraw twice. And yeah, that's very much how this bridge works. Okay? The leaves of this exit tree, of course, can be NFTs, but can be RC20s. Can be any sort of value, or even some messages you can pass between the trees. Okay? So, well, this is how it actually works. So, of course, when this is a normal thing of a rollup, when a rollup sends funds from A to B, in general, they are going to do it in the trusted state. So sending the trees is just executing normal transaction. In rollups, these transactions used to be very few, even some can be about a second, 2 seconds, half a second, depending on the rollup. This, of course, is a trusted state. This is very much what the decentralized sequencer does. The exiting is very easy. But when can you use it in the other chain? If you are sending funds from chain A to chain B, when the other chain is safe to start using, to withdraw these funds and using well, this chain needs to generate a proof. This proof goes to L1, this proof is included in the global XC tree, and once this global XC tree is broadcast to the other chains, then the other chain can use it. Okay? So you need, for each chain, you need to generate this proof and send it to L1. This is in the case of the ZK rollups. This proof time can be, well, generating the proof currently is about 2 minutes. Well, actually, with the last implementation, it's about 1 minute. With the last generation of servers, is less than 1 minute. But it's still 1 minute, and the idea is that the chains, they don't publish. So each chain, they don't publish this proof every minute, because it would be too expensive for this chain. Currently, the ZKVM is, I think, it's about half an hour. Okay? So one obvious solution to that, and that's something that's, well, we are going to start very soon, is instead of each chain having to publish its own proof on chain, the idea is that we can take all the proofs, aggregate them together, so generate a proof that proves all of them, and then publish just one single proof on chain. This, of course, it saves a lot of cost from each chain, because I mean this cost is aggregated. The fees on L1 is just proving a single proof. Okay, so, and this is aggregated, and this is much cheaper. But the interesting thing is, because we are aggregating many proof of many chains, that means that we can generate this proof much often. So maybe we can generate a proof every 5 minutes, 2 minutes. So, and this will accelerate a lot this timing between one chain and the other. Okay, and this is version 1, version 2. This is very much what we have right now on the Polygon network. But can we do it better? I mean, the idea is, okay, 2 minutes is probably too much if you want this to look as a single chain. I mean, the idea is, okay, we are many chains, but users should see it like a single chain. Okay, so, well, the first thing that we did in order to improve that, but this is a little bit like a previous work, and this is something that's really important in the Polygon ecosystem. At some point when we started the Polygon ecosystem, we had like kind of a single proof that rules it all. I mean, and the proof very much is a transition state. So if you have a ZKVM, well, you have very specific rules that are the ZKVM, okay? And then this is the specific state. And if all the chains, they are following these rules, then the system is safe, because, I mean, you cannot spend the funds of the other chain, okay? But here we are seeing, and this is one modification that we did time ago, and that we are working really hard on that, is that, okay, instead of having one set of rules, we divide these rules like in 2 rules, which are actually 2 proofs. One is the rules that somehow specify how the state transition function changes inside your chain. Okay, this would be the state transition function. But then we have another set of rules is, what are the rules that you need to follow in order to not affect, so whatever you do in your chain does not affect to the other chains. Maybe you are screwed in your chain, but what cannot be possible is that you can, in your chain, you can withdraw the funds, that are maybe stored in another chain. This is something that this cannot happen. And if you, for example, you have like different state transition functions, imagine you have a ZKVM, but you can have maybe a ZKWASM, or you can have a Maiden, or maybe an application chain, which is a very specific state transition function defined than that. And what happens if there is wrong? I mean, this can affect the full ecosystem. So with this, we separate this in these 2 proofs. So one proof is, we call it the invariant proof, or if you want the cross-chain accounting proof, that actually guarantees that whatever you do in your chain will not affect the other chains. And the other is the proof of the chain. I mean, the proof that guarantees that your chain is safe. Okay? Actually, it could exist perfectly in the system. It could exist some chains that they don't even have a proof. I mean, they are unsafe in itself. I mean, I have a chain that's centralized, that I'm deciding where the funds go. Well, I could have that, but this should not affect the other chains. Of course, the people that want to use your chain, it's your problem, you're autonomous, you do whatever you want in your chain, but because you are in a community, you are in another chains, these are what you guarantee. Okay? So this is an important concept that, each chain needs to submit this kind of two proofs. Okay? So if we see the invariant proof, mainly what does the invariant proof? Well, the invariant proof, mainly what it does is it keeps a kind of an accounting of the full system. An accounting, I mean, here we have different chains, we have different assets, and mainly what it says is, okay, in chain, this is the current state. I mean, in the chain A, there is that many assets of this kind. For the people that's thinking about NFT, you can think an NFT like a normal token with a total supply of just one. Okay, but here is you need to keep a kind of an accountability where the assets are. And, here there is some very light colors that are difficult to see. Okay, so let me just go to the next one. So this invariant proof. So when a chain submits a proof, well, here very much what you say is, okay, according to this global accountability. So all these so this is state transition function, and this is very much this local exit route. I mean, how many exits? This differential exits. This is what we call it exit route. I mean, this tree of exits. So how many if you take all these exits, all the funds that are quitting this chain, do I have enough balance in this global accounting in order to send that? If that's correct, then if you don't go negative, that means that this chain, so that this state can happen. Okay, let me just go back. Okay, so we have this. Well, you see, this is in the top we have a single chain. This chain is changing. I mean, it's having different local exit routes. I mean, in exit route 1, 2, 3, in each one we are adding more exits, and we have this exit A, which is the differential of each chain. And in the second is we have another chain. Of course, it can be in can have different blocks. So we have this idea of the chains. Okay, and so in order to coordinate here, the full idea of this piece of the aggregation layer, of this version 3 of the aggregation layer, is to have this kind of coordination layer. I mean, would be a consensus layer, should go relatively fast. And here is where all the chains, actually it's not necessarily needs to be a blockchain, but let's assume that's kind of a blockchain. Okay? So the idea is that the different chains, they can submit this new state. Okay? So they submit the state, they submit which chains they are, the state root, the local exit route, which is state root. I mean, from the aggregation layer, it's very much informative. I mean, the important part is the local exit route, because this is very much what I want to guarantee. The state route is very important for each state, for each chain, but not for the full system. Okay, and of course it includes a proof. Okay, a proof of this commitment. Okay, and then here in this chain, the idea is that each chain commits to this network. And when I'm saying this each chain, I mean it can be anybody. Here, of course, there is some incentives that we will talk a little bit later. Okay, but somebody chains and guarantee that this belongs to a chain. So they commit to this new state. It's not on the commit; they prove this new state. Okay, and of course, every time that the chain commits to a new state, this exists history. I mean, all these differentials on this local state, they are somehow stored in a tree that looks like very much like this. I mean, I'm just taking all the, so for every time that there is a commit, I'm just keeping this accountability. And things in chain A, the local exit routes, the state routes, and the exit routes. I mean, this differential part of the local exit route. Okay, so I'm keeping this, and I merkelize and I'm keeping this, the blockchain that's just keeping this track. Okay, so the proof. What needs to do the proof? Well, it's this cross-chain accounting that internally, this is going to be a recursive accounting with this cross-chain accounting also will prove the state transition function. But this, again, this state transition function can be anything, even can be do whatever you want. This is going to be parameterizable for each chain. It's going to be kind of a parameter that chain will be able to control autonomously. Okay? So they are proving that everything this works, and given a global exit route at a given point, all this happen. Of course, this global exit route, this global accounting route, it can be relatively old. So here, I need to also include all this exit history, all these new events that happens there in order to prove, because maybe at that point, I didn't have enough funds to live, so I need to add other differentials in some other states in order to be able to exit. Okay? Okay. This is, the problem here is that the big problem that we have here, I have 3 minutes only. Okay, the problem that we have here is that, maybe this proof becomes a little bit complex, because if the last accounting, if the last snapshot of the global accounting is very old, maybe I need to prove a lot of these exits that are in the future. Okay? So here it can be one way to solve that is by having another proof that we call is a kind of a consolidation proof. That's very much just taking all these exit routes, so all this history, so I have a new snapshot of the history of this route of all the changes that happen, and somehow it updates the global accounting route. This is a proof, okay? And this gives a new snapshot of the global accounting route. This can happen maybe once per day. Okay, so it does not needs to happen in each place. But this very much what it does, it saves the change. It changes the complexity of the proof. They don't need to go very much backwards. Here it's important to say that this model, for example, for big chains that they have a lot of TVL, in general, they can. They will not need. They can use. They don't need to prove because they already have some funds, maybe from other users. So these proofs can be relatively cheap to generate. Okay. Okay. Another important topic, and it's important. This is different, is because in this model, okay, we need to. So in this model, we need to write. So for each chain, so imagine a chain generates a new block, but then the chain needs to generate the proof in order to be committed, and generates a proof for the other chain to happen. Okay, so here we are a little bit in the same paradigm on there. Of course, a different chain, they will not have to pay in L1, the same thing that in L1, but they still have this problem. So in order to solve that, here is we have the option to that the chains so before sending the proof, they commit to the state. And this commitment of the state means that they cannot change this state. Okay? So I can commit to one state, and then another chain would be able to use that chain as far as they are following the other chain. And they need to check. They need to be sure that this state is valid. And this is done because they are running maybe a node from the other chain and checking that this state is valid. Or said in other words, if a chain is able to build a proof for the other chain, then I'm safe to use that state. Because if the other chain doesn't submit the proof, I will submit the proof. Because it's committed, and it's committed here in the chain, and this cannot change. Okay? So this is the idea of the preconfirmations. The problem of this model is that it doesn't scale very well, because if a chain wants to be connected to 1,000 chains, then this chain will have to run 1,000 nodes from the different chains, which doesn't scale very well. And that's why it's so important to have fast proofs. And fighting for, and this is the huge improvements that are happening in the ZK are not for optimizing the cost of the proof, but for optimizing the latency, how long it take the proof. And here is where hardware acceleration will play a huge role in here. And well, this is where the things are going for. Okay. And the last thing that I want to mention is, of course, this is a kind of a side chain, and at some intervals, maybe once per era, in Ethereum, it's going to be a kind of a consolidation with L1. Consolidation of L1 is very much, you can understand this like a normal, like a roll-up with a very specific state transition functions, and this is very much what will be consolidated in L1. Yeah, with this is we can have, I would say, here 15 seconds, but this is probably even pessimistic. But here we can have a fast, with this system we can have really fast transfers of value between chains. This chain also will need to have all this incentivation layer. Here is where the Pol token is very important, because I mean, how you pay the provers and how you synchronize the provers. This also decentralizes the proving system. Okay, so here we have a kind of this coordination layer that helps to do these transfers between one chain and the other. Okay, this is a little bit the roadmap. I mean, we already have the LXRY bridge available. You can already use that. We have this proof aggregation quite ready. I mean, this is a hope that in the next fork we can enable that. And we are working really hard in this ACK layer B3. Let's see if by the end of the year we can have running. I mean, no commitments here, but this is very much what we are working in Polygon. I have only like 20 seconds for a question. But I mean, maybe if it's a fast question, maybe I can take it. But if not, let's keep it here.
Yeah, let's give it up for Jordi. So, we actually have about 4 minutes for questions. And this is the final talk of the section, so maybe we can get 2, possibly 3 if they're quick. So yeah, any questions from the audience? In that case, I think...
Well, I'm going to be here.
Actually, sorry, we've got one over here on the left.
So, yeah, I'm in maybe a little bit more of the details of how proving happens. So imagine I've got chain A and chain B, and we've got the global accounting group for chain A, which tells me all the stuff that chain A has. But now I mint a new token on chain A, and I want to send that over to chain B. How is the proof actually integrating the fact that this token just got created out of nothing on chain A? How is the proof enforcing that? I mean, I understand if
this is very much. This is very much
in advance.
This is very much. This is like in general the tokens are like in layer 1, and in layer 1, I mean, you can create a token in layer 2, okay, but. Layer 2s and layer 1s for the bridge system, there is no difference. You can understand layer 1 like another layer 2. So the idea is that the chain, the owner of the, so the owner of the chain of the owner of the token, they can do whatever they want. They can mine. So there is kind of an exception that the exit tree of the chain that's owning the token, they can do whatever they want. In any case, I mean, if it's an L2 that's generating a token, and of course, if this chain is bad, you are going to be bad anyway. The best example is layer 1. I mean, layer 1, you can mine a token in L1 and you can transfer to other chains. That means that in the local exit route of the layer 1, you can add whatever you want, and the proving, I mean, the proof allows you. So in the, I mean, if we've seen, oh well, it's gone. But if you've seen if you've seen the leaf of the exit tree, there is one of the fields that's the origin of the chain. Okay, and this is and this is important. I mean, this is important, and this is much, and this is included and take it in account in the logic of the prover.
Okay. All right. Thank you very
much. Lovely. Time for one final question. Any other takers? Oh, yeah, up here in the front. That was a hand, yeah? OK, yeah, perfect.
Thank you. Yeah, I'm sorry if the question is redundant with what was said, because unfortunately I missed the beginning of the talk. But for this system to work, does that mean that every client running the chain will have to add another client to run the aggregation chain?
If you don't want to wait for the proof to happen, yes. If you have a proof, then I mean you don't need to run because you already are proved. Here the problem is how long it takes to generate this proof, and here is where it's really important to have proving systems that have very low latency, and this is what we're working on. Right now, a proof in the ZKVM takes 60 seconds in a CPU. We hope that in the upcoming versions, we can be few seconds. And with the introduction of hardware in the ZK, I think here we can go to really fast proving systems. And then we don't need, we are trying to avoid that. I mean, that's the full idea.
Lovely. OK, we do have one final, but maybe you all can take that up after.
I'll give one. That's what I mean.
So let's give everyone else a break. Thank you for all of today's speakers. And see you all back in here in about 25 minutes, OK? So we're going to resume at 4:35.
Everyone, can you hear me? Okay, great. Welcome to the final session of the day. I hope everyone's feeling good. You've had your espresso, maybe some gelato. To kick it off, we have a talk from Adrian Brinker titled Anoma, Ethereum's Intent Machine. Give it up for Adrian.
All right. Let's also put this here. Perfect. All right. This also works. Great. Yes. Thank you very much. Today, I'm going to, very briefly, in the next 20 minutes or so, going to talk about Anoma, Ethereum's intent machine. What intent machines are, how we got to sort of having to think about intent machines, why they're a more useful abstraction than just thinking about transactions. And then I'll also go through a bunch of examples here and sort of some of the affordances that intent machines are going to give us. So let's start with a very basic thing, which is, what is a VM? And really, a VM, it's an instruction set, it has a program counter, has different layers of memory, and fundamentally it runs programs sequentially. Over the years, we've sort of started with the Ethereum virtual machine as the first full-fledged virtual machine, but sort of over the years we started developing, by the way, could I get the timer started? Thank you. Great, thank you. So over the years we developed a bunch of these virtual machines, but fundamentally, they all follow the same logic of being a sequentially that they execute programs sequentially. I mean, some examples here are really like the Solana virtual machine or the Nia virtual machine, but predominantly, I think the virtual machine that's mostly in production is actually the Ethereum virtual machine, not only on Ethereum main chain, but also on most of the rollups, right? But for example, like some of these ZK VMs, not necessarily the ZK EVMs, but the ZK VMs, they're still fundamentally VMs. They're virtual machines that will generally follow this model. And these things are very good at transaction execution, right? Like when you have the fully fledged state transition, VMs are very good at going, OK, I have a fully fledged state transition, and I just want to update the underlying state of the system. Let me run this transaction. Yeah, so as an example here, the Ethereum virtual machine. So to contrast this, what is an intent machine? An intent machine really takes a batch of intents, computes possible valid state transitions, and selects one of them according to some criteria, and only then updates the state of the system. And here, really, the important distinction between a transaction and an intent is that an intent is a partial state transition. It is, I have A for B, but I do not have B for A. Right? Like when I go to a shop and I go, here's some USDC, I'd like some milk, I have a fully fledged state transition. I have a transaction because the other side of the trade is effectively the physical milk. And this is something that, as a result, payments can generally be immediately executed on chain. Intents, on the other hand, are partial state transitions. They are the idea that I have A for B, but I don't yet know who is B for A. This may be one person, maybe 100 people, it may be 15 different hops away. It doesn't matter to me. I just have an intent. It's a partial state transition over which I need to discover with whom to coordinate in order to settle and satisfy this intent. And this is a very fundamentally different abstraction because an intent is not directly executable on a virtual machine, right? Because there's no valid state update afterwards. If I only have A for B, I can't update the global state because it will be imbalanced. Like, I'm spending some money, but I'm getting nothing in exchange. So intent machines don't exist. Specifically, generalized intent machines just yet don't exist. Sort of the first one here is the Anoma resource machine, which, again, it's not a account model, it's not a UTXO model, it's a resource model. It's a model that allows you to very efficiently express partial state transitions so that you can figure out which counterparties to coordinate with. So I would, in the beginning, like to take a minute or so to talk about that Anoma is an interface. It is not an intermediary, and this is very important to understand. And the differences here are really crucial, and I think lots of times at the moment, people confuse intermediaries for interfaces, and I think a lot of intermediaries try to pretend really, really hard that they are interfaces, whereas in reality they're not. So generally speaking, intermediary it's an actor on the network. And oftentimes they're valuable ones, right? Like
but they're fundamentally a party that you interact with. And they have the capability to sort of leverage their privileged position in the ecosystem to almost always introduce extra security assumptions, most of the time be able to extract extra rent, and most importantly, they add actually unnecessary latency and complexity. And this is because you're fundamentally going to a specific counterparty with which you're interacting with. Like, you have to send something, like with intermediary, you have to send something to a specific party. It's not you're just using some code, it's you're interacting with a specifically identifiable counterparty. And sort of when you think about this from a global latency perspective, no matter how fast this intermediary is, even if the intermediary is an actual decentralized blockchain somewhere in the world, I now have to interact with this system, which means in most cases I have to like send my thing to some global consensus instance, to some controller instance that then comes to consensus over this. If we don't, with interfaces, like two of us in this room can decide to directly talk to each other, and we do not have to route via some global instance. Like going via intermediaries is always going to be slower than directly just using interfaces. One really good example here are bridges. In our ecosystem, most of the bridges currently are intermediaries. They are fundamentally new trust assumptions. If the bridge blows up, and I'm not saying that they necessarily blow up, that they will blow up, but if the bridge blows up, you have to consider this as part of your personal security model. This is not you just using a free interface. No, you're trusting a specific identifiable third party, whether this is a single 1/1 multisig or a completely decentralized system. But you're trusting an intermediary here. And here it actually doesn't matter whether it's a multi-sig bridge or actually a chain. In the real world, we have also a great example for this, which is fundamentally banks. And it's in the real world actually kind of really weird that in order to access the sort of global financial settlement layer, you must go via a bank. Like, why is there not the point that I can just directly interact with the settlement layer without having to route via some intermediary that I now have to trust with my money? I mean, there are historic ideas for why this is the case, but sort of like on a technical side, there is no reason why we need to go via these intermediaries. Interfaces, on the other hand, are just protocols, which translates or represents like one semantic, for example, ordering, compute, and storage semantics of an underlying machine. They're simply code. They're freely copied. If two of us in this room agree that we all want to use the same interface, we can. The best example in the world for this, in my opinion, is TCP/IP, because it very much shows the difference. If TCP/IP was an intermediary, we'd all have to talk via a single Oracle server in a basement in Virginia somewhere. But TCP/IP is an interface. It's a permissionless thing, where if two of us in this room agree, we can just have a local device connection over TCP/IP and exchange data this way. And there's no third party we have to interact with. And I want to make this very clear. Like the ANOMA protocol, it's just code. It's freely copied. It's an interface for declarative intents and implements imperative ordering, compute, and storage semantics of an underlying machine. But if two of you in this room want to just agree on how you coordinate over an intent-centric system, you can just use ANOMA. You do not have to go via any central intermediary. You don't have to go via any chain. You can just agree on this as an interface. Actually, in the real world, in the blockchain world, there's also another great example here, which is IBC. IBC, like two people, two chains can just decide to talk to each other. They do not have to route via a central intermediary. So this is very important to me that everyone understands this. There's no ANOMA chain to which you must send intents. You can just use the ANOMA as the protocol, the interface, without going via any specific ANOMA chain. You can use this on whatever settlement system that you care about. Yes, so really, when you use things in this ecosystem, please think whether you're using interface or intermediary, because it fundamentally changes the assumptions and sort of security concerns that you must have. So with this, let's come to ANOMA. ANOMA is a universal intent machine for Ethereum. And actually, yes, one too far now. So it's, I think everyone sort of started speaking about intents lately, and when some people then come up to me and go, well, aren't intents just limit orders? And yes, this is true. All limit orders are intents, but not all intents are limit orders. And really what I'm speaking about here in terms of intents are fully generalized. They are just code and some amount of state. They do not restrict what you can do. They're not just, like an intent in ANOMA does not know what a price point is, what an asset is. It does not know what a specific counterparty is. It just knows I have some state in some Merkle tree somewhere, and I'm willing to exchange or trade it or move it to some other party. To some other, I'd like to update the state. The nice thing is that as a result, intents don't have to always get posted on chain. Intents can be free. Like if 2 of us or 15 of us in this room want to locally do something using intents, we can just update our intents every half a second and just sort of submit this to our local network. And only if we actually find an intersection where like I have A for B, you have B for C, and the third guy has C for A, does this intent actually have to be settled on chain, right? Like we can have these very flexible systems where I can have incredibly quick and low latency updates all the time over whatever intent I care about, and only when there's an actual match does this get settled and executed on chain. Yes, what does this mean for a number of parties here? So this fundamentally means that builders can write dApps in terms of intents instead of transactions or execution traces. And really here the distinction is that transactions are really, they are very imperative in the way they work. It's a transaction just defines some specific execution trace, and then you update this. So you start with a state, and then you say, I'd like to modify the state using this execution trace, and then I'm at some future state afterwards. An intent, on the other hand, is very declarative. An intent just says, I'm currently at state A, and I'd like to be at state B. Anyone that can make this happen can take this and settle this on chain. I do not have to describe the specific compute that needs to happen in order to get me from state A to B. I just describe what are the fundamental state changes. I have a declarative thing that I sign over that I'm currently in this state and I'd like to be in this other state. Can some solver in the network please figure this out how to get me there? And again, here it doesn't matter whether there's one other counterparty or there's 100 other counterparties that have, as long as you have some way where all these intents balance in the end, once combined into a transaction, the system will accept them. And interesting enough, like rollups fundamentally are intent-based systems, intent-centric systems, right? Because when you think of what a rollup does, it has some user has an intent A to B, some other has B to C, the third guy has C to D. What a rollup does, it just collapses the intents, all these partial state transitions, into A to D, or if they actually, and then really the signature over from the rollup provider is sort of to finalize the thing that is C to A, or D to A in this case. So intents are pretty much all around us. We just don't yet have sort of coherent abstractions that try to have a unified approach towards intent-centric systems. Yeah, it's just a universal standard for intents and application formats. It does not constrain what kind of specific intents you can express or build. Again, if you want to represent Gitcoin with this, you can. If you want to make this about trading, you can. I mean, like, order book exchanges are great examples of a specific application using intents. But the system itself is not constrained to just order book exchanges. It's generalized intents. You can, whatever you can express in code, you can express in this intent framework. And maybe this is the most important point, which is intents and dApps written with ANOMA can be ordered and solved and settled on Ethereum. This is, or anywhere else in the ecosystem. I mean, like, to a large extent, an intent-centric design like ANOMA solves the consensus, actually implements shared sequencing. So if you're very much interested in generalized shared sequencing, look into Typhon, the consensus model here. But fundamentally, intents can be ordered, solved, and settled on Ethereum or on one of the other rollups in the ecosystem, right? Like, it can also say, like, my intent is either settleable on Arbitrum, Optimism, or Ethereum main chain, and then users can pick. Or maybe the users actually don't want to pick, and they just care, like, give me the fastest, cheapest thing, and then solvers can pick, well, it's fastest or cheapest to put this onto Optimism right now. But maybe for some things you don't want to do this. For some things you actually may care about the underlying security, where, like, I only want this settled on either Arbitrum or Ethereum main chain, right? And so with intents, users can incredibly flexibly express what kind of specific settlement guarantees or security models they actually care about. Yes. So, yes. ANOMA is a universal intent machine for Ethereum. Intents and dApps written with ANOMA can be ordered, solved, and settled on Ethereum, or anywhere in the ecosystem, right? Like, this could be on an EVM rollup, this could be on an AVS, you name it. This could be on a ZK EVM rollup, on a ZK VM rollup. wherever you can build a protocol adapter or a normal protocol adapter in order to get access to the intent the intent stack, you can use this to settle there. Yes. So why use Anoma to build dApps? What kind of affordances do you actually get here? Well, first you get permissionless infrastructure, and this is not to say that there's just some magic cloud in the sky. It just means that there's no whitelist. Like, you don't have to ask someone specifically to run this code. As long as people in the ecosystem, node operators, for example, Ethereum validators, run this as a sidecar, you get access to intent-based infrastructure. The really cool thing, though, is you get intent level and intent machine level composability. And what does this actually mean? One of the big challenges in a transaction-centric world is that even though users have intents, they can't express this. And as a result, things don't compose really well. Like, I fundamentally have to choose whether I'm interacting with something like CowSwap or something like Uniswap. We're splitting this here. You as a user must choose at the interface level where you go. With intent level composability, you just define that, well, I want to do A for B, and maybe it goes to CowSwap, maybe it goes to Uniswap. As a user, you don't have to care. You get full intent level composability, and this is not just over, for example, like marketplaces, order book exchanges, or generally AMMs. This is across many different things. For example, a user may say, I want to trade A for B because, and another user then wants to go, well, I want to put B into Gitcoin. All of these things start composing with each other at an intent level because, again, they're just state updates. They're just declarative state updates. And rather than every user having to make the top-level choice on, like, I want to go to this specific thing and do that specific compute, I can say, well, I want to get this general state change, and then solvers can figure out what is the most optimal route in order to satisfy all of these things. And you get intent machine composability, which means that you can treat many different networks, many different rollups, for example, as a single intent machine. Even though under the hood, they're composed of many sort of separate intent machines. In the intent itself, you can describe whether you care about security model A or B or C. And really, I think this is going to be a fundamental unlock for the entire ecosystem, that all of a sudden you get this composability not just at the settlement layer, which is what really transactions give you. You get composability at the intent level, like at where you do counterparty discovery, so that users don't have to fundamentally pick which central server they're interacting with. They just pick, I want to get A for B. The rest of the system can figure out how to get me this. You also get information flow control. Information flow control really means currently we have systems that are fundamentally designed around a single large piece of global state in the middle somewhere, right? Like, this is like the global Ethereum state is a single large piece of state that lives in the middle and has to be synced and understood by everyone. Data or state is going to move to edge devices, specifically because nowadays we can have proofs over data on our edge device. So, like in any reasonable system, not only from a scalability perspective, but also from a privacy perspective, you actually want to move more and more data away from the sort of fully public middle, thing in the middle, towards end-user devices. So that my phone here holds my state, and when I interact with the system, I then declare that I am willing to reveal this kind of state, and maybe I publish it fully transparently, or maybe I say, well, I have this state, and I'm willing to author a proof over this state. And this is what information flow control gives you. It makes what users reveal not a choice of a specific application, but rather a property of what the user chooses to do. And sort of like the simplest example here is that maybe you have a case where some people want to trade transparently, and they sort of just attach a plain text signature to their state. So they reveal all the state that they have and who they are via plain text signature. But maybe some other users actually want to trade privately for whatever reason, and instead of attaching a plain text signature, they just attach a ZK proof. Those two things can still be composed into a single transaction, result in a single state update on-chain. So yeah, and regardless actually of the privacy implication with information flow control, it's also from a scalability perspective. Like having this large piece of global state is not super scalable if instead my individual state can live on my phone and everyone else's individual state can live on their phone. And you get heterogeneous trust, which I think really is something that's very underappreciated. But you want to have a model that has heterogeneous trust assumptions. Not everyone and their mother will want the same global security model. Like my parents I don't think I will ever be able to convince them that something is super secure and decentralized. They will always trust their local government more. And this is sort of just a fundamental reality that like different people have different trust assumptions. And to some people, they want to have the most globally decentralized system. But to other people, they actually trust the local 5 friends, and they want to have their financial system, their financial assets secured by their local 5 friends, right? Like, and with Intents, you get this heterogeneous trust model where users can define whether they care about global decentralized decentralization or they care about localized sovereign systems, right? And it just makes this very transparent in the architecture so that we don't have to go like, well, here's an enterprise blockchain that like does the thing for this local city, and here's this global thing, and moving between those 2 systems is very difficult. Rather, we can have one single unified intent architecture that goes, well, as a user at runtime, I pick which specific security model I want to care about right now, and I can always move between them freely, and my application can roam. This is actually the biggest thing, which is applications can roam trust models. Rather than redeploying the same application on every possible settlement layer, you deploy the application sort of at the intent level, and then users decide where this application fundamentally runs. Yes, so some novel ideas for dApps on Ethereum. If you're interested, they fundamentally will need intents. So if you like hacking around with things, take a look. I hope this is some inspiration. Public signal. This is effectively an inverse to Kickstarter. Rather than being a supply-side market where I sort of go, well, I'm willing to supply these kind of services. Do you want to give me money? We can have a demand-side market where many of us may say, well, I would like this kind of service, and only, for example, a simple example is we all want Starbucks coffee, and so if everyone chimes in $5, and if we get enough people together, maybe someone is willing to go, well, I know that this specific cryptographically signed market or demand exists. Let me put it out there. Do I have another 5 minutes, by the way? OK, great. Yes, then I'll quickly run through this. So this kind of marketplace can exist where people where then a supplier can go, well, I know there's demand. Let me satisfy the other side. Something that I deeply care about is sort of around nuclear research. Rather than sort of people building nuclear reactors, we can instead go, and then hoping that someone buys it, we can each go, well, I would like this specific thing. Let me signal this to the market that there's an actual interest here that I have. Scale-free money, actually, I think this is the end game for our entire industry. This is about the capability to say everyone locally issues their own monies. And my monies effectively represent my economic trust graph with my community. But by having this kind of scale-free money system, where I can very transparently exchange my money for someone else's money for someone else's money, we can build a very global financial system that represents local economic realities quite well. Multi-chat, it's effectively a privacy-preserving version of Slack. And a promise graph system, it's how can organizations structure themselves around the actual work not being done rather than a sort of like high-level design for what the organizational structure should look like. Yeah, if you like any of this, please scan the QR code. There's a bunch of ongoing discussions here for what kind of applications are possible in this new architecture. Perfect. And with this, I'll come to the quick TLDR, which is it's VMs and IAMs. It is not against or versus or IAMs. It is fundamentally intent machines are built on top of virtual machines. Intent machines do not replace any existing infrastructure. They are just another higher level of abstraction to make our lives easier while building an ecosystem. They are not, if we do not have virtual machines to actually run the settlement system, IAMs are all very nice thought experiments, but we cannot run them anywhere. Care about interfaces, not intermediaries. Many people will tell you that you should use their thing, and in reality, you should use the intermediary. I mean, if that's your thing, please go ahead, but like everyone should just be aware of are you using an interface or an intermediary. Yeah, what does the universal intent machine mean for Ethereum? Well, we get intent-centric dApps, we get a bunch of standards for intents, and we get the capability to settle everything on Ethereum. I went through the affordances that Normal actually built, from permissionless infrastructure to intent-level composability, a bunch of things around information flow control, as well as heterogeneous trust assumptions. Yeah, and then lately, if you want to chat about more novel ideas of what we can build in this new architecture, find me afterwards. So yeah, what do you think? Please feel free to scan the QR code. Chris, my co-founder, wrote a very long blog post on ETH research, and a very long post on ETH research. Some of you may have read it. If you want to read it, take like 2 hours, probably, maybe more. It's a very good post, though, and it provides a much more comprehensive overview with sort of backlinks to all the underlying research that goes into Typhon, the consensus, the intent machine abstractions, the abnormal resource machine. So yeah, thank you very much.
All right. Please give it up for Adrian Brink. Very nice talk about the beauty and a nice example of the beauty of composability and modularity. Next up, we have a talk by Nick Dodson titled Ethereum Without ZK.
All right. Can you guys hear me? Yeah? All right. So I know, first of all, that a lot of you are probably pretty tired. It's hot, and it's been a really long day. So I'll try to make this as quick, efficient, and hopefully engaging as I possibly can. So yeah, today, and thanks to Gnosis and everyone doing DappCon, I think this is it was a really great event. Cool. So this presentation, I'd like to just go over a concept, something I thought would be a little controversial, which is Ethereum without ZK. So there's always so much discussion around ZK that I'd like to actually try to imagine a world where we just don't use it that much. And I think that this should hopefully describe maybe an alternative position in the community that is something maybe not so considered and something that might help us actually use ZK better or more effectively, in developing all these different technologies that we're doing right now. So the first thing is I do love ZK. I think it's an amazing thing, and even though I put a very controversial title, I do love it. I think it's an amazing primitive, the fact that human beings can produce these kinds of succinct proofs, mathematical proofs, and create this kind of reality that we have with crypto. But there's a few caveats to using it. So the thing is, we love it. It's very, very useful. It's getting better all the time. There's significant improvements all the time. We use it across a ton of architecture. But there's a few things that kind of suck. And I think that the more we're open about it, the better we can apply all of this in reality. So some issues. So basically, and don't mind the very bottom, it's sort of supposed to say hard to beat optimistic soft confirmations. But yeah, so ZK verifying and proving is both too late in the process and also it's really, really expensive. And one thing that maybe we don't consider so much in a global context is just exactly how the internet is wired and why doing things in the way that we're doing them now kind of really sucks. So some things to bring up. Global ping times are not great. It's very hard to basically create a world where we have everything interconnected and it sort of feels real time. We're just not really going to get there, which means that things need to be done ahead of time, which means all kinds of different assumptions that are definitely not ZK assumptions. So global ping times really make using ZK proving kind of difficult. As well, there'll be latency on markets. There'll be contention issues that need to be worked out before you actually do things in proving. As well, even if we have FPGAs and ASICs, which we will have pretty soon, and Justin Drake is like super excited and everyone's so happy, we'll have it, but bare metal racks are not really first-class citizens, at least in the way that the internet's wired, and so there's going to be tons of latency even placing devices like that around computing in general and where it is. As well, we have a hard enough time managing non-ZK nodes. So just literally running blockchain nodes is a giant PITA that is so awful that if you only could speak with DevOps guys, they would tell you wild, wild things. And basically, we're in this sort of weird space too where optimistic soft confirmations, right? Things that we can just kind of do ahead of time because we know things are true because, quite frankly, a lot of the stuff we're doing with blockchain is very, very simple. they're just really, really fast and really, really great for a lot of different reasons. So soft confirmations are like something that's really, really hard to beat, especially with the UX that we're really looking for. So when you're thinking about like a typical sort of pipeline, you have the transaction going to builders, you'll have sequencers, and this is, again, the ideal situation for rollups. So you'll have like a sequencer, hopefully a decentralized one. You'll have rollups, you'll have different kinds of bridges going back to Ethereum, optimistic and ZK. And you can see that it's already quite a pipeline, and there's already going to be quite a bit of latency just within this pipeline alone, and this is a pretty simple one. This isn't even considering multiple different builders or other kinds of things like that. Like it can get very, very complex. And so basically you're going to be fighting, as I was describing before, global ping times, and if you really want to make a global system where you have, you're working out global state contention, then you're going to be dealing with overhead of like at least a few hundred milliseconds if you're actually going around the entire world. And that really sucks. If you want to have this sort of amazing ZK-proved system where everything is kind of interoperating and sending its ZK proofs and verifying them all over the place. So this really just complicates everything, because this is just going to create all kinds of back and forth latency and overhead between each piece. And it's really because you're fighting physics and the speed of light, and you're fighting all kinds of submarine cable issues and all sorts of things. And if you want to make Ethereum really global, and you want to make Ethereum really something that really does run and is protected and being built in all places around the world, then unfortunately you're going to have to cope with latency, and unfortunately that means a lot of interoperation between all these different pieces. So complexity and overhead is basically a huge challenge. Even if we had magical ZK chip in our hand that did everything, it's still an enormous challenge. There's so much that you have to do ahead of time even to get there. And Fuel, even though we're more known for actually doing the first optimistic rollup, and that we focus on optimistic rollups as our technique, we actually use ZK a lot as a product. Like we use SP1, we use RISC0, we use all kinds of different ZK products because we're more agnostic. And I can tell you firsthand that like it's cool, it's really cool, but it's not there yet. It's very difficult to use right now, especially in production. It's getting there, but it's difficult. So there's this overhead issue, there's a complexity issue. Custom chips are really hard to build economically. They're hard to service too. And ZK is very hard to make economical for something that usually gets overlooked, which is very small chains. So, one project, one chain, maybe they have their own user group. They'd like to interoperate with everything, but they don't want to pay an enormous proving bill. It's really, really expensive to run. They have to cut costs everywhere they can, and this is really not worth it for a lot of small projects that have a lot of volume. So, why should they pay this proving cost just to prove to Ethereum that what they're doing is valid? Which, by the way, if you just run a node for a lot less money, you can show that it's just valid. But you just can't really show Ethereum very well that it's valid. So, so what tools do we have outside of ZK? And by the way, this is something relevant to both ZK projects and non-ZK projects, because it's also relevant to what you do ahead of the ZK itself. What assumptions or what things or tools are you using either ahead of ZK proving or without ZK proving at all? So some typical core mechanisms that basically engineers have thought up over time is honest majority assumption gadgets, honest minority assumption gadgets, hardware-based attestations, bonded cryptographic attestations, and social slashing. So not totally in specific order in any way here, but just to say these are some varieties of mechanism that we have to construct things that allow us to work through building these kind of state transition machines. And so, you have the typical like layer 1 designs, you have side chains, you have committees, you have multisigs, and that's in the honest majority category. Then you have a very special odd category, which is the honest minority assumption gadgets. And these ones are really actually, it's a very small group currently. It's just Fuel v1 and maybe one or two other rollups. Bartek's in the room. He'll probably be able to clarify which ones really meet an honest minority assumption. And then as well, there's this gadget I released recently called, I just call it fast finality optimistic rollups. So you can read that on Ethereum research. And that describes a mechanism to build fast finality optimistic rollups such that optimism, arbitrum, everything can basically, if everything works well, can drop their finality window down to 1 Ethereum block or less. So basically alleviating that 7-day window that's very, very annoying while retaining the honest minority assumption. Then you have hardware-based attestations, which kind of got a bad rap over time, but they're actually super important. So like Intel SGX got a very bad rap, a lot of bad things about it. But when you're really thinking about building these really complex provers and complex systems, like at some point you might need to level with yourself and be like, hey, if I had something like SGX that really worked, and that gave me a really good cryptographic attestation from this known hardware device, that's pretty great. It's not ZK, but it's actually very, very good in comparison, especially when you consider all the overhead. Signed bonded light client proofs and other things are really interesting. There's a lot of mechanism design there. And then you have some interesting kind of social slashing and governance mechanisms you can see with things like Eigenlayer and Ethereum in the worst cases where we have just tyranny on Ethereum itself. So these are the mechanisms we actually have, and these mechanisms are actually pretty amazing. They're not going to give you everything. They're not going to give you a single succinct mathematical proof that things are true, but they are going to give you an incredible tool set to build some really, really great things. And if you can actually get things down to an honest minority assumption, that's pretty great for most projects, and it's virtually almost free if you can actually manage it. And the cost is very, very low. So what would Ethereum look like if we just forgot about ZK for a second? We just only had these other mechanisms. So basically, optimistic rollups would become commonplace as the primary rollup format. Cross-chain atomic execution would be done through builder networks and attestations. So builders would be able to basically build on different chains, but they can see the state of it, and they would attest, and then you would basically get some kind of cross-chain atomic processing that would sort of make all the existing optimistic rollups feel like they're kind of one, at least to a user. You would have assumption-based sequencers, so things like Tendermint and other things would be used to help sequence transactions. As well, there's also base sequencing. That's something people are discussing. And then you would be using minority and majority and social slashing assumptions everywhere in terms of the mechanism design. So, and probably with different levels of combination. As well, intents, which Anoma is kind of known as one of the major intent projects. Intents would be used everywhere, basically to create a different kind of user experience that you're not going to get if you're just trying to make transactions all the time. But instead, you're kind of settling what you want outside of some of these chains. Staking and, let's just say restaking, sorry. Staking and restaking can be done on primary operators as well. So when you actually have all of this, one of the biggest benefits of not using ZK is that it creates risk. And unfortunately, for human beings, risk is such an incredible provider of yield. And when you remove all of the fun of the risk, you also remove all of the opportunities for yield. And so a really big one that is sort of not really listed here, but is something that I think is really, really cool, is that when you step away from trying to get absolute truth, you actually step into a different reality where, well, how much are you willing to risk? And with Ethereum, you could put billions of dollars on it. It's got like $90 billion of economic security. That's pretty great. And even if that whole 90 billion was corrupted tomorrow, we would as a community sort of socially fork and probably fix it. So this is a pretty amazing effort in the sense that Ethereum is running on this majority assumption, and we just kind of have this social contract, at least as a community. So basically, what's really wild about thinking about Ethereum without ZK for a second is just that we're getting to a place where, well, it's creating all these kinds of new risk-oriented opportunities that you would remove if everything was just perfectly mathematical. And I think that humans actually prefer this, and the markets probably prefer this, over just making everything risk-free at tremendous cost. And so when you look at the pipeline again, you can see that there's different assumptions that are going to have to underpin different areas of rollups themselves. And this is a very stacked assumption. in general for security. So as opposed to just like a single monolithic chain that has only one assumption that you're really going with, yes, you're sort of stacking them up over time. But at each one of these layers, you're actually creating a tremendous point of value creation that I think is really, really interesting. And remembering that we don't need to rebuild honest majority chains all the time. We have rollups. We have Ethereum to prove things, which means you can have honest minority assumptions, and you can create all these kinds of bonding and staking and slashing criteria with those, but with much better guarantees on security. So it's really actually a very fruitful universe if you look at Ethereum without ZK. And I think that that's sort of a different angle. So again, the benefits with no ZK are that you just don't have this giant overhead that we're always thinking about all the time. And it is getting better every day, but it's still just an enormous overhead. And unfortunately, I'll be the uncomfortable customer in the room being like, I don't like this yet. It's very, very expensive. But it'll progress and get there over time, but maybe this is a little bit of a reality shift for at least Ethereum itself. So again, no proving overhead as well. Cross-chain atomic execution can be done by attestation, or it can be done by even honest minority bridges. As well, there's just way more opportunity for cryptoeconomic risk-taking, which is awesome. And that proving times are no longer an issue, because the second the computer validates it's true, then you're either going to build an attestation out of it, you're going to vote on it, you're going to progress it. And remember that with all the latency that ZK will have, you'll still need to do things ahead of time anyway. So some of these things will still need to be there. And as well, one last thing that we don't really talk about is that there's just no complex overhead on the auditing surface level. So you're really only doing the transactional level, and that's it. So there is some pretty awesome benefits. Some downsides of no ZK are, of course, you've introduced new assumptions and new bonding. You've introduced more bridging and interoperation risk. And as well, there's challenge windows and gadgets that we'll need to overcome. But even with my fast finality gadget that I released as well, and I'll release a part 2 of that gadget, there is ways to actually overcome the reliability of those things, if you know what I'm talking about. And that'll be a very exciting post that I'll do later. So what does this look like in the end? At least for Fuel and what we think of ZK is that we take a position of pragmatism with ZK. So call it ZK pragmatism. So there's certain areas in our build that we really like using ZK, and that it's really, really good at. So compressing data and witness information, fraud-proving enforcement in the pessimistic cases, Verkle trees and state minimization, proving low-throughput rollups is definitely a possibility. Unfortunately for Fuel, which is a high-throughput rollup, it's going to be a long time, I think, until we really see that to be very, very efficient. And then as well, predicates, which are something unique to what Fuel does and what certain ecosystems do, which allow for monotonic processing in sort of a massively parallel way. These are great moments for ZK, and we definitely want to use them for those. What we don't like it for is interoperation between rollups and proving high throughput, low value rollups. These are very tricky in terms of proving itself. So, of course, always open to reevaluate as the angry ZK customer in the room. And FPGAs and ASICs will reevaluate those as they come out, and reevaluate all kinds of ZK in the high throughput setting. But for us, we're definitely more on the pragmatist side when it comes to ZK. We love it. We love all the different ideas that can come from it. And we use it in our designs all the time. But we just don't use it to prove everything because, quite frankly, for most of our users, they just wouldn't want to pay for it. And even if it's for interoperation or security, they still wouldn't want to pay for it. And they wouldn't even want to lose the opportunity to generate all the yield off the risk of producing a new chain anyway. So anyway, a bit of a controversial, odd presentation, but hopefully that was interesting. And yeah, thanks everyone.
Thank you, Nick. Good to hear some real talk about ZK proofs. We have a few minutes for questions for Nick, if there's any in the crowd. Right over here.
Thanks for the presentation. I think I personally share with you most of the comments, just not the conclusion. Okay. So a question for you. Assuming we lived in a world without zero knowledge, okay? Yeah. How would you see challenges working for systems like, EigenLayer or similar, where basically at the end of the day you need a challenge to be able to solve disputes, as with many of the other approaches we are saying? Also, if we decide to exclude SGX and other T-based attestations.
Yeah. So I think that so Ethereum provides us the most incredible platform to witness state transitional machines that we've ever created. So Ethereum is the best platform ever that humans have created to adjudicate something, computational at least. So, so in a sense, Ethereum provides us with an amazing platform to adjudicate. But I think that the best assumptions that every mechanism should work over is probably an honest minority assumption, meaning that any one particular party on planet Earth, if they run the machine, can challenge that there's something invalid. And I think that when you get different designs down to that level, it just becomes such an interesting world, because you could have, like, out of a validator set of like 300 people, you could have one person who's just maniacal who can defend the entire system, even outside of the cryptoeconomic like criteria for like a rational actor. So I think that like the IVG games we have that are between like Bold and what Optimism is doing with Canon, like those mechanisms are fine to adjudicate computation on Ethereum. They're not really great, and quite frankly, we prefer using ZK to do those fraud proofs because it just makes more sense. But I think that the most interesting world that we haven't lived in yet is building everything with honest minority assumptions around Ethereum. And I think that that's actually a very, very crazy world. Like, there's no honest minority bridges, really. There's no challenge-based honest minority gadgets being used all in different kinds of ways. And what I don't like about EigenLayer is it assumes majority assumptions too much. And for me, my favorite designs are to just assume that Ethereum is your only honest majority assumption, and then build off of that with honest minority assumptions. And to me, that garners such a high level of security. Even we've seen the trust in Arbitrum and Optimism to produce these systems and gain the TVL that they have, that I think that for most cases on planet Earth, for most human beings, building your chain with an honest minority assumption is like probably one of the best things you can do. And it's not exciting, it's not sexy like ZK would be if it was all magical ZK, but I think that that narrows down the security profile and the risk profile so low that like it's really worth it if you can do it. So with Fuel and some of the gadgets we'll be producing code for, you'll see that we can actually achieve really great fast finality properties while retaining a minority assumption and a permissionless validator set, and building that off of Ethereum, and showing that it produces really great, as I was mentioning, opportunities for risk, which creates great opportunities for yield. And I think that we shouldn't ever understate that, especially looking at the success of staked ETH and the success of some of these designs that we have in the space. So that would be my preferred world, is that everything's an honest minority assumption, if that makes sense. Except for Ethereum. That needs to be a majority, probably. Yeah.
Other questions for Nick? If not, I think we'll let Nick go. Thank you so much, Nick.
Thanks, everyone.
We'll get started in about 1 minute. All right, for this next talk, I'm going to cheat and use my phone. We have Vijay Krishnavanchi and Andreas Samados with a talk entitled The Missing Infrastructure, Building an On-Chain Knowledge and Collaboration Layer. Give it up.
Hello, everyone. OK, beautiful. How are you? So for those who were here in the morning panel, I assure you this is completely different. We're not talking about AI, a little bit at the end. But I want to mostly introduce a thesis to you, a problem that concerns all of us, and the solution that Vijay and I and our team have been building at Founders. So I want to start very simply and clearly, as much as possible. Internet freedom cannot be guaranteed behind walled gardens. I think this is evident for most of you here. And there is something even worse to say about those walled gardens, which is they limit the type of global coordination and collaboration that we can imagine and let alone realize. And crypto is all about solving global coordination and collaboration problems. Games. Now, the problem speaks for itself. I'll give you some details, but in just 2 minutes of research on Google, you'll realize that your tools, your favorite tools, are leaking data constantly. They're censoring you. Your account is not really your account. It's an entry on somebody else's database. And this leads to a bunch of known problems, like the one that happened yesterday, where a huge company lost all their data that they were storing on Google and the backup data that they paid Google to back up on top of it. So just to give you a bit of an overview of the main issues that come with those centralized collaboration and storage tools that you're using, you're at the mercy of mass surveillance and the behavioral manipulation that comes with it, arbitrary decision from somebody in the company or a disgruntled employee that wants to fuck shit up before they leave. You have insufficient or complete lack of encryption, let alone end-to-end encryption. You have link rot, which is very related, which, fun fact, 38% of all content that you had on the internet in 2013 doesn't exist anymore. So this is a huge problem for academic, journalists, etc. You also have a problem, the possibility of the company going bankrupt, getting bought, leaks, server outages, user lock-ins from the design of those apps, and finally, constrained ownership configurations, meaning I want to share a Google Drive with the people I interact with most on my favorite subreddit. Impossible. But we can do that now with multisigs for bank accounts, for digital bank accounts. So I want to keep those reference points and explain how we're approaching them in order to explore not only a way to solve all those issues, but actually also open up a design space that is completely unique and allows for group collaboration. Now, 3.2 billion people around the world are dependent on 2 companies and a few servers in the US mostly to create, store, and share information. For crypto teams, individuals, communities, it's the same issue. We should know better, but we couldn't do better. At most, what you could do is use a file-sharing peer-to-peer network like BitTorrent, or maybe use a privacy-enhancing centralized collaboration suite. But they were each solving different problems. One is an open peer-to-peer network. The other is centralized technology. It provides privacy, but it has a lot of the issues we just went over. Now, to avoid capture altogether and the abuse that comes with it, we believe that our most essential activities and data should leverage open protocols and networks instead of closed products managed by centralized companies. Thankfully, we're not starting from zero. I think that it's been now 40 years, 45 years, give and take, that the open source community, the cypherpunks, all those people that we admire, we're thankful for everything that they established to create a crypto industry on top of them, have been trying to create the types of tools that I'm describing to you today, or the type of infrastructure that I've been describing so far. But they've been depending mostly on distributed systems, on peer-to-peer networks, some access control management, and inevitably, some centralized servers to do essential tasks or essential permissioning that you could simply not do with the tech that was available until now. And then community computers stepped in. I like to use that term. It's not mine. It's Ethan Buchmann from the Cosmos community that I first saw using. He describes it as personal computers unleashed unimaginable levels of sovereignty and interoperability for people. Think the iPhone. And community computers will do the same for groups. So now we're talking about an architecture that is a bit more developed. There's something missing here. That is a bit more developed than what we've had until now. So it's not just peer-to-peer networks anymore, with, people could have their own public and private key, which is a great addition to peer-to-peer networks if you want to be self-sovereign. But there is a last element that we consider extremely important to create a more universal public good infrastructure for any type of collaboration between people and management of knowledge, and that's public blockchains. So on this slide, there should be a second column where I describe the properties and the advantages of both public blockchains and peer-to-peer networks. I'll just go over quickly why we think that the combination of both basically allows us to create completely new types of applications, unlocks completely new types of interactions between people, and what we like to call self-sovereignty. So public blockchains provide you with global consensus, strict global consensus. It enables objective identity. It's one of the most important properties is the credible neutrality that comes with public blockchains. You have computational and data integrity, and it allows mostly for some type of inter-app composability through smart contracts, for example. OK, we're missing one column. So this is the thesis. I'm going to pass on to Vijay to explain to you the architecture and how we're putting all that together. But I want to leave you with that mental model. We've had peer-to-peer networks since forever, good cryptographic tools as well. They weren't enough for us to simply replace Google Suite, Notion, all those amazing apps we're using all day, but that are basically working against us. And now with public blockchains, we think that by merging the two, we can create a new type of infrastructure that can unlock a bunch of new activities, coordination, etc.
All right. Let's see. Next. Yeah, and thanks, Andres, for doing a perfect job of explaining the vision of Fileverse and what we are trying to do. Now, what I would like to go into is a bit of a detail of what powers that vision, and as in like why we flex our tech in general, and to highlight different components that we have. The one component that we have is the off-chain component, where we mainly rely on peer-to-peer technologies. For example, IPFS nodes, gun nodes, and different peer-to-peer systems that we are using for powering this off-chain infrastructure. And then we have the on-chain component. The on-chain component is the component where we are storing things like, let's say, if you have the pointer to the storage, if you have the registry for identity, and if you have the address of the multisig that you're using to control your fileverse stack in general, and the permission registry in general, that's the on-chain component of fileverse. And then we have the app layer, and this is the most worked upon layer, if you will, from our side. And this is something where we are working on different UXs, where we are working on different patterns that we have developed for allowing users to interact with the above-mentioned on-chain and off-chain stack seamlessly. And yeah, so after working on the previous stack that I was explaining, we came up with different different common primitives that we are using for our own self, meaning while we're building the fileverse infrastructure, we figured out there are few common pieces that can be used by other teams as well. And since they have been developed by us for our own use case, why not make it available to everyone else? And the main work on the fileverse protocol that we are doing, you can categorize it into 3 different layers. The first layer that you have is the identity layer, then you have the storage layer, and then you have the collaboration layer. We'll go into the details of each one and what are the specific primitives that we have developed to power these layers. So first one is the identity layer. In this, we already know about EOAs and multisigs. We're using them to allow you to control your fileverse stack and fileverse smart contracts. This is the new work that we are doing with respect to programmable identity. It's something that's based on Safe's work that they have done for ERC-4337 wallet. But we are combining the cryptographic access using encryption keys and the signing keys with the recovery, multiple recovery strategies that can be automated and are not assuming, let's say, that it's the person that's going to use that, and they can be used within the code without relying on human interaction. Then we have the storage layer, and in the storage layer, there are 2 components, like 2 high-level categories. One is the on-chain storage, and the other is off-chain storage. In the off-chain storage side, what we are doing is we're relying on peer-to-peer systems. And on the on-chain storage side, where we have worked on this collaboration smart contract, which allow for these peer-to-peer systems to agree on a state. And what this offers is it allows you to take your data, move to a different person or different peer or different network altogether without compromising or losing any data in the process. Then we have the collaboration layer. And this is the most interesting one because there is one big piece that we recently figured out with the help of different teams that we are working with. The first one is the collaboration smart contract, which is what I was explaining with respect to storage, permissions, and this is something which is giving us the data neutrality for giving right to exit to the users. Then real-time collaboration, in this we have this piece we have figured out recently, and in this we have peer-to-peer collaboration with end-to-end encryption, and also adding the offline first support with the browser, with the users being able to open that document into the browser as well and continue their work. I'm going to explain these things in the workshop, which we'll have later at the DappCon and one at the SafeCon. Then I'll let the looking from.
Yeah. Yes. So just to summarize, You've heard the thesis, you've heard elements about the architecture. Let me put all that together once again. So today, we're all depending, 3.2 billion people are depending on Google Suite and Microsoft Office for their daily activities, preservation of knowledge, etc. For everyday people, that's fine. There's still a lot of issues that are affecting people seriously. For crypto teams, it's catastrophic. For communities, no need to even talk about it. Those tools are simply not made to serve the needs of a decentralized community or a group that gets together. Maybe some of them are anons. They want to collaborate, but they cannot co-own the storage space, the documents that they share. The combination of peer-to-peer networks and public blockchains allows us basically to serve the needs of all those people, not just crypto teams and communities, but everyone that depends on those tools for their daily activities. It gives them the right to exit. No need to use our app if you don't want to use our app. You can continue using the access permissions that we've perfected for you. You can continue using storage that we've perfected for you. You can continue live collaborating with 10, 100 people on the same document without ever needing to hit one of the Fileverse servers. So really, it's that right to exit and composability that we've finally put together. And there are a lot of really cool use cases that are opening up with those. I won't go over the ones you're familiar with. I'll just cover a few. For example, the Fileverse stack at the moment can be used permissionlessly with Farcaster. Two protocols interacting with each other. You can put all your documents, favorite files, links, etc. on a Fileverse portal, smart contract. And even without using our own app, you can create, for example, a frame that goes through your content that you've stored somewhere directly on Farcaster. It also means that you can plug Fileverse smart contracts in crypto-native social media without ever needing to request permission to anyone. This also means that we've created a new primitive almost on-chain, which we call collaboration smart contracts, but that also act as registries for content hashes that you've stored somewhere off-chain. And this has been quite useful for teams that are experimenting with on-chain AI agents, actually. So I think you're all very much aware that most blocks produced today in public blockchains don't just have financial transactions and interactions occurring, they also have a lot of content hashes and pointers to certain media, to certain types of interactions, etc. So those AI agents can also interact with this type of content, store and give a representation of their activity on-chain, and have access to their own storage space off-chain without ever needing to get a user involved, go through a KYC process, sign up on a centralized app, etc. So just to make it extra clear, I want to give you a quick demo of the first building block we're releasing today. It's a decentralized app. It allows you to do everything you do today with Linktree, but instead of just having links, you have a decentralized web page. You can add your favorite links, documents of yours, files, images, videos, and all that without ever needing a server. And on top of that, you can invite people, give different access permissions to different people, again, without ever requiring to interact with one of our servers or fearing that you might be locked out of your account at some point because of X or Y reason. Just doing a quick sign to the tech team. Is it possible to to get the video going? Hello, is it possible to get the video going? Super. Okay, I hope you enjoyed that. I'm sure some of you recognize the music that was in the background. But this is just a first view of what we're releasing, the first building block that we're releasing. You can scan this QR code if you want to try it out. It will only be open today for a few hours to get an initial wave of first users, get feedback, be able to interact directly with people, and not just onboard everyone in crypto before we are ready to actually make this completely permissionless. Voila, thank you so much.
Thank you, Vijay and Andreas. We have a few minutes for questions. Right here in the middle. Oh, they'll bring you a microphone.
Very cool, thanks for that. I was interested in like the storage you were using. You had IPFS and like Arweave and then et cetera. Is there any option for like local storage? So say if like you and I want to collaborate, but I don't want to put it on a public network, I want to just store it locally, and yeah, how does that work?
Yeah, so.
Yeah.
Yeah, so what we are doing is like the way that we have written the architecture for our storage layer, as you can say, is by writing adapters, and different adapters can store things to different places. One of the adapters is IPFS, other is Arweave. The one adapter that we really like to use is IndexedDB as well, like meaning you could do things on your browser side if you need.
So yes, local storage as well, but we wanted to make sure that we didn't just reproduce types of peer-to-peer apps that you would download a local app, which are great, provide a lot of security, privacy, etc., but that are simply not accessible to most of people around the world. Most people use Google Drive or Google Docs by going directly on their browser, accessing that.
Yeah.
And yeah, that's it.
Other questions for Fileverse team? All right, give it up for the Fileverse team. One of the most important projects on Gnosis Chain. We'll get started in a few minutes with the next talk. Interoperability. Give it up for Hilmar.
Hi everyone, great to be back at DappCon. I think I've been here most years since my first presentation in 2019, so always glad to be back. Audience is growing, I like to see that. Last year in the bear market it was still fewer people. Today I will be talking about Ethereum Layer 2 interoperability, and specifically not just interoperability for the sake of interoperability, but actually we believe it enables a whole new sort of class of smart contracts to be built, which we call infinite, horizontally scalable Web3 applications or smart contracts. And I will be diving into what that means in a moment. And it's actually quite timely. Vitalik, the man himself, tweeted today about Layer 2 interoperability, emphasizing how necessary it is, and sort of also talking and promoting a bit that we need like standardized systems and we shouldn't build too much sort of isolated system in the industry. And so I just want to plug that in because I think it was quite timely. It was like 10 hours ago. And if I want you to get anything out of this talk, then it is sort of this concept, which I would sort of classify as a pretty bold claim about the future of how you build Web3 applications. It might not actually end up like this, but I think there's a strong likelihood that this happens. And the first one is that apps actually won't build on any shared blockchains anymore. And this you might have heard from like the application-specific blockchain hypothesis, right? It's fairly similar, but I want to take it a bit further and actually say applications won't build on a single blockchain. You will have applications that build on multiple horizontally scalable and interoperable virtual machines. And these virtual machines, i.e. these layer 2s, they will scale elastically. So they can be created and they can be destroyed. And with that, you can actually horizontally scale applications to the world like we do in Web 2. And this requires a pretty big shift in how we think about smart contracts and designing them. We need to think of smart contracts as modular systems and not sort of monolithic systems that are based, where the state is based on a single chain. That's me. I'm Hilmar, one of the founders of Gelato. If you don't know what Gelato is, we are building Web3's cloud platform, and we try to enable developers to build verifiable, horizontally scalable blockchains and applications with a bunch of really powerful Web3 services. So at the core, it's a rollup as a service platform where we host layer 2s, all the optimistic rollups, ZK rollups that you know. We try to make them as interoperable as possible for you. You can have multiple layer 2s that you spin up concurrently. We want to provide you with shared sequencing on top of that, so you can have higher guarantees, atomic composability between them. And on top of that, we have a bunch of really valuable Web3 services that enrich these applications with off-chain data, verifiable randomness. You can abstract complexities like gas as well. So we provide you with all of that on a single platform. And we've got a bunch of really awesome chains that are already live with us, from Asta, the first Polygon CDK connect to the Egg layer, to Liz from the OP superchain, to Rhea, the biggest perp application, application-specific perp DEX on L2 that actually trading went live with them today, which is super exciting, and many, many super exciting ones in the pipeline, so stay tuned. But yeah, let's jump right into like the more technical part, which is, this is sort of how the layer 2 landscape looks like today. So you have a bunch of isolated layer 2s, where each layer 2, this is sort of changing slowly now, mostly has their own individual L1 to L2 canonical bridge. This is, of course, not optimal because you might want to aggregate assets into a singular sort of bridge contract, so you don't need to move them on L1 if you need to rebalance, if you want to move assets that are originating from L1 between L2s. Then you have monolithic layer 2s that are not communicating with each other, or they are communicating but with third-party validator cross-chain messaging protocols in a very sort of high latency environment. And then you have sequencers, or you can think of sequencers as block builders, that are building the blocks, so ordering the transactions of each of these L2s in a way which is super isolated, and so one sequencer doesn't know what the other sequencer sees on his chain or another one. So it's very isolated, everything. And if you're building an app, you sort of say, OK, I either want to build my app on L2.1 or on L2.2, or I want to build my app on L2.1 and 2 and 3, but they never communicate to each other, so you just replicate them. So yeah, it all doesn't really make sense that much. And on top of that, these chains are already struggling to scale, right? Chain scale via cheap sort of computation and data availability that they can access. This is already, it has some pretty good progress with like 4844 and Celestia and all the other DA layers coming up. But the execution environment, the VMs are actually getting the bottleneck. You see this with Base really like hitting it off sometime in March, and it spiked tremendously. And so VMs are already becoming the bottleneck for these chains. And if we really want to do mass adopted, if you want to build applications that have millions of users, then our current VMs are just not enough. You can build parallel VMs, but at some point they also sort of end in terms of the performance increase, right? And if you're building on Base, let's say you are just building an application, but suddenly there's this degen NFT that consumes all the gas. Obviously, you're out of luck, and your user experience suffers a lot. And you can't just migrate to another chain, right? You're kind of like stuck. This data is stuck on that chain, and so yeah, you can't really do anything. And so how we can solve this from like a technological point of view, from like architectural point of view, is by having more shared systems between the different L2s and having standardized systems. So firstly, what would be great is having like a shared layer 2 bridge where everyone can deposit their assets into on the L1, and then each L2 can sort of derive what assets it has based on the assets that were locked into the bridge and some sort of pointers that are in there. And the cool thing is if you want to actually move assets from one chain to another, they don't have to be moved on Ethereum by the transfers. They just sort of, you update it with a Merkle root, the different balances. Then we need communication, trustless, Ethereum-grade communication between the L2s via a shared interoperability protocol, which I will sort of discuss in a moment, how this can be designed from like an optimistic rollup point of view. And then shared sequencing, what it enables, if you combine it with interoperability, it brings you atomic composability. So you can say, rather than crafting a block for layer 2 number 1, you can say, I craft a super block for layer 2 number 1 and layer 2 number 2. And the block is only valid if transaction A was included here, then B here, and then C there, and then D here again, right? And so you can sort of atomically execute transactions between them. And the cool thing about this, and this is sort of what I want to bring home at the end of the day, is you can build applications that sort of change state and move from one chain to another and sort of evolve dynamically with new chains being spun up. So I will talk a bit about the optimistic rollup design and how we can achieve it here. A lot of research has been put into this, especially for like the OP Foundation. Arbitrum Orbit is also working on this. Polygon is working a lot on the ZK side, and I know I'm really bullish short term around the optimistic rollup side. Vitalik posted today that hey, in 10 years it doesn't really matter, everything will be ZK, but I think the emphasis here is in 10 years, right? So I think there will still be a pretty sort of long period now where we will first dive into optimistic rollups and everything. And so some definitions first. What do we want to achieve here with this interoperability? We want users to be able to submit transactions on chain A, and we want this sort of information to be transmitted to another chain. So this chain B should be able to read from chain A. There are also other things you can do, like chain A writes to chain B, but this is a bit more complex, out of the scope. And then there's an initiating message on chain A that the user sends, and then there's an executing message on chain B that like the user can send as well, or a relay, or anyone really, a block builder can include it. And then chains can control which other chains they actually will allow to communicate with. So if you're a chain, you can say, hey, I allow chain A, B, C to send executing messages to my chain that I have to verify. And this is sort of like the high-level process of how this works. So what you can do is you can have, let's say you have OP stack rollups, right? And you have, let's say, 5 of them. You will pre-deploy standardized cross-chain messaging smart contracts on all of them. It's very similar to like any cross-chain messaging protocol here. This is a pre-deploy. It doesn't have to be pre-compiled, so you can just like do it on the fly. You don't have to deviate from the standard EVM. And then you as a chain owner, you can say, hey,
maybe these 4 chains that I will whitelist in my dependency set, maybe they're my chains, right? And so I have a pretty high trust in these chains that all the sequence transactions are actually sort of like conform with what I want to achieve. But maybe you also have, maybe you also trust some other chains, right? Maybe Base or OP mainnet, you want to integrate with them, so you whitelist them. And then what happens is that, let's say there's a transaction on a chain, relayers will sort of get paid or incentivized, and relayers could be block builders at some point, to then submit transactions which originate on other chains to the sequencer of, let's say, our chain, our home chain, and they will point them to an identifier that enables the sequencer to say, that enables the sequencer to find that a particular event that was emitted on the foreign chain. And this consists of an event index, chain ID, address. And then the sequencer will be able to validate whether this event was actually happening on the other chain and will include it into his own chain, the executing message. If the event was not emitted on the foreign chain, then he will discard, or she will discard the transaction and reorg out, so it won't be included. And the whole system is actually not secured by some external validator set. It can be fully secured via Ethereum using a multi-chain fault proof. And what it means is that rather than you having to prove that the state rules that you're publishing as a sequencer to the L1 from your own chain are correct, you need to now prove that the state rules published to not only your, but all the other chains with the dependency set, and potentially also the dependency sets of those have been done correctly. So yeah, it becomes much more difficult to actually build these blocks. This is more like a diagram on how this looks like. It starts at 0 here, so user sends a transaction to, let's call it base. Then relayers will listen to this and send an executing message using the data that was emitted here to my chain, right? This is the Hilma chain right here. It listens, it has base as a dependency. What I now need to do as a sequencer is I need to verify whether this was actually emitted here. And if this was emitted here, I will include it in my batch that I post on Ethereum. And then once I post my batch to Ethereum, anyone can go in and actually check whether this event was actually emitted here, and if not, can submit a fraud proof to potentially slash my stake. This, as you can see, makes it much more difficult to become a sequencer, right? Because you now don't need to be only aware of this chain, but also this chain, this chain. So you need to be quite careful which chains you add in your dependency set. And these machines will be beefier. But I will go into some trade-offs in a moment. So the great thing about this design is that there's no force inclusion, meaning you don't have to sync all these chains together. Why? Why does it still work? Because we actually, rather than having like an in-protocol rule that all the transactions that have been emitted need to be executed, we outsource it to the block builders, right? We can say, hey, events can be emitted, but only if someone really incentivizes you to relay that transaction on the destination chain will block builders actually come in and do this. And this is cool because we don't have to, like in Ethereum with withdrawals, we don't have to implement some queue system, and we don't all have to sync all the chains together. We can all have them run asynchronously, independently, and let the block builders really handle the scalability of this. If you combine this with shared sequencing, you can actually get atomic composability if the block builders have sort of monopolistic power over building blocks between one chain and another, and then you can have transaction A that originates here, relay to B, then back to A, then and back to B here, and then you can have some sort of flash loan potentially even. And yeah, this all works with like a multi-chain fraud proof, so there's no additional trust assumptions in the system. Some cons of this, it leads to centralization, so basically Wintermute will build all the blocks, right? But they kind of already do. And it only works for certain optimistic frameworks like the OP stack. It can also work for like the Arbitrum Orbit stack or other stacks, but it is very difficult to make cross-framework right now. And of course, it would be great if we can all do it cross-framework. But this, unfortunately, is a bit harder. But there's also some solutions to like the centralization of block building, like Merkle trees and stuff like this. It just makes it much easier to verify the state of other chains, right? But this is all a couple of years out, unfortunately. So now, an example that I like to use to sort of, now this was the interoperability part, right? But what about these new smart contracts that just like scale, right? How are these actually being built? And so let's imagine we have a perp DEX. And let's imagine this perp DEX actually consists of 2 chains. One chain has all the assets in the world that are traded against USD, and then one chain has only ETH versus USD that you can trade there, right? And because ETH-USD is the highest volume pair with the most trades, it needs like its own chain to really sort of satisfy the demand of the users. And now what happens is that Paper, a meme coin you might know, starts really going crazy, right? And a lot of people want to buy and sell Paper, right? And the virtual machine of the long tail USD L2 really gets to capacity. What we can do is we can dynamically spin up a new equal virtual machine, being like a layer 2, and we can migrate the state of Paper, USD, all the assets, all the orders and everything. You can think of this as like an on-chain order book to this new chain. And the users will just like sort of send transactions via like some API probably, and it gets routed always to the right chain. Assets can be moved freely between them. And now we have a dedicated virtual machine which only handles Paper USD, right? And now the system scales again, and everything works well. Let's say Paper volumes go down again. Now Paper, no one cares about Paper anymore. Everyone sold it, and we don't actually need this dedicated instance anymore. What we can do is we can, again, with like an off-chain worker that does this, that monitors like the loads and so on, we can migrate the state away from these new L2s back to the old one, to this general purpose one, where you can think of it as like the hub, right? And we can spin them down, so we can deprecate these chains. And now we are back to only two chains. You see it's very similar to like horizontal scaling and Web 2. What do we actually need to sort of like build this out and make it work? We need to abstract away the complexities of managing state from developers across many L2s in sort of like this elastic, dynamic way. There are some ideas around this using distributed hash table libraries and so on, but yeah, this still has to be built, right? This is the complex part. We need these off-chain systems that actually like monitor the loads that these systems are getting, and the capacity limits, and then spin up new chains and sort of deprecate them again. We already have a lot of this at Gelato by having to service a lot of layer 2s in production that sometimes like get 10x the usage for an NFT drop in a moment, and we have to replicate instances and spin up new VMs and so on. But this has to really happen with like new chains that are then migrating states, so it becomes much more complex. And this whole system has to be done in a way where it sort of works well, it resets itself, it heals itself, right? Every time there's a new chain deployed and there's a new chain destructed. This probably won't work for all the applications, right? I'm not saying this will solve everything, but it will definitely, I see a lot of use cases like on-chain order books where you can split via pairs, or you can even split between pairs, right? Or you can have certain engines that only focus on deposits and only focus on sort of trading and liquidations on like different shards. But yeah, it requires a lot of additional tooling and has to be built. And yeah, of course, it would be great if we can harmonize it between all the different sort of clusters that are being built right now. I think Vitalik today said he's not really happy about having 5 separate solutions for 5 sub-ecosystems. That's needless fragmentation. This is kind of like what is happening today with all these ecosystems being built in parallel. It would be great if we can find like a harmonizing way. Probably something around like ZK proofs at some point will enable this. But yeah, right now, basically, we have these separate instances sort of being built. And I actually believe there will be many, many more in the next sort of year or so. Yeah, I think that's already it. If I want to bring one point across, is this sort of new way of building smart contracts, not on one chain, but you have 10 chains behind a single application. And yeah, we are sort of experimenting with this. And so if you're interested in building, I don't know, the next Binance on chain that really needs infinite horizontal scale, reach out to us. We work together with a bunch of cool projects that are having similar sort of ideas. And yeah, thanks a lot for listening.
Thank you, Hilmar. We have a few minutes for questions here. Down in front in the blue shirt.
Hi, thank you for the talk. I actually have 2 questions, if I have time. So the first one is about the sequencer centralization. You touched on it already, that when you whitelist some chains in your dependency set, actually, you're kind of whitelisting the full dependency graph, right? Because these chains in the dependency set will have possibly different chains in their dependency set and so on. So does this mean that the sequencer actually, when they have to verify the inclusion of a certain initiating message, possibly that they have to verify the full dependency graph?
Yeah.
So which means that possibly you're not really scaling in a sense, like you scale with the number of chains in your dependency graph.
Yeah, you have to really be mindful of who you whitelist to this, right? You can't whitelist chains that have, I don't know, 100 different dependency sets to all sorts of random chains that you don't trust. So it has to be, especially in the environment where you have your chains interconnected with each other, you can really horizontally scale forever. If you want to use this to interoperable, like with foreign chains, let's put it, right, you have to be very selective. Otherwise, yeah, it grows in terms of the workload that you have to do and the remote chains you have to verify. And this leads to centralization of block building.
Whitelisting is also off-chain, like it's nothing on-chain, right?
Yeah.
In the future, they could whitelist someone else, and then you're kind of mindful for others, so let's put it in this way because you could.
Yeah.
Okay.
DOP, like how Optimism actually tries to solve this, they have like the governance, right? And they have this governance layer where they actually decide what to whitelist and so you will probably have these enclosed environments where you interoperate rather than just letting everyone go crazy.
Yeah, that makes sense, yeah. I have another question if nobody has another question.
Go ahead, please.
So this chain-on-demand approach that you presented where you spin up another execution layer whenever there is need for it, wouldn't it be simpler and maybe equivalent to just, let's say, increase the gas per block, maybe with some protocol to increase it for specific applications, but without spinning up new chains, without migrating the state, just having a more flexible, gas economy, let's put it this way?
You mean vertical scaling?
Yeah, I mean, in the same chain, the gas per block can increase dramatically. I mean, this cannot happen now. I'm saying, would it be equivalent?
Yeah, so it's vertical, like basically vertically scaling single instances, right?
In this sense,
yeah. So there are two approaches to scaling, right? Vertical and horizontal. Vertical has its limits eventually, right? You can't vertically scale forever, and so you will at some point hit a threshold that you can't go beyond. It will become also increasingly tougher to verify this particular chain for everyone else, right? Whereas, like, if you just want to verify this particular chain, everyone can still do it if they don't need to verify all the other dependencies. And so, yeah, in Web 2, you also don't have a single server for Amazon that has everything, right? Amazon scales horizontally, and there's probably a reason why we believe this might be the superior architecture.
Okay. But in a sense, it's the same problem. Like you're centralizing, that's the same trade-off, kind of, right?
Like,
that you get.
with today's block building and verifying everything will become more and more centralized. It is already happening, I would say, yeah.
Thank you.
Another question, the white shirt.
Hi. Thanks for the talk. I think you mentioned that in the example, the use case, but I just want to ask again, see if I understood correctly. How does it actually solve the liquidity problem that we have across layer 2s today?
Yeah, so basically, in this model where you have the native interoperability between multiple chains, you can spin up new chains and atomically move over assets in, like, I don't know, a second, a block or something, to the new chain and then conduct all the trading there. As soon as the chain is no longer required, you can reconsolidate the state back. And the state means the balances and all the assets, and i.e. all the tokens via like mint and burn mechanisms back to the other chain and then deprecate it. So it has native interoperability, i.e. native bridging in there. And then with the shared sequencing on top, you have composability where you can actually sort of do the mint and burn and like atomically across different L2s.
Yeah. Any other questions out there for Hilmar? All right, give it up for Hilmar. Thank you so much. And for our next talk, for the final talk of the day, we have a talk from Austin Griffith. If you remember the XDAI days and ETH Denver, then you'll remember the burner wallet. And Austin is going to give a talk about building decentralized apps quickly. So give it up for Austin.
Okay, just a great job.
Thank you. Yo, what's up, everybody? Last talk of the day. How's it going? Got a few people in the crowd? Yeah, I still got some excitement. The beer started over here already, I think. Okay, yeah, I'm Austin Griffith. I'll be talking about building decentralized apps quickly. And usually I do a workshop. A lot of times I'm sitting here with a laptop building something, and I kind of assumed that's what I was going to do here. Then I found out I needed to do a presentation. So I'll do my normal coding workshop, but via slides, kind of in the middle of this. But I work for the Build Guild DAO. And we do a lot of things in a lot of different areas, but the TLDR for building apps quickly is use scaffold.eth, and I'll get into that more as we go, but let's zoom out a little bit and let me just give you a little context about the Build Guild and where we're focused. So the Build Guild is a Wyoming DAO. It consists of, who knows, I think we have like 1,000 members or something like that have joined. But these are the three pillars. We focus on education, tooling, and grant giving. And let's kind of dive into each one of those. In the tooling section, I will go through how to build decentralized apps quickly. But I thought, let's do some slides and let's give a higher level picture. So education first. We do a lot of education. We focus on onboarding. We want to bring as many developers on board as we can. We're kind of finding that, yes, price action brings in developers. As sad as we want to be about it, like people want to program money and they think they can make money programming money, and you probably can. And I know that's going to bring you into this space, but once you land, you're going to learn so much more, and you're going to pick up the ethos, and you're going to find out about what makes Ethereum special. So getting you down that rabbit hole is our job. And the farther down the rabbit hole you go, the more likely you're going to stick when that bear market comes around. So we want to get you all the aha moments as fast as we can. We want to put a little ETH in your hands, and we want to incentivize you to prototype. And Speedrun Ethereum spends a lot of time really focusing on those aha moments, and we built this curriculum in a way that will give you those aha moments. I've done a lot of one-on-one mentorships and tried a lot of things and found these moments that work. One example is a Web3 cron job is different from a Web2 cron job. It's not just something that checks in every hour from a computer. It's the rules, but also the incentives. The incentives are very important. If you create a system with the right incentives, you'll get people to always check in, and your cron job will run no matter if your server has fallen over or not. And that's just a small example of one of those things that we teach and we want people to learn as they come in. You'll take on the NFT challenge, deploy that cute little buffalo. Then you'll take on the decentralized staking app. You'll learn about the superpower of Ethereum is giving you, the builder, the opportunity to build, write the rules of a system where people can coordinate together to achieve some goal. In this case, it's getting some funds together to then spend them on something else. But you learn a lot of those rules, and if you build this correctly, the players of the game only have to trust the code. They don't have to trust you, the deployer. In fact, if you deploy this thing correctly, not even you can stop it. And I think that's an interesting power of Ethereum smart contracts. Then onto the token vendor. You learn about ERC20 tokens and the approve pattern and contract-to-contract interaction. Then the dice game, you learn about randomness, which is super hard on a public deterministic blockchain. Then on to the DEX, right? You learn about hyperstructures and how to create expansive apps that have fee systems built into them that go to LPs and what all of that even means, right? And then eventually you get the opportunity to join the Build Guild, and we provide more mentoring, which I'll get to when we get to our batches program. But I wanted to zoom in here. This curriculum is not a copy-paste curriculum. You cannot just follow along and learn. You need to actually write Solidity, and there's a lot of moments like this where it's like, okay, you're gonna need to create a mapping named balances, and you're gonna need to create a threshold set to 1 ETH, and then you need to write the function where someone stakes, and they make sure that the threshold is reached, or you update the balances, right? You're gonna have to write the code. We just make it really
good and clear, and there's good debugging for you. We've built a lot of debugging into it so you can really understand what's going on and try to make it look nice along the way. And then you'll build up your Web3 portfolio. As you build these things, you'll have a whole list of these cool concepts that you've conquered. And we have an auto grader, so you'll turn in your smart contracts on chain, and we'll go look at them and run them in our own isolated environment and make sure that they're correct, and then you get awarded that it was accepted, and then you unlock more challenges. So that's the education wing of Build Yield. We do lots of DevRel. We just held a workshop today. We had a workshop. We had 20 or 30, maybe 40 people in there. And we basically went through some of the challenges of speedrun Ethereum and some of our tooling, which I'll get to next. So Scaffold ETH is our main tool. It's built by a kind of an inner circle within the Build Guild called the Sand Garden, where we focus on making very intentional apps. And what we're finding is Scaffold ETH is kind of a starter kit of starter kits. We're seeing lots of people fork Scaffold ETH 2 and use it for interesting things. We were using the Scaffold Base earlier today to deploy an app on Base, and really it's like 15 minutes of work to go from Scaffold ETH to Scaffold Base, but it's just nice to have that little push in the right direction. We're going to select a chain for you. When you do a yarn fork, you're going to fork mainnet Base. Just some nice things that come out of the box with a starter kit. Okay, building decentralized apps quickly. That's technically the title of this talk. And let's pretend I'm giving a workshop now, because there will be some screenshots and I'll be coding away. But let's start with Scaffold ETH. We go to scaffoldeth.io, and then you can copy either one of these. You can clone the repo, or you can do this npx create ETH. And npx create ETH gives you kind of a choose your own adventure. And we're going to add more templates for different things and more extensions for adding new things to your app. But at first, the first question is just hard hat or Foundry, right? It's still kind of a, people will argue, but it's still kind of a 50-50 thing. And so we want developers to be able to choose between the two. I'm selecting Foundry here, and then it gives you, it kind of installs things, and it gives you the option, or it gives you the hint that you need to go run these three things, right? You need a CD into your directory, then you need to yarn chain to spin up your Anvil, then you need to yarn deploy to deploy your template smart contract, and then you yarn start, and that'll start your dev server. So I have all three of those things here. You can kind of see the chain on the far left, and then in the middle, there's your dev server, and then on the right there, I've already deployed my contract. And this is what it looks like. You get localhost 3000, you get Scaffold ETH, and it's a web app ready to go. It's going to handle things like your wallet. It's going to handle things like if they're on the wrong network, it nudges them over to the right network. It's going to have all these nice little components, like this address component, where when you click on it, it takes you to the block explorer of whatever network you've set your app to be on. It's just something that we've built lots of apps, and we've gone to hackathon after hackathon, and this is our starter kit. This is what we like to build. When we go to prototype, when we go to build an app to prove that we can make something work, we're grabbing Scaffold ETH every time. A lot of times I'm doing it on camera, too. And this is the, what is this? What do we got going on here? I feel like maybe I went too far. Yeah, Scaffold ETH. Oh, maybe this is the debug contracts. So if you click the, I think, yeah, you can't, I can't see it on my screen, but you can see it up here. We were on the home page earlier, now we're on the debug contracts page. And this is a critical page. So this is going to auto-adapt to your smart contract. As you add things to your smart contract, yarn deploy, they'll show up here automatically. And this allows you to tinker with your contract and test your assumptions and try things out. Maybe you don't know exactly what you want your smart contract to do. You know, am I going to use an array? Am I going to use a linked list? Am I going to use some kind of struct? Sometimes you need to tinker with your Solidity a little bit to figure out exactly how you want it to work. Scaffold ETH is great for that. You can just sit down and try things and test your assumptions. So let's pretend like I'm adding some code. I get into my Foundry smart contract, and I'm going to add a beneficiary, right? And then I'm going to add a set beneficiary to it. By the way, the contract that comes with Scaffold ETH is like this classic greeter contract where there's a string that's saved, and you can add a greeting to it, and that'll go on chain. But forget about that. I'm just right at the top of that. I'm just adding in some extra code here. So we had, if we remember back here, there's a greeting there. It looks like someone has set the greeting to building unstoppable apps. There's an owner. Then what I'm going to do is add this beneficiary and add this new set beneficiary function. And as soon as I hit save and deploy that locally, then we get this set beneficiary function, and we see the beneficiary is the 0 address. So right after we write the code, we can see this right away on the front end. And we say, OK, so beneficiary starts at 0. I've got this function. And let's make Vitalik the beneficiary, right? So I type in vitalik.eth. It does the ENS resolution for me. It gives me a nice ENS avatar. It shows me his address and blocky. And I hit send, and it sets him as the beneficiary. So I say, OK, my code's working. Basically, the owner can set the beneficiary, and it works. And then what I want to do is try the inverse of that. Can a bad guy get in here and set the beneficiary? So I come in as a second account, and I'm using burner wallets here. They're basically private keys in local storage, great for local debugging. With a new burner wallet, kind of like our bad guy burner wallet, I fund it, and I get in here and I try to set the beneficiary to atg.eth, and it complains, not the owner, right? It throws an error back to me, and I've tested my assumptions. I've tried as the good guy setting the owner, and it worked, or beneficiary. As the bad guy, I tried setting the beneficiary, and it didn't work. So now we know that is owner modifier is working, and we're testing our assumptions, and of course, these are not exhaustive tests, but they're great for quick tests to kind of test your assumptions and make sure it does what you think it needs to do. So let's just pretend like the contract does what it needs to do. We've tinkered with it. We got it working. Now we're going to move on to the front end. This is kind of the second phase after tinkering with your smart contract. It's starting to build out some of those damn React components. And so here's our home page, and I've cleaned some extra stuff out of there. And then I'll get into the Next.js app, right? Everything we've been doing so far is kind of over in the Foundry folder. Now we're going to move over to the Next.js folder. Now I'm going to get into the app, and I'm going to use a hook. And this hook is built on top of WAGMI. We use WAGMI, V2, and Tailwind, and Daisy, and VM sometimes. But you can go look at all those docs as you're building your things. But what we're doing here is we're doing a contract read. What I want to do is read from the contract and keep that state in my front end. Use scaffold read contract will do that. I give it the contract name. Then as I type in the function name, it just gives me this autocomplete. And this is really important. It's looking at my smart contract over there in the Foundry world and giving me a hint about what function I want to use. I didn't write hardly any of this code. Between Copilot and the suggestions, I'm basically hitting tab more than I'm hitting anything else. And then here we put we get the beneficiary at the top and we store it in our state. And then down at the bottom, we're going to output that beneficiary. So what does that look like? There it is. OK, cool. We've got our beneficiary there, 0xD8D. Very ugly, right? If you want to make this look good, let's take that beneficiary and let's chuck it in one of those address components that comes with scaffold ETH out of the box. Oh, that looks much better. You got that ENS avatar, you got that ENS name, you got a little clicky copy button. Very nice. And I guess Vitalik is the beneficiary. So what if we wanted to build a front end to allow us to update that, right? We're going to need some kind of input. Scaffold ETH has an address input. When you're building apps for Web3, you're going to need addresses. You're going to need address inputs. These are kind of new components that haven't really been around before. Scaffold ETH has all of these out of the box. So you'll notice I have some state new address, some on change that updates that, and then it gives me that nice text box there. So I type in atg.eth, or I paste in some address, and it gives me this kind of nice ENS avatar, ENS name, blocky, all of that stuff out of the box. OK, so we've only read from our contract so far in our React. Now we need to write back to our contract, right? Again, we're going to wrap that use write contract from WAGMI, and we're going to use scaffold write contract. Just does some extra things with the wallet and some extra abstractions. But look at this, we create this write your contract component, and then I can call write your contract with a function name, and it's gonna tab complete. When I do that first little quote after function name, it's gonna give me a list of all my functions. I choose set beneficiary. Then for the args, I pass in that new address that we've been tracking in the state, and we get this nice little button, and I type atg.eth, and I hit set beneficiary, and Vitalik's sad because now I'm the beneficiary. Awesome. Okay, so we've basically built our smart contract. We've added a beneficiary system. Then we built our front end. Well, we kind of built our smart contract. We tinkered with it in that debug page. Then we moved on to writing our front end. And now I'd say we're pretty good. It's pretty ready to go. Let's deploy this thing. So to deploy an app with scaffold ETH, you do a yarn generate, and that creates a deployer account. You're going to keep it in a specific place where it's already get ignored. You would have to try hard to commit this thing to Git, right? We see developers accidentally commit private keys now and then. This is a one-time use private key that lives just in this directory that you're going to fund with a burner wallet or something with just enough money to go to deploy the contract, very isolated and hard to screw things up. Then you do a yarn deploy, but -- network. So you've been doing a yarn deploy locally, trying things out. Now we do yarn deploy -- network Gnosis, and we deploy our smart contract to Gnosis. And then there's one more change we need to do. We need to tell our app, who is currently pointed at the Foundry local chain, hey, let's work off of Gnosis. We type in chains.gnosis, and our whole app now switches over to Gnosis. You see it in the top right. If I click any of these addresses, now it's going to take me to the block scout, the Gnosis block explorer. And let's see, I probably type in atg.eth, and I hit set beneficiary, and we see the transaction is successful, and then there we go, I'm the beneficiary. And that was all on-chain, right? This was all on Gnosis. So the last piece we need to do is deploy that front end. This is the most fun command, yarn vercel YOLO prod. That's how I do things, right? And that sends your app all the way to Vercel. I think you might have to get in there and change a setting now to say, hey, make this public. But after that, you get a URL, and anyone can go to that URL, example, Berlin, DApp, something, something, something. They can connect their wallet, and they can use your app. And that's the most important thing. You're able to write a smart contract, tinker with it, and make sure it works. Build a front end, deploy your contract to a public chain, deploy your app to a public server, and then anyone can go to your app and connect their wallet and use it. So that's building decentralized apps quickly. You really can, although these were just screenshots, I promise you really can build an app in like 40 minutes with the right knowledge. So that's our tooling. And then I'll finish this off with some cool things that are happening within the Build Guild. So in the grants area, we started with ETH streams. It was this smart contract right here. And this smart contract is different than almost any other streaming contract you'll see. First of all, most of the time it starts full. I trust you. I'm going to deploy a contract. I'm going to load it up with some ETH, and I trust you to go build what you think is best for the ecosystem. And you can withdraw from this smart contract. The other weird thing is it sort of pauses when it fills all the way up. And this is something we noticed. Most Ethereum developers start as nights and weekends developers. Maybe you're around and you're doing some cool contributions, then you get busy with something else. That's okay. If you disappear for a while and come back, your stream will be paused full, waiting for you. And so I started streaming to a bunch of people. I, like an idiot, deployed that code that you just saw to mainnet like 100 times. Shouldn't have done that. But we're supporting a ton of devs with these ETH streams. And then we were like, well, we kind of want to do this like group stream thing. So at the same time, we had Build Guild Labs, which is kind of like a DevRel, more over on the education side. But toward the end of this series, we were like, let's build a streaming smart contract. And these bottom three things are building that streaming contract. Here we are live. Looks like Edda's a little stressed in the last one. Sorry, Edda. We built this cohort streaming that lets you stream to a group of people. And then we really leaned heavily into Jesse's hacker house and all the really great hackers that Jesse was finding. And then even our internal group, the Sand Garden, started using this to fund their builders. So we partner with some ecosystem heroes. We have a huge list of these things, but grants is really the best way to go. We started giving small grants, and with those small grants, we've streamed over 772 ETH, and that's it. That's Build Guild. We're education, tooling, and grant giving. Thank you.
Thank you so much, Austin. Great to see the evolution of Build Guild. And we have a few minutes for questions for Austin, if you're up for it. I know it's the end of the day here. Any questions for Austin?
There were also more slides there. I just stopped because my timer ran out.
Oh.
That's okay, though. Could we bring the slides back up? I could show off a little bit more, if that's okay. If I have an extra 5 minutes.
Yeah, let's do it.
Yeah, everyone's out like, I want to go get a beer. Come on, man. Yeah, okay, so then Build Guild has this back office where we control everything. This is like our app, and this is where we can see kind of all the recent builds from all the builders. We see the activity, what people are posting, what they're up to. We can even see stream withdrawals. Every time someone withdraws from their stream, we get a sweet update about what they're working on. Looks like Hunter added a default frame to Scaffold Base, and he's working on the burner wallet. That sounds exciting. Okay, so we noticed something within the onboarding process where we were kind of a little bit too quick to give streams, and we needed something in the middle that gave us more feedback about a builder, and that's where the batches program came from. And really, this came from Carlos and the Sand Garden. They were like, let's build this thing, and I was just really excited about it as soon as I heard the idea. But basically what we do is we advertise to you within the Build Guild app, which, by the way, none of this stuff captures information about you. You connect your Web3 wallet and you share what you want to share. We never take your email. We never do any of that shit. So it's all like very Web3 native. But we do throw up an advertisement to you now and then and say, hey, come join the Build Guild. You've learned how to build a token vendor and a staking app and a dice game and a DEX. You know enough to at least start asking the right questions, right? You're not the blind man feeling the elephant anymore. You've got a pretty good idea that you have a lot to learn, right? And so now we can be a little bit more one-on-one with you, and we can spend more time with you. We're gonna bring you into a Telegram group with like 20 other people, and we're gonna circle up around a GitHub repo. So we're gonna teach you Git etiquette. We're gonna teach you how to make a PR. We're gonna teach you how to contribute to open source, just to make sure you know how to do it. There's a bunch of challenges here where it's more about just making sure everyone knows how to contribute to open source and everyone can make PRs. And then the builders kind of set their own page. Like for each batch, we sort of have a website for each one, and they can kind of control what that looks like. And then as you go through the Build Guild, this grant system is open to you. Anybody, once they go through these batches, once they join the Build Guild, can connect their wallet and say, hey, I want to build this thing. And that's going to show up to us, and we can choose whether or not to YOLO you half the ETH to get started. Some apps that are coming out of Build Guild. We do a lot of prototyping and building. ABI Ninja is one of my favorites. You can give someone a link to ABI Ninja, and basically what it's going to do is you tell it the contract and the network and then what functions you want to show, and it's going to do an automatic front end for that smart contract. So in this case, I'm talking about the DAI stablecoin on mainnet Ethereum. So whatever that address is, /1 for the network, and I want to show them the balance of and the transfer function, right? All of that is one URL that I can share to someone. They land here and they basically get this view. And you can see I put in Vitalik's address and read that he has 1818 DAI. And then I transferred to Patricio, I don't know, 10 DAI or something. Another app that we have is Hacked Wallet Recovery. This is another community-built app from within the Build Guild. Sometimes when you do leak your seed phrase, that ETH gets swept, but sometimes there's remaining assets that the bot didn't sweep. What you can do is use Hacked Wallet Recovery to create a Flashbots bundle. And that bundle is going to never land in the mempool. It's just going to fund your hacked wallet, pull out the assets you need to a safe wallet, all atomically without hitting that mempool, and lets you sweep your assets out. Address Vision is another fun one. You go to address.vision, you put in an address or EMS, and it's going to tell you all about that address. Even if it's a safe, right? It knows if it's a safe, and it knows what the threshold is, and it knows who the owners are. Just a really nice, quick way to look at apps. And then the Punk wallet is kind of a predecessor of the Burner wallet. It's got all these different networks and all these different tokens on these networks, and it's a quick app that you can build with. There's a lot coming soon from the Build Guild. Call to action, if you're super rich, YOLO 420 to the ETH. If you're not, go build something that will get users. If you're not even a dev, tell your dev friends to go speedrun Ethereum. Thank you. I'm Austin at Ethereum. Hit me up. My DMs are open.
Thank you, Austin. We didn't even talk about Nifty Inc. I was hoping you were going to talk about that one, but thank you so much.
I talked about Nifty Inc. like DappCon 2019. I was talking about the idea of an app that pays for the user's gas, and you come in and you provide value, you create something first, and then later on you sort of start worrying about your seed phrase and your account. That's what Nifty Inc. was about. And I was talking about it then, we built it and deployed it, and it kind of, all that meta transaction stuff sort of led to Yoav and GSN doing all that cool stuff, and that was like kind of a predecessor to like early account abstraction stuff in 4337. They did all the work. I didn't do any of that stuff. I just prototyped early versions. But Nifty Inc. was that. Yeah, thank you.
Thanks so much for the talk. All right, everyone, enjoy the rest of your evening, and we'll see you here tomorrow.